Well, good morning. Welcome to Sebastian Dive number 625 here on the Octopus Odyssey 2. I'm Andy Fisher in the chair. I'm a hydrogeologist from the University of California at Santa Cruz. And I'm out here with Ru Akiba, who's a graduate student. And we're on a mission to make heat flow measurements through the sea floor. Heat flow measurements are basically determinations of how much energy is coming out through the bottom of the ocean, coming from the earth below and up into the water. And we do this with a fancy thermometer, essentially. It's called a heat flow probe. We insert it into the mud and we let it equilibrate. And we calculate how much the temperatures change with depth. And then we fire off a heat pulse and watch that heat dissipate. And that tells us about the thermal properties of the sediment. Those two measurements put together allow us to determine how much energy is coming out from inside the earth. And the reason that we're interested in that in this area is because the amount of energy coming out is related to the amount of water that's moving through the sea floor underneath the sediment. In this area, the sediment is a few hundred meters thick. You can see it looks like a kind of a brownish green clayey layer. You can see that out in front of the vessel. At greater depth, it's mostly a white carbonate ooze, as the sediment is known, made up with primarily with the bodies of microorganisms that have fallen out through the water. But underneath that is layers of a volcanic rock called basalt, and some of that was deposited in flows and lobate pillows, as they're known, and chunks of rubble. And that's a very open kind of an aquifer system. Water can flow through. Right now, our pilot is testing to make sure we have plenty of soft sediment. So they're using the test probe and just going to push it in here. And this probe is about the same length as our heat flow probe. This is not our heat flow probe, but it's a test pole that we'll use just to make sure that the bottom is plenty soft here and we're not going to be surprised by hitting hard rock. We can see it's going in pretty smooth. On other remotely operated vehicles, this would be the mechanism by which we would insert the heat flow probe. But here on the Sebastian, operated by Schmidt Ocean Institute, they have a mount for our heat flow probe on the side of the vehicle. So we're going to actually insert the probe off the side, but they're going to use this test probe also to help kind of anchor and hold us steady here. That way we don't vibrate around too much from the current. So you can see all the material in the water column, and there's good currents around here. Looks good.
We're happy when you're up. Do you want to put that screen up onto here?
Yeah, we should probably do that while we're putting the probe in, huh? Yeah. So we're gonna switch the view now and look at the side of the vehicle, and you'll see the tip of the heat flow probe. Right? We're gonna actually make a few measurements before we insert the probe, just to get the background conditions.
Okay.
Do you want to hop back here?
Oh, great. Thank you.
I don't want to.
Are you?
Yep. I'll hand off to Beth Orchid now, our chief scientist.
Thank you, Andy.
You want to put in the numbers and look at
Actually,
it?
Yeah.
There's one happy back there with that one.
Are you pardon?
Oh, if you're happy there, yeah.
Yeah,
If you
we're
look-
good. Yeah, this is good. This is good.
So,
So what I'm going to do here is first make a few measurements, just like a background calibration.
Sure.
And then I'll close the file, open a new file.
Okay.
We'll get a few seconds of lead in, and then we'll be ready to go. So
Okay.
it'll be about 2-3 minutes.
Yeah, no worries. How do you want the speed? I know I checked it yesterday and it looked like it wasn't quite as fast as how Rachel was doing it.
Yeah.
I can bump it up a little bit if
Yeah.
you want the speed to.
When we process the data, we assume it's instant. So whatever's sort of the fastest you're comfortable with,
Okay.
that you can go. Just
Without touching the dirt, can I just give it a little wiggle right now, or will that mess up your data?
you can give it a little wiggle.
Okay.
It's all right. Just not too much.
Yeah, not into the dirt.
So I'm going to start this as a, I'm going to call it cal.
Okay. Yes.
So we'll do a measurement here. Do this HF. And you can mark that off to the side or something. It's
Okay.
not an official file. It's not a penetration, but it's just. This will be number 1. Okay. Cal. Very good. This will be a good test about before we actually get the penetration really. Okay.
Yeah, just
Okay.
publish it at 75.
All right. Welcome to our world. Yeah. That's true too. Well, we'll be counting on our watermark to save us. You know, the Alvin probes like this are made in 3 lengths. There's a 1 meter probe, a 60 centimeter, there's a 30 centimeter probe. So, they have them shorter. And in principle, if you're in deep water and the temperatures are really steady, you can use the shallow probe.
Yeah.
In this case, deeper is better. We're giving up 15 centimeters to get that bottom water. Yeah, so this is what our record's looking like, and you can. Yeah.
Yeah, I saw that.
Yes, there was one yesterday. It was pretty cool.
I'm just going to wait another 10 measurements here, and then we'll close this file. All right, go ahead and close this. So you can stop measuring now. It's about 2 minutes. Okay, I'll open up the new file. And do this.
So, for our audience tuning into our video, we are currently in the abyssal plain,
And wait,
off
Yeah.
a few hundred meters away from the.
So Adam, we're gonna set this with a time delay, so it'll automatically fire its heat pulse.
Okay.
And I'll give it like 9 minutes. So we're 8 minutes. So we'll wait a minute here, and then we'll go. So we're gonna start it, and then I'll give you say let's wait a minute, and then we'll be ready to go.
You just tell me when.
Okay.
So, in the background, you're hearing one of our scientists, Dr. Andy Fisher from the University of California, Santa Cruz, who is running a sensor on the starboard side of the vehicle called a heat flow probe that's going to make measurements of temperature in the sediments here to understand the thermal gradient in this area, which is an indication of how much heat is being transported in the rocks below the sediment. What you're seeing in the front here is just the arm of Sebastian holding basically a measuring stick that we use to probe the sediment and make sure it's not too hard.
And starting now. Oh, all right. We have to type it in here.
See, there's a good bit of current here, pushing some marine snow past the vehicle.
Test data. So we'll move those later.
Okay.
Leave this for now.
Do you mind if I
Yeah.
use the camera?
There you go. Yeah. Start it right
The quarters in right here.
Okay, we are logging. We're going to wait about a minute.
Yeah.
Vortex.
Is it, Carl, is it possible to put a picture-in-picture to show the heat flow probe on the live
It's
stream?
already lifted off when I probed in because there's like a hard layer.
Oh, you're
There we
right.
go.
Ha! I'm looking at the
So I
wrong
really wanna
screen.
make sure we're getting a good push without any resistance.
So y'all already tried it.
We're gonna do it in a minute. So. Yeah. So yesterday we were so light, and I noticed there was almost like a layer of almost like clay.
Yeah.
I saw when we came out. So when we pushed down, it actually pushed the vehicle up a bit.
Okay.
And then it penetrates. So right now we've got quite a bit of downs. So
Yeah.
we're hoping that we're just a straight shot in.
Got it.
I think you'll get a better
Got
result
it.
like that too.
Yeah. You know, part of it, there's this hemipelagic layer here that's relatively thick, but in some places right close to the outcrops, it's been scoured away. You almost get into the carbonate right away, and that stuff is stiffer.
Right.
I remember that from pouring.
Yeah, because remember we pulled it out, it almost looked like whatever was stuck to it.
It was stuck to it. Yeah, that carbonate's really sticky.
Yeah.
Yeah. All right, so we're ready now to insert the probe. Let's just go in smooth, and we should be stopping based on the position with one of the sensors up out of the mud.
Okay, so not all the
Well,
way.
the probe's been moved up just a little bit.
Yeah,
So you
but-
should be able to, yeah.
I suspect because the top layer is so.
We might be a little deeper.
Yeah. So
Yeah.
what I'll do is I'll stop before the cone hits.
Exactly.
Yeah.
Let's give it about 10 centimeters, give or
Okay.
take.
How about that? You tell me where to stop.
All right.
Okay. You ready?
You can respond that quick.
Oh yeah, I can.
Okay.
All right,
We're
here we
good.
go.
Yep.
And coming down.
We're in now.
Yeah. Now it's inserting.
And stop. A little bit, might be a little bit early, but let's just leave it.
So if you saw in the picture-in-picture there, the heat flow probe being inserted into the seafloor. So we're going to stay in this position for several minutes while, as we insert the probe, it creates frictional heat along the sensors. We have to let that dissipate. And then we'll send a pulse of heat down the probe, and it'll heat all the sensors back up again, and then they will dissipate that heat again. So the whole measurement takes about 15 minutes. So we'll be sitting here for that period of time, and let's have a look at the seafloor and see what's here.
Probably went up 3.
So right in front of us, looks like we have a brittle star.
We have probably do want to be about another few centimeters down.
Yeah, because I think you probably,
Yeah.
that's probably 10 centimeters.
But that's all right. This will be, we're still considering this a test, and we'll see what we get.
Okay.
But yeah, we'll probably go a little farther on the next one.
Okay.
Can we get lasers on, please?
Sorry.
Is your noise looking any different or about the same?
No, it's the same. That was, we got down to the bench.
So these green dots at the bottom of the screen are an indication of
That's what we got.
the distance of 10 centimeters. So that gives you an idea of how big that brittle star is.
So, but, when
Is it
yesterday
possible
Rue
when we
took
bring
this
the
data
vehicle up to like
and
try
just
to push the lasers
took
up
the
so they're more
shallowest
centered?
measurement and subtracted it from the others, and everything just smoothed out.
Behind the
But
brittle
some
star,
kind of-
we
some kind
see what is most
noise
likely is
uncertainty
Falkor.
that's affecting all the sensors, but it's also affecting the temperature, because these should be around 2. So everything is offset and noisy. And we think perhaps by just referencing to the bottom water here, we can subtract that effect out.
You mean the highest one?
The
right?
highest one, yeah. Normally with this tool, we don't have a bottom water, because we push it all the way in, right? But that's what we're gonna try.
Noise cancellation is nice.
we'll see. That's the idea.
So even though they're quite large, these, well, relatively speaking, these uniphyrophores are a type of unicellular foram, benthic foram,
Compared to the others.
and they
So there we have
aggregate sediment into their
something in that range.
body material,
But
so
here,
they-
this difference.
quite large, visible to the naked eye, whereas most forams are quite a bit smaller.
About 100
You can see several of these uniphyrophores on the seafloor, these little aggregations of mud.
Normally I'd make up an index card, or hold something up here, just take a reading and estimate the area. At this point, it's hardly worth trying to do that.
And even though they don't necessarily see a lot of life on the seafloor, things walking around, you can see evidence of life. You can see some of these pellets left behind by animals who are moving through the sediment and consuming sediment and getting nutrients out of the either organic carbon or little animals that live in the sediment and leaving behind trails. Likewise, these little mounds are indications of animal activity in the seafloor.
That doesn't make any sense.
This one's not going to come into view so far well because it's a little bit out of our field of view.
There's a big correction here, right? So already the yellow one was warmer before we even went in.
Yeah.
So that's going to end up being corrected down.
Yeah.
So it's
Carl,
gonna
do you
say-
mind putting up
It also
the
can be
map
the
as an
bottom
inset
water
in the live stream?
Can be stratified.
Thank you.
It's not unusual that there's a boundary layer right at the seafloor with a little bit of a different temperature.
We can turn lasers off, Adam. Thank you.
So this will go at measurement 240, right? That's seconds. Each one of these is 2 seconds. Tornado. It's like the surface of Mars.
Just have a little bit of zen here, watching the water go by. What is that little tornado coming out of the top? Is that just the way we're sitting in? It's,
Just sucking dirt through.
yeah, it's funny.
I really see the
Oh, so it'll only cool if the frictional heating is high enough. Otherwise, if there's very little friction, it'll just rise. So, and either way, that shape follows the balloon function. Okay, so it gets modeled the same way. Oh, there's our heat pulse, just fired. That's good.
Looking good?
See how my camera skills are to see what this little organism is.
Nope, that's it. Now
That's
let's
a little
pull
too
that
small.
down. So yeah, it doesn't look like much, but if there was a nice rise as these went in, you'd see it better if it wasn't all chewy like
Yeah.
that. And now the decay from the heat pulse will give us the thermal conductivity of the sediment. Yeah. Yeah, and unfortunately, there's no way to avoid the heat pulse on the bottom waters.
Yeah.
So now you can definitely see that's in the bottom water, right? It's cooling.
Yeah.
It's cooling a lot quicker. The others are not. So it looks like this depth here looks pretty good.
Yeah, even though it's like in the last trimester?
Yeah, we want one in the water. So
Yeah.
what we're gonna do is use. There's one about right here. We're gonna use that one as a correction on all the others.
So next one, do you want to just insert just the tip of the bracket, or right stop right at the base of the bracket? So this is a bracket, so that basically it's sitting on here, right?
Yeah.
So if I go any further, this is now going to punch into the dirt.
Yeah, no, we definitely don't want to do that. I actually think this, from my mind, this is exactly right because we've got 4 sensors in the mud
Yeah.
and 1 in the water. That's what we want. We're going to use the water one to correct the other.
That's cool. Yeah, I think Rachel was putting the 5th one in, but yeah, if you like the water one, that's great.
Well, we do because we need the correction.
Right.
If it were all working smooth, we'd want it as deep as we could. In fact, even if you over-penetrate, it's fine,
Yeah.
right, normally. But in this case, we want this one. And that's the other thing. Once this levels out, we can now start correcting again.
Yeah.
Right? If this is back at bottom water, we can take it from there and just use the late data,
Yeah.
and that'll work. Okay, even if we don't get the pulse, because we don't actually need the pulse.
Okay.
What we want, the late data is often better anyway.
Yeah.
So I think
This
if
is
we
so nice.
if we divide the data up,
Same thing.
isolate that. The trick is we may end up having to play with that. We can do it with the tau window. We'll extend the tau window to be much later in time.
Mhm.
Okay.
Sure.
So we can figure out, like there, start there,
Yeah.
right? We can calculate that and figure out, but right now it's like 10 to 1.6 as the tau window. And instead we could start at like, 10 to 4, 10 to 5, something like that, right?
Yeah.
Because the smaller the tau, the longer the time.
Yeah.
Dimension. I think that's right. Dimension is longer time. Yeah.
Yeah.
Okay, so we did 240. This is, and in fact, that's a good reason to get a nice steady record here. So 360 will be about 3 minutes, right?
I haven't done it. I'll do it after my shift.
A good 6-7 minutes. That's the
Sure,
other
if
thing.
you want to.
When the record here
It's right in
is
front of the keyboard on
essentially
my
flat,
little sitting area.
then
It's like 3 pages. And there's a
the-
thumb drive on it
the
too.
system may have a hard time finding the minimum error for the misfit because it's just a straight line, it's just a flat line, right? So then all the parameters skate around, but it doesn't matter because the extrapolation is the key.
Yeah.
And if that's extrapolating to no deviation for the correction, it's fine.
Yeah.
So this may well work.
And the heat pulse in the center, because the temperature is high, the noise gets a little bit.
Ben, do you want to say
It
something
looks like
about
there's
the maps?
less of it.
Oh, yes, thank you so much, Carl.
Oh, it probably is.
So
Oh, yeah.
But
the map you can see in the live feed shows you what we refer to as Caballito seamount or outcrop. Doesn't have an official name yet, but this is a name that we are proposing as our group. The little white line on the left side is an indication of kind of where we are on the seafloor. So you can see that we're out in the abyssal plain off to the edge of this feature. Our dive plan today is to move towards the edge of that outcrop. We're going to take another heat flow measurement on our way to the edge, as well as some sediment push cores. And then we're going to work our way up the side of that outcrop, doing some transects to quantify the animals that are on there. We'll be stopping occasionally to collect specimens, and then we'll be working our way up to the very top, that ridge on the left-hand side, which we have not explored yet. We explored the southern end of this feature, which is in the background view, on our last expedition in June, but we haven't actually been to the true summit of this feature yet. So we're going to be going up there to see if there's any indication of venting, if we find any octopus, but also just understand the diversity of life in this region. In the far background, on the left side, you can see we have a nice little fish coming into view here. I'll have a look over there. Off to the left in that map view is a site we refer to as La Pulperia. It is the second known octopus nursery in this region. A little nursery on the southern end of that feature. And so we think that these two features are hydrologically connected, with water maybe coming into the seafloor here at Caballito Outcrop, and may be connected to water that's coming out at La Puparia. And so these heat flow measurements that we're going to be doing on this expedition will help us to understand which part of the seafloor is cooler, which part of the seafloor is warmer, and then we can use modeling to try to help us understand regional water movement and heat flow in the system.
Yeah, that's the heat pulse. So again, it's really noisy. We've
Thanks
left
a lot,
one of the
Carl.
sensors out in the water, and we're going to use that to correct the others.
So it sounds like what you'd expect.
Yeah, it looks like the heat flow is quite low here, which we do expect. Other measurements in this area were showing like 20, 25 milliwatts per square meter, really, really cold. And that's because that big outcrop, we think, is where recharge is occurring. So cold water is going in there, and it gets flowing to the smaller outcrop, and then that's where the water comes out and the octopus are breeding their eggs.
And we have a nice little shrimp coming into view here. Let's see if I can follow him around for a few moments.
That'll take us to another maybe 6 minutes. We might go 1 more minute.
Nope.
The more we get that equilibrated,
Didn't like that light.
better. Because, if we even get, if it's completely flat, that'll minimize the correction. Hello?
So is it working?
Well, it's very noisy, but we've left one of the sensors out, so we can use it for a correction, we think.
Yeah, I saw that at the review.
Yeah.
I think it's clear the
Looks like there might be another fish way off in the
That's heat
distance.
flow. So this was the insertion in the mud. The heat flow is very low. I mean, it's hardly warmed up at all. So, but that's consistent. Rachel's measurements out here were like 20 milliwatts.
So I heard you talking to the guy before, so you have a sea mount that is being used as recharge.
Yeah,
You do heat flow all around, you can see what is the closest part, you can sort of
that's the idea, exactly.
reach it.
That's right. That's right. And we can quantify that with modeling, but just qualitatively, that's right. If one side is cooler and one side is warmer, well then the colder side is where the water's going. Exactly. Right, it's a clue. Yeah. Because as it flows, it heats up. And the faster it flows, the less it heats. And if it's flowing slowly, then the heat flow will rise. If it's moving quickly, then the heat flow will stay low. And again, you can quantify that.
Such a good tool.
It's pretty handy.
Ruth, can you make an observation of the fish here?
Right? Yeah, exactly. So it's a little, you have to take your time to go around, but that's why it would be wonderful to have like a net with measurements all around that.
Not at this distance. I can't tell what it
Okay.
is.
That's what gives
I'll,
us profiles.
I'll take one now and put another one.
Yeah, it's more just to flag it in the
Yeah. That's
annotated video so we know where to look. I am not a fish
All right,
expert.
if we pull up.
Yeah. Give me 1 second, just
Sure.
take a snack of it.
Sure.
That's fish.
Yep. Okay, we're ready to remove the probe, please.
Okay.
Yeah. It's noisy, but we think we can make it work.
Okay, it's all the way up.
Okay, probe
I'll
is
set
out
it here.
at 801.
All right, so we can stow Excalibur and we'll boogie on to, or no, then we're gonna do, it's not really any specimens right here that we want to collect. We'll maybe hop up and just pan around to see if there's any sea cucumbers in the area.
So like give her a little blast forward, I suspect it'll take a lot of mud.
That's fine, that's totally fine. It doesn't need to be right here. Just, we're not really exploring for stuff, we're just having a look. Can you take a snapshot, Rue, please?
Another heat flow fan.
Great, Dorothy. That's an update from me. Morning. We're great. Jumped in the way when they go. There's a twister. See the twister?
What's that?
Oh yeah,
Twister.
Yeah.
Oh, yeah. We create our own weather.
Unless we do a sample. Even just still like,
Yeah.
or just leave it, you can choose access for your next time.
And stuff the.
Yeah, I stopped
Yeah.
logging.
After, yeah. And this time we actually got the pull out.
Yeah. Yeah, I mean, we got the pullout, but there's barely anything there. Just a little warming right there. So I'm gonna go ahead and move these.
Yes.
Okay, so yeah, organize this a little bit. I remember. Right. So we put our test. Oh, did you copy it over? I don't remember.
I think that was. I think you went.
Did we put it there? Okay. I don't remember.
Yesterday when you
Yeah.
found the drive.
Oh, right, maybe I copied, okay,
I
yeah,
think so.
yeah. All right. That over.
Yeah.
Okay, so from now on, we'll put the data there.
Yes.
Don't get caught up on
Hopefully,
that.
you can be.
We'll just hit that right now, but it's fine.
Now I'm a little more.
I think like see the core there is hitting the edge of the red.
Pardon? Yeah, I think our thrusters are, maybe there's like convergence in two thrusters or something. I don't know what, yeah.
Diva, are there priorities for out here in the abyssal plane?
I was like, let me just get up in case they're doing the log here. So,
I'm looking for some cucumber, but
Yeah,
I don't know if there's
exactly.
anything else.
there's a bit for
I might have picked up the wrong clipboard, you know, so it might be on the other clipboards.
Yeah. Go ahead and save some power.
Okay.
Is there a way to adjust the camera so it's focusing on the seafloor and less on the marine snow?
Yep.
So, we're not gonna find any of these.
No.
So, we'd like Scopioid holosaurians, like other echinoderms, basically.
Okay.
Around here.
Yep.
I think that's what we're gonna see the most of.
Okay.
Or if there's some out there.
There's the
Or-
cucumber.
But there's specific sea cucumbers. We don't want one we collected already.
Okay.
So I could help with
If we want to
that.
get our survey.
Like we've collected one
I'm
of
wondering,
those
so
already.
Okay.
one of the
Yeah.
engineers also
And then
said
also
they
sponges. We might see like
rubber.
The little lollipop?
big, yeah, little
They put a
So one of those would be
rubber
good?
between the probes
Okay.
Sure. Let me go.
and the clamps. They basically
Okay.
isolated the probe. They wrapped it entirely.
Do you mind if I fly the camera around?
Yeah, yeah.
Okay.
I guess I don't know that it would make a difference in terms of a ground fault because
Am I okay to
we're
get
exposed to the
one or
ocean.
yeah.
We're just gonna
Which
look
is
for a
just big
moment.
electrolyte.
Yeah.
So I think we have to stick with this probe, given the time we have left. If we,
Looks smarter to do these
it is.
which, and we can maybe just put it on. And
Oh,
just-
put the other one on.
And just see as it goes in the water. If it ground faults or like that.
Good.
I'm gonna just bump ahead to our clouds falling
Yep,
this year.
that's
And
fine.
we're not even gonna, might not even turn it on. It's just like, just to see it. Well, we probably should turn it on. But just to see if it talks.
Right.
We could even do that during the session. So it doesn't like mess with that.
Yeah, I suppose. And the thing that's frustrating, I can't really tell.
I like that one with the zoanthus on it. Maybe this
Okay.
one also does. But
All
they're
right.
very big, so they'll probably have to go into a bio box, which I think is okay.
Yep, there's a method on that.
Yeah.
Okay.
That's,
We're gonna try this specimen here. Can I get lasers on while we're coming in? Just so we can figure out where it's gonna go.
the opioids we had zoomed in on when I was in the other room.
Yep.
Also great.
Okay, I think
as
I saw
well.
one.
Yeah.
So it's about 20 centimeters. It might fit in a
But
little
then the
quiver.
fibers usually
Oh.
go like quite away into the
Okay.
seafloor.
All right, well, we'll see what happens.
Yeah.
So are we gonna
We're gonna try to collect that specimen right there
Yes, it's fun.
in a bio box. Most likely.
with zoanthid.
Wouldn't hurt to bring the coral quiver rack out because we might do some other collections. So a major motivation of our expeditions is to collect deep sea animal specimens that will then become part of the Museum of Zoology at the University of Costa Rica. Some of these may be new species, or some of them may be new records of the species existing in Costa Rican waters that are known elsewhere. But we won't know unless we collect some of these specimens to do taxonomic identification work. And we have a lot of taxonomic experts on board with us on this expedition, many of them coming from Costa Rica to study the corals, the sponges, the echinoderms, the brittle stars, sea cucumbers. How are you feeling about that setup, Andy?
You think? We'll have to wait till we.
Adam, are you still, how do you feel about the setup? Are you already on the seafloor? Okay. All right, let me get some beauty shots.
So we can subtract that from the others and see if that kind of corrects away the errors. Yeah, I know.
Where can you get a frame grab, please? And this is a sponge with zoanthids.
This is a sponge that's opposite.
And can we have the lasers off?
Or is that that's all one way?
Do you want one without the laser?
I do. We're waiting for him to turn them off. Okay, another frame grab without the lasers. Okay, we can proceed with the collection. So I think we're trying to pick it up at the base and pull up. There's usually part underneath. Not sure yet. If it doesn't come out with the fiber,
Maybe what we'll do is we'll just open the quiver.
oh, okay, that's not a bad idea. I'll let you control there. Oh, Maria. Oh, I just realized that, yeah, okay, I see. So yeah, someone else come in here. Doesn't need to be me.
Hi guys. This is yours.
Okay.
I think.
Yeah.
Flower.
Yeah, it looks like
Did we get some good zooms of the zoanthids? Yeah? Sorry.
We did with lasers on it.
Great, perfect. I'm not sure if Beth said, but the fibers often extend quite deep, so
Yeah.
you might need to pull for a way.
Hopefully we can fit it in a quiver. Morning. How are you?
Oh, wow.
Yep. They don't mess around.
Wow.
Yep. Yep. There we go.
Yeah.
Yeah. So we're gonna get some good zooms of this before we stow it from the bottom up to the top, or vice versa, doesn't matter. But you'll see that each of these strands in the base that make up the stalk actually look like a fiberglass strand, like a glass strand basically, and that's because these are silica based. Might need to manual zoom on this one.
I think it's got backwards here.
So normally Maria Sandoval from Universidad de Costa Rica is here right now, but we've done a swap. See, look at those strands. Oh wow. Yeah. Mm-hmm.
This seems really weird if you go look at
That's
it.
the design. Sometimes the fibers from inside the
No, this is for a sponge.
And-
These are glass sponges that go like that. Glass.
Wow.
And just stains there.
So this is essentially the sponge's anchor, right, that holds it in place in this soft sediment environment that's not very stable. And then if we could work our way, up the sponge before we.
Huh.
But does it provide information to the
No.
temperature or stuff?
We don't know.
Well, we don't. Yeah, we don't know.
And those are zoanthids. Probably zoanthids.
So these are zoanthids that are living on the sponge stalk, and then we have the actual sponge top as well. And when we are looking at the top, if we could just snap the lasers on for a little bit as well.
Yeah, it looks just
You
like
take
a
them out
flower.
to screen grabs, right, Brew?
See them as close in because they're shining.
Oh, fair. Okay, well, just before we stow it, if we could try and get just a shot with it with lasers.
We did it was on the bottom.
We got
Okay,
yeah, we got
fine.
laser.
You guys are recording it.
Yeah, I think it's okay.
That's
We're
great.
getting
Thank you
data,
guys. We
and
can stow.
We left one sensor out so we can use it to correct.
So okay in the quiver?
If you can get it to fit in the quiver, yeah, absolutely. Those glass strands are bendy, but also they can snap.
Yeah.
Brittle, somewhat.
It looks cool here. I mean, we knew that. We thought it would be. There's very little temperature rise when we
Pardon?
So it looks like heat flow.
I mean,
like
preferably,
we
yes.
expect is quite low. This is near where the recharge is.
We do have all the bio boxes available,
Do you want it in the box?
which if you think it's too tall for a quiver, then I would say preferably
we'd have
stow
to
in
bend it
a.
a little bit to get it.
Yeah, then I would say stow in a bio box if that's okay. Because we can dump other stuff in there as well.
Ah, that's amazing.
Yeah.
Where would you like it to?
Um,
Where DC start?
Hold on one second. Yeah, we are going to. Which file? Sorry. Let's put. Do you think it could fit happily in Biobox 3A or 3B or 1A or 1B? Yes, one of the smaller ones, please. Thanks, guys. So as I was saying, usually Maria Sandoval is here from Universidad de Costa Rica, but we have swapped this morning, last minute. And so my name is Dr. Diva Aman. I'm here with an NGO called Species in Trinidad and Tobago, but also with the Benioff Ocean Science Lab at University of California, Santa Barbara. Logging this morning, we have Ru Akiba from University of California, Santa Cruz. And then in the pilot seats this morning, we have Adam and Andy. And then we've got Sophia over in the corner as the multimedia tech this morning. This one. What sample number is this?
Sample number is 151.
What?
151.
151, thank you. Oh, what was 150? What was 150?
Heat flow.
Heat flow. Oh, I don't think we're supposed to log heat flow.
Oh, really?
Yeah,
Okay.
that's fine. Don't worry about
The
that.
measurement, not a
Yeah,
sample.
it doesn't have to be exactly when
Oh,
we're
yeah,
collecting it.
that's-
Great. Oh, donk. Don't squish it. Oh, you'll probably just knock it in, right?
Yeah.
Yeah.
There you go.
Okay, that's great, guys. So while we're here, there's also this guy up here
Okay.
that we'd like to collect, please.
Try to do okay, not too much sediment.
Yes, please.
We're definitely covered
That's
by-
okay, yeah. Abyssal sticky sediment is very, very, very sticky and sort of lifts very easily and stays suspended for a bit. Means operating in these terrains is, even though they're nice and flat or relatively flat, or can be difficult in other ways. Oh yeah.
Comes our cloud with us.
That's okay. Let's. So right now we're at a depth of about 3,180 meters, about 200 kilometers off the coast of Costa Rica, west off of Costa Rica. And this is the second leg of the Octopus Odyssey expedition. We were here in June as well. And right now we're at a site called Caballito, which is a seamount in the Dorado area. We visited it for the first time with the ROV in June, and I think this is only our second dive here potentially in total. So the first one for this expedition. And so what we're going to be doing during this dive is moving from the deeper regions where we are now, the sedimented plain, to move upslope, and we're going to be stopping at various periods to do some sampling as well as to do some transects. Today is very much not about collecting experiments like some of the other days have been. It's about collecting samples of biology. So I see someone in the chat has asked whether these sponges are what have inspired fiberglass. No, not fiberglass, but and no, not these sponges, but there are some sponges from the deep sea, one particular type, that have inspired more efficient fiber optic cables. So from bioinspiration, we have looked at the structures of these sponges, and then not us, we humans, and then use those structures to inspire new designs that work better.
Box 3 as well for this?
Yes, sure. That's a good idea. The same one.
Yeah, did you want pictures on the bottom first, or?
Yes, please. A bit in situ, lasers on and lasers off, and then when we collect a few zooms of it before we stow it.
Could you give me a name for it?
This is a brittle star,
Brittle
or
star.
ophiuroid, which is a type of echinoderm. Oh, this is interesting. Okay. So actually to the west of here is an area called the Clarion-Clipperton Zone, just outside of Costa Rica's waters. And one of the things that we're doing on this expedition is we're comparing the animals that live here with the animals that live there at these deeper depths. So, beautiful. If you get a little zoomed out when you're done with the lasers on. And so in that area, there is this remarkable diversity of ophiuroids. It's also a sedimented plain, but for some reason, there is just a huge number of ophiuroid species. and this looks like one of those species. So that'll be really interesting for us to examine when we get up. Great, this is a big guy. Yes, if we could put him with the sponge, that would be great. Rue, you got some
Got it.
photographs, right? Yeah.
Really rich.
Oh, and this is a shrimp swimming by. Yeah, they're so hypnotic. The way this, when you, if you, oh no,
Oh my
he's
gosh.
on the run. Oh, it's okay. Leave his alarm. Oh, he's on the move. And so we think about many echinoderms, so sea stars, brittle stars, sea urchins, other types of echinoderms, sea cucumbers, that they're quite sedentary. But actually, many of them do have mechanisms relatively to move quite quickly. So for instance, here we're seeing an ophiuroid employing the way that it can move much more quickly by using its arms to sort of drag it along the seafloor. There are some holothurians that perhaps we'll see this morning that are able to actually lift themselves off the seafloor and swim for short distances if they need to go somewhere more quickly. Try to grab its disc, the central part. There we go. Great. Thanks, guys. Oh no. Okay. Let's put the arms in, and then we'll come back for.
We have a quiver open if you want to go straight to a quiver.
I don't think he's gonna fit in a quiver.
Okay.
Five
I
up.
just worry if I torch out, we might go
Oh.
right over him.
Okay.
Try to slide back. He's definitely gonna kick with this.
Okay. We'll try the quiver, but yeah. Let's go.
Unless-
Go for it. Go for it.
Unless you think you can grab his disc just with the two arms in your.
But then we're gonna drop the two legs.
Your call.
Put him in the quiver.
Yeah.
So there are many biologists on the biology team on board, both from Universidad de Costa Rica and other universities. And because there are so many different priorities in the group, every evening we have a meeting to discuss what are the sampling priorities for the next day, and so on. Okay, just get the actual from his central disk. And so last night, because we sit and we think about what are the environments we're going to the next day, what are the types of animals we're most likely to see, and so ophiuroids was one of the priorities today. So this is a really great collection, and we actually don't have that many from these sites, especially from these deeper plains. And so this species, it's very unlikely you'd ever find wonderful.
We can throw this in the box. How box?
Oh, sure, yeah, because nothing actually went into the other one. Sure. Wait, can we get some quick zooms of it? Yeah, even though it's not. That's okay. Great. Thank you. Got some labs? Great. Okay, and he's going into Biobox 3BA. Sorry, Biobox 3A. With the sponge, yeah. This is 152, right, Rue?
152, yes.
Yeah, so this species of ophiuroid or brittle star, it's extremely likely, like I would say with very, very high certainty, that you would never see this species on the rocky areas further upslope. That's like finding finding an animal that lives in a grassy plain up on a forested mountainous area, if you will. Thanks, guys. That was great. So it's really important that we sample the different environments that we're in to characterize the different animals that live there. Okay, so at 8:30, which is in 2 minutes, we are supposed to begin our move to waypoint 2 at 0.3 meters per second with no stopping for sampling, only dropping markers if we see something amazing.
Let me know when you're ready for video transects.
Oh, this isn't video. This is just a fast move. Yeah, with the ship. Yeah. So in 15 minutes, we should be there for your next flow, right?
Do you want to do some more sampling before then, or
We only have 1 minute, so I think let's.
I'm gonna put this in the background?
Yes, please. We have another sampling opportunity in 2 hours. Don't worry.
They have a big moving pool in the drill ship. That's where the drill pipe goes down.
Yeah.
I better close it quick so it doesn't fill up the water. You only keep it open for a few seconds, otherwise. the ship is-
Otherwise, that's it. They're flooded.
Yeah.
I can fly up and get our visitor.
Yeah, let's do it.
It's all like it's just splashed against the wall. It's like it's a good way to close the leaves. There you go.
So you can see how sticky the sediment is on the abyssal plains, some of it, because it's stuck on the front of the ROVs. What are those called?
Oh, the Rock'em Sockers?
Rock. The what?
Rock'em Sockers?
Rock'em. So if you're looking at the feed now, the rock'em sock'ems of the RV, these types of arms that carry some of the push cores in this case, you can see there's actually sediment, abyssal sediment, stuck onto it. In the background, what looks like an umbellula, I'm thinking, a sea pen perhaps. Or a crinoid. Oh no, it's a beautiful stalk crinoid. Lovely.
This thing back in.
Fortunate. Just sit on there. I think I'll just rail in and it just sits there. It's just gonna pop up and move.
Okay.
Frozen.
What's that? Can we do a quick zoom over there?
I do have to do a quick spur of the vehicle here because the sediment is
Yeah.
sticking to us.
I should put kaleidograph on here so I can process, I could do some corrections on the way.
So we can see lots of bioturbation around here, and that's essentially the marks that are, so Lebensspuren is the marks that are left when animals move around in the seafloor, like the soft sediment, and or bioturbate. And so you can see there are some mounds here in front of us, lots of different colors of sediment indicating that there was some disturbance, movement of life, whether it is through their feeding or moving. And that all of this bioturbation is what helps to bury carbon down in the deep sea and lock it away for thousands to millions of years, which is a key role that the deep sea plays. It's one of our biggest allies in climate, the mitigation of climate change. Whoa, a big sponge in the background. So we're going to be moving very quickly to the next waypoint where we're going to do a heat flow experiment. So we're not going to be stopping to look at anything, just quickly flying by. So here we've got a pancake urchin, as well as another stalk sponge with a different species, some ophiuroids, brittle stars. Every now and again you can see some little sort of strange shapes on the seafloor. If you look really closely, those are xenophyophores. They are single-celled organisms that are able to create these tests. Was that us?
No. Something different altogether.
Okay, we did not form what is in front of us, interestingly. So
Sorry, are we in transit mode?
yes, we're
Okay.
supposed to be going at point 3, please, guys. But do you have any idea what could have formed something like this?
Do you have any, you don't have any shipboard ones here, right?
Any shipboard?
Like gravity core type style measurements around here?
Oh, we do. I'd have to double check whether there were any. I don't think we did any coring over here, but I'm not sure. We might have.
I'll log it.
Oh, you know, we might have because
Adam, are
we
we
didn't
going
put
to
outriggers
waypoint
on
2?
every core.
Pardon me?
Are we going to waypoint 2?
Yeah,
Right.
sorry, I wasn't sure
Yeah.
if you guys were looking at the hole or
No.
just cruising along.
I got a marker.
Yeah, so when we move between, we want to go as fast as
At
possible.
point 3.
Well, I want you to because I need to get all the metal.
See, cucumber.
It's interesting because we're seeing a lot of our biology priorities that we talked about last night here. Some benthidites sea cucumbers, some irregular urchins, some pancake urchins. So hopefully when we're at our next sampling site, which is in a few hours, we'll see some more of these animals because we have never collected them in these areas. We can also see these tubes sticking out of the sediment. Those are from polychaete worms.
Is the blue square just a mark of 100 meters?
I don't know what those squares are.
10, right now they're at 10 meters. If you look down the lower right, this is grid
No,
size.
you meant the blue square that's right behind the vehicle's position.
Oh, that's
That's
just
just
a half
the midpoint.
Halfway
Halfway,
between.
okay, yeah, thank you. Because I put this off 200 meters away, so that
Mhm.
makes sense. Okay.
So yeah, some of these shapes you can see here, sticking off the seafloor. These are xenophyophores. They are single-celled foraminifera that create these really beautiful tests. The tests can be either plate-like, so they're just sort of one-dimensional, not one-dimensional. They're just sort of one plane, one. Struggling to speak this morning. Or they can be reticulate, which means they look more like a netted type formation. Like these ones right in front of us, these are the reticulate types. And you can see they look kind of like much more complex than the plate ones would look.
It's nice when there's a lot of current set up in that garage.
Zooming past some lots of life, and even though this may look very empty, not a lot of life, a lot of the life lives within the sediment. There is a usually quite a large diversity in abyssal sediments, but they're much smaller animals, so lots of species of worms, lots of species of crustaceans, very small ones that live within the sediment. These must be from us last cruise.
I thought this was unexplored this side.
No, didn't we do heat flow around here, Andy?
Yeah.
We did heat flow around here, right?
In the past expedition.
Yeah.
Yes. Yes. We're in
Yeah.
fact where we're approaching now
Yeah.
is the end of the previous heat flow line. So we're going to repeat a measurement there as a way to see if we're getting the same value.
Oh yeah, I recognize it now.
Oh yeah, this looks familiar. Yeah, we've been here.
So was it like, sorry, you guys like in a previous cruise or with Rachel?
In June with Rachel.
This one was with Rachel. We're going right now is where one of Rachel's measurements was.
Okay.
And so for those of us that may have tuned in during the June expedition, we took some heat flow measurements. So that's where you stick a very long probe into the sea floor. Obviously it has to be a soft sea floor like sediment. And you take a measurement of the temperature. And we're trying to work out whether this particular piece of equipment is working effectively. So we've taken a new measurement, which if you were here at the start of the dive, that's what we were doing on a new site. And now we're going to a site where we actually took a measurement in June exactly. And so we're going to then use that to compare to the measurement taken in June to see whether the same and validate whether that piece of equipment is functioning as it should. So some of these bigger marks we're seeing here are unlikely to have been created by anything other than us. So it really gives you an idea of like how slowly these types of environments work. The fact that, you know, this was 6 months ago and you can still see the imprints that the ROV left. Wow, now that we're zoomed in, looks like we're like absolutely trucking it.
When I feel like you're going really fast.
Yeah. So when we get to waypoint 2, we're gonna settle down for a heat flow measurement, right? I'm just gonna let Andy direct that operation.
gonna go into clear water here.
Mm-hmm.
Sounds good.
So last expedition we had Rachel Lauer and Rob Perrin, who were joining us from the University of Calgary, who were on board taking these heat flow measurements. And this time we've got Andy Fisher and Rue Akiba from the University of California, Santa Cruz. They're really close collaborators and they are going to be building on each other's work. Or it's group work is what I should say. That bow wave. So we're just setting up to do the heat flow, but you can see one of these xenophyophores to the left of the screen. This is again a reticulate type that has this, maybe a plate-like type, but one of these single-celled organisms that is amazing and can build this home to live in.
Very similar, right? So again, just comparing the two to each other will be useful.
I'm gonna take Maria's lip.
You're gonna what?
Change you, Maria.
Okay,
So, just here.
perfect. So this is the heat flow probe going in to the sediment. It's been nicknamed Excalibur.
Good.
Yep, nicknamed Excalibur. And so now we're going to sit here and see what kind of readings we get.
So we could, for the video, we could put the heat flow in the upper left corner, right? For the audience.
Yes. So we start. Hey, Sophia.
Yes. Would you mind putting that picture and share the heat flow probe? It's awesome.
And maybe instead of the quad.
Oh, yeah, sure. I'll take it in a second, though.
So someone in the chat is asking where we are exactly. We are about 200 kilometers off the west coast of Costa Rica, still within Costa Rica's waters. And right now we're at a depth of about 3,179 meters. And we're working in an area known informally as the Dorado area because there is a specific outcrop there called Dorado, but there are lots of other outcrops and seamounts in the area which we are also exploring and studying.
Oh, perfect. Thank you.
Upper left screen.
That's what's interesting.
Okay.
Alright, so I'm gonna turn the probe on here. You're all powered up, yeah?
What
Yeah,
was
we
on the
haven't touched
screen
anything.
before?
No, upper left now showing the heat flow probe.
Yeah, so that's the live stream right there with the heat flow.
Okay.
Oh, we didn't have the insert before.
Yeah.
Right, got you.
Pardon?
You can have to shoot the photo against it's saying exactly.
I'm sorry?
No, shoot back.
So for those watching the live stream, you've now got a pretty good shot at the heat flow probe attached to the vehicle in the insert. And so these measurements of temperature that we're taking right now are going to give us clues as to whether it is an area of the seafloor where fluid is entering or fluid is exiting, or perhaps neither of the two. because that's one of the really unique things about this area where we are working, the Dorado area. We have confirmed it's one of the 2 places in the world that we have confirmed we know where water enters the seafloor and then water exits from the seafloor.
Okay,
You ready?
when you're ready, yeah, we are too. So we want to go about the same depth. Looks like it was perfect last time.
Okay, so
Yep.
I'm going to stop
Nice and
about
smooth. Just
5
right.
centimeters right below the bracket.
Yeah.
So this one,
So
I
if
would
temperatures
say we're
are
not
lower,
quite
it
as
means
deep
water
into the sediment as we were
is
last
entering the
time, but I think
seafloor, and
that was also
if
so
temperatures are higher, then it's a place that waters are exiting. And then we can often see, for instance, on Dorado, we know waters are exiting in some of those places because we can see that beautiful shimmering water and get those warmer temperatures just with the temperature probe that I think we've measured up to 12 degrees.
And stop. Too shallow?
It looks pretty close to last time.
Yeah, that's pretty.
I was thinking, we'll see. I see, yeah.
Wait, so is this piece is just for conductivity? What's this about?
This is to probe and see how dense the sediment is.
Yeah.
Oh my goodness. I have literally always thought that was it. That's so funny. I've done a whole expedition and thinking that was it.
I feel like a bunch of people were also thinking the same thing.
Today I was like, wow, it's not actually attached to anything. How does that work? Sitting here, and then when you put the insert up, you were like, oh, it's up there. I was like, what's up there? Okay, so learning things this morning. So what we are seeing in the big picture is not actually the heat flow probe. I'm a biologist, guys. It's not actually the heat flow probe. This is just to probe how soft the sediment is to make sure that we can insert the heat flow probe safely. But if you look into the insert in the top left corner, you can actually see the heat flow probe, which is nicknamed Excalibur, going into the seafloor, and it goes slowly, moves in slowly.
Quite cold. Yeah, in terms of the thermal gradient is very low, very, very low. So that's consistent with the recharge occurring through this outcrop. When that cold water goes in, cold in the crust, cold in the ocean, so you have no gradient between, almost no gradient between it.
I wonder if you snap a picture too with your phone, next time you'll be able to compare the 2
Yeah,
images.
that's a good idea.
frame grabs as well?
I mean, we can
Yeah.
hold,
Yeah.
we can hold
Great.
a ruler up to the screen. I don't know it's old school, but
Oh, we've done that.
yeah,
Oh, yeah.
Yeah, we're not opposed to old school things.
whatever works, right?
Exactly.
Yeah.
Yeah.
Oh, the hole on the outside and the hole in the bracket. Yeah, that's a good measurement.
I know. It's completely. And
So these measurements usually take a few minutes,
very little evidence. of the
several,
size.
about 15 to 20
Yeah,
minutes.
I don't know till
So
we
we're going to be
do the
sitting
process
here
and see what this looks like. But
for a little while.
if you see T1, it's going from here to maybe here, like a little bit warmer, barely.
Are we allowed to do Zooms while we're sitting here?
Of course.
You don't want to watch Excalibur.
I definitely feel very silly this morning.
Yeah,
So-
green is a little bit higher, maybe.
Yeah.
While Andy and Rue are looking at the heat flow measurements that are coming in, we're going to take a zoom at some of the biology in the area, which I'm sure is going to be thrilling. Can we first take a look at this little xenophyophore right here?
Did you want the camera?
And
Oh, sure, yes. That's great. Thanks, guys. I haven't had caffeine yet. This is not my shift. So this is one of the single-celled foraminifera that we were talking about. There's actually two in shot right now, one to the left and one to the right, and these are these incredible, again, they're a single cell that is able to build this this home to live in. And actually from an earlier expedition off Costa Rica, I think in 2019, with the old Falkor Classic, Don Jorge and Professor Lisa Levin from Scripps Institute of Oceanography and a few others showed that these xenophyrophores, actually some fish lay their eggs inside of them in these structures because they're safer from predation. And so these xenophyrophores are playing this role of being a little fish nursery sometimes. So it's pretty cool. See what else we can see around here. Little burrows, some bioturbation. Ooh, a cereanthid. Lovely. Let's zoom in. So even though this looks like an anemone, it's actually not. This is a cereanthid, which is a tubed anemone. You can see the tube at the base. That's not actually like the anemone's sort of foot or peduncle. But this cereanthid is able to fully retract down into that tube if disturbed. Inside of the center, the darker colors, you can see that would be its area that it feeds with. And the arms can then bring food into that central oral area. And we know very little about a lot of the life living in these areas. As we said, before the expedition 6 months ago, no one had ever been to Caballito. And so it means that highly likely a lot of these animals are going to be either new species, if we are to collect them and bring them up to look at their DNA and to look at their the shape of their body, their morphology. And so they're either going to be new species or they're going to be new records for Costa Rica if they are not new species. So this is all really important work in terms of understanding what lives where.
There goes the heat pulse.
And all of the samples that we're collecting on this cruise, so the brittle sow we collected this morning, the sponge, all of the biology samples are going to remain here in Costa Rica at the Museum of Zoology, which is at the University of Costa Rica, Universidad de Costa
No,
Rica.
I think that's just, well, it is, but I think that the capacitor was already charged. I think that's just a random, this electronics, they were like this when we got on board. Old and flaky. I sent an email to Elaine Abrams asking about rebuilding this, and I might look around and see what our options are. It's a pretty good sized can right now, considering the options that are out there.
Yeah, you could have another 16 sensors in there.
Don't give him ideas, Adam.
He loves ideas.
Okay, let's see what's going on in this area, if we can see anything else. Oh, another type of xenophyrophore. So xenophyrophores are some of the most common animals in the plains and sedimented plains. Are we able to zoom to focus past
Yeah, try to get some
the arm, if that's possible?
I can just move the cord around there.
Kind of did it here too, just not as much. My interpretation is just it's a random shift. Anything we get at this point is
Oh yeah.
I'll be grateful.
So now the arm is out of the way, the autofocus should work.
I'll be very happy.
What I can do is I don't want to move the torch because
No, yeah, we don't, this is not essential.
if you come with it out of the frame, you
Oh,
might just
in the corner. Oh no. Oh yeah. Oh yeah, look. Okay. So the first ones we were looking at were plate-like morphologies, but then this one is a reticulate morphology. And you can see it's almost like this little sort of like netted type organism. And then to the right of it, we've got some probably holothurian poop, which is all important down here. Anything else going on in the area? Ooh, okay, got something back here. Another xenophyophore, but we're gonna look past that. Okay, so that's all the zoom we've got. So this is likely one of, I mean, it looks like a bunch of different things, right? It could be, from afar you could confuse it for a sea pen, potentially. From afar you could confuse it for a stalk crinoid. But actually this is likely a polychaete worm living within this tube that it has created. You can see the tube is made partly out of the sediment. And it's extending its feeding appendages out of the end. So let's sit and observe this for a bit and see if we can see anything while I hand you over to the next shift lead. So I'm going to be handing you over to Beatriz Naranjo from Universidad de Costa Rica, and she's going to take you through some more heat flow and then some driving to a new waypoint. Thanks, guys. Lovely to join you an hour early.
Thanks, Diva.
Thanks, guys. Okay, let me show you. So, doing a heat flow measurement with my tube. Here we collected a purple star and a sponge. So now we're going to heat flow, then we're going to move. So it's really important not to stop until we back in the
Did I tell you?
It's already going right now. I'm just gonna record when it is.
We collected a purple star over here, right? Yeah. And a sponge. And we have seen a lot of the priorities. Right, so we saw the yellows. We've seen pattern regions, we've seen irregular regions. A lot of those rolling triangles.
Buenos días, bienvenidos nuevamente al mar profundo en la zona del Dorado. Estamos hoy explorando un pequeño monte submarino o estructura geológica conocida como Caballito. Estamos en el buceo 625 del ROV Sebastian, explorando a 3.162 metros de profundidad. Mi nombre es Beatriz Naranjo. Soy bióloga marina de la Universidad de Costa Rica.
So it's really
50/50s?
We'll see what we can do with it.
So are you going to compare it to Rachel's results as well? And I guess you get a good halfway in.
Exactly.
Now this is that probe as well?
No, that one was farther out.
Me acompañan en la
And it's
sala de
interesting, that
control
looked warmer. This-
dos
we're getting closer to the
pilotos
outcrop.
del
It looks like
ROV
it's not
Sebastian,
warm here.
But in terms of the actual
Adam
physical
y Andy y Sofía
Yeah, it's actually the
en la
she
parte
used the one
multimedia,
that's
que es la
got,
que
Pro
hace
10.
posible
Yeah,
que esta
Pro 10.
transmisión llegue a ustedes. Es impresionante poder estar acá explorando a
No, I think those numbers
más de
were
3
for,
kilómetros de profundidad y
the
poder
folks who
estar
made it
transmitiendo en vivo
Right.
para todo el mundo.
There's more.
Me acompaña también el doctor Andrew Fisher, que es el encargado de las mediciones que estamos haciendo en este momento, que les voy a explicar en unos minutos. Y colaborando en la anotación de datos tenemos a Leonardo Chacón de la Universidad de Costa Rica.
We're almost there. Okay, we are.
No, you didn't do it.
Okay.
I hit the button.
We're
All right.
we're done with our measurement. We'll let you go ahead and pull the probe out when you're ready.
What kind of
So we're removing the heat flow probe.
This is not a measurement.
En este momento estamos haciendo unas mediciones de flujo de calor. A la derecha el brazo de Sebastian tiene un equipo conocido como Excalibur, así lo llamamos, que se utiliza para saber la profundidad del sedimento y asegurarnos de que el verdadero sensor que está haciendo las mediciones de temperatura puede ingresar al sedimento. Esa es la que ven en su esquina superior derecha. En este momento lo estamos retirando. Es una medición pues que parece sencilla, es una medición de temperatura, pero es bastante impresionante que una medición tan básica
Yeah, we're going to
pueda decirnos tanto de estos ambientes.
I thought we were going up on the,
Waypoint 3, no stopping, waypoint 3, heat flow measurement, and push course.
oh,
It's like a freebie.
okay. I thought we were only getting 2. All right. News to me. Sounds good.
I think on this one, I don't know if they want to sample, it says no samples, it says no, just hold on.
Básicamente con estas mediciones de temperatura podemos tener una idea de si hay agua ingresando a través de este monte submarino o más bien saliendo un poco más caliente desde la corteza terrestre.
So these are the values. You had the wrong priorities.
All right. Thank you. Estos montes submarinos que hemos estado explorando fueron formados alrededor de hace 23 millones de años, así que la corteza terrestre no ha terminado de enfriarse y con estos valores que ya se tienen modelados para todo el mundo, de acuerdo a su tasa de enfriamiento, con estas mediciones de heat flow o de flujo de calor podemos saber si los valores de temperatura en los sedimentos son mayores o menores a los esperados de acuerdo a esa tasa de enfriamiento de la corteza, así que es una pues bastante impresionante que se pueda obtener tantísima información de nuestro fondo oceánico con una medición de temperatura. En estas planicies de sedimento o planicies abisales vemos que tenemos una fauna principalmente dominada por anémonas tubo, por gusanos que forman tubos también a partir del sedimento. Y ahorita vamos a dirigirnos hacia nuestro siguiente punto de muestreo, donde vamos a realizar otra medición de flujo de calor. Vamos a hacer tres. What is it? Oh, Dumbo. Dumbo Octopus, yeah. En esta expedición hemos estado estudiando los pulpos del género Musoctopus principalmente, pero como ven, hemos tenido la suerte de ver muchísimas otras especies de pulpo, tanto en el fondo como en la columna de agua. Dumbo Octopus.
It is.
It is.
Cute.
Can we just start to focus on the
Yeah. Yeah, we're a couple minutes out of schedule, so it's
Alright.
fine to spend a few moments to get
Okay,
video
great.
if possible. Although, you know, the sediment cloud is
Yeah.
not in our favor.
No.
Well, we've seen one. I'm sure we'll see another.
Want to continue on, or you want to get a quick zoom?
Okay. Wow.
So beautiful.
Yeah. I think it's like probably the second one that we have seen so far. Oops.
On the dive?
No, on our 2 cruises.
Yeah.
Wow. Los colores son impresionantes.
It's like it's lit up from
Estos
within.
pulpos muchas veces los vemos en la columna de agua, pero ahora, como ven, son organismos que también podemos encontrar en el fondo. Wow.
As soon as they come up off the ground, we'll get into clear water, so we'll go down into a white
Did you make an observation?
hit that button. I'll try to increase the ice.
Como ven, aquí el terreno es sumamente... I don't know how to focus.
Yeah, I think because the
It's
biz is
because
gone.
okay.
Yeah.
Yeah, I think that's as
Yeah.
much as a little bit. So
Okay.
it's on the move
We
in.
might swim away. Okay.
How did this measurement go?
That's pretty good.
Yeah?
So there's
Nice
some
Dumbo
green one right
octopus.
before we find
Part
the
of the
pulse,
Octopus
but
Odyssey
I think
experience.
we have some ideas too.
Okay.
Un saludo hasta Guayabo de Bagaces, en Guanacaste. Estamos aquí explorando un sitio, de hecho, frente a la provincia de Guanacaste. Estamos a unos 200 kilómetros de la costa. Y de hecho tenemos una participante de la Universidad de Costa Rica que creció en Guayabo de Bagaces. Así que un saludo para toda la gente de Guanacaste.
Oh, is there a jumbo octopus?
Yep.
No.
Take a look in the
Yeah. Oh yeah. That's so funny. Oh my god, that's so funny. They are strange.
Estos pulpos son
That looks
depredadores,
like a Pokemon.
yeah, that
parte de los animales que saben sacar provecho de estos ambientes tan profundos. Y si no me equivoco, son los pulpos que pueden vivir a mayor profundidad. En este momento estamos explorando esta zona de planicies de sedimento y poco a poco, mientras avancemos en el buceo, vamos a acercarnos a la parte rocosa, donde vamos a estar explorando algunas zonas cerca de la cima de Caballito. Muchos camarones que utilizan la columna de agua. Les recuerdo que pueden dejar sus preguntas o comentarios en el chat de Facebook y YouTube de Schmidt Ocean. Este sitio que estamos explorando hoy, los datos sugieren que es una entrada de agua que permite el calentamiento de ella a través de la corteza, y que después el agua sale en la pulpería, que fue un sitio que estuvimos explorando en días anteriores, donde también encontramos una guardería de pulpos. Así que los modelos lo que sugieren es que el agua entra por esta estructura conocida como caballito, que van a ver en algunos minutos o unas cuantas horas. El agua lentamente se va filtrando por ahí a través de las lavas, en sus fisuras, y posteriormente sale en la pulpería, que es uno de los nombres que estamos sugiriendo para poder nombrar oficialmente todos estos sitios que no habían sido explorados hasta este año durante nuestra expedición, tanto en la primera parte, que fue en junio, como ahora estaremos explorando hasta el 13 de diciembre. Aquí vemos un pepino del género Cicloprotes. Leonardo Chacón, que me acompaña en la sala, es un especialista en equinodermos, así que hemos estado haciendo algunas recolectas para mejorar todos los testigos que tenemos de nuestra biodiversidad de aguas profundas en el Museo de Zoología de la Universidad de Costa Rica. Estas estructuras globulares o circulares que ven en el fondo son organismos vivos, no son animales como tal, sino que son organismos de una sola célula con muchísimos núcleos bastante importantes en estas planicies. Se pueden encontrar desde aproximadamente los 500 metros hasta las partes más profundas del mundo, casi hasta los 11 kilómetros de profundidad, y son organismos que utilizan minerales y sedimento de sus alrededores para construir una testa que puede tener algunas cámaras. En la expedición del 2019, Costa Rica Deep Sea Connections, que se realizó también con el ROV Sebastian, pero principalmente frente a la costa del Pacífico Central de Costa Rica y la cadena de montes submarinos de la cordillera volcánica de la isla del Coco. Recolectamos algunos de estos xenofióforos, que es como se conocen en el grupo de los foraminíferos, y encontramos huevos de peces dentro de ellos, así que son estructuras que dan un poco de tridimensionalidad y refugio en estas extensas planicies de sedimento. Estas células pueden ser bastante pequeñas, desde unos pocos milímetros. Sin embargo, hay algunas especies que pueden ser bastante grandes, pueden ser de hasta 20 centímetros. Así que estamos hablando de células de 20 centímetros, una sola célula. A la izquierda tenemos peces conocidos como brotulas, son parte de la fauna principal de peces que vemos en estas profundidades. Estamos muy cerca de nuestro punto de muestreo número 3. De los 9 que tenemos para el día de hoy. Nuestros últimos 3 puntos de muestreo están localizados justo en la cima de Caballito, que se encuentra a unos 2.800 metros de profundidad, así que estamos hablando de que es una estructura de aproximadamente unos 300 metros de altura. Unos gusanos pelágicos. Ayer estuvimos recuperando muchos de los experimentos que habíamos colocado en junio, así que aunque aún nos faltan algunos experimentos para ser traídos de vuelta, la mayoría de ellos ya fueron recuperados y eso nos da también un poco más de posibilidades para explorar nuevas áreas de sitios que ya hemos estado visitando. Para poder realizar toda esta exploración se realiza un gran trabajo de mapeo. Para muchos de estos sitios se contaban con mapas muy preliminares de expediciones anteriores que aunque no fueron visitados con submarino, se tienen información desde los barcos. Los barcos también tienen muchísimos sensores, así que sobre todo en la expedición pasada dedicamos bastante tiempo a hacer trabajo de mapeo para mejorar toda la batimetría o las líneas de profundidad que nos permiten planear nuestras inmersiones. Así que poco a poco hemos ido mejorando toda la información, los mapas que tenemos del fondo costarricense. Sin embargo, falta muchísimo aún por mapear. Y mucho de lo que se encuentra mapeado no tiene una resolución tan detallada, así que son parte de los vacíos que hemos ido llenando para el país. Nuestro interés es que todas estas imágenes, todos estos videos puedan ser recopilados de una forma que permita también ser traducida para público general, para tomadores de decisión. Así que aquí a bordo hacemos un gran trabajo de curación de datos y por supuesto tenemos muchísimo trabajo después de la expedición para lograr toda la cantidad de datos que se generan tanto desde el barco como desde el ROV. Es impresionante, son muchísimos gigas de datos. Así que este tipo de expediciones implican años de trabajo posterior. Aquí vemos un pequeño cangrejo que se coloca, sea una anémona o un grupo de zoántidos, otro grupo también emparentado con los corales, sobre su caparazón, y esto le permite pues protegerse, ya que la anémona tiene células urticantes, así que lleva su guardián consigo a todas partes. Estas cicatrices que ven en forma circular son marcas en el sedimento, en el fondo, que dejan algunas medusas que solemos ver en estas inmersiones. Y todas estas pequeñas estructuras globulares son los organismos que les comentaba que son unicelulares, los xenofióforos. Otro cangrejo cargando su anémona. Muchos de estos peces es bastante difícil identificar, son bastante difíciles de identificar, principalmente porque no tenemos acceso a los especímenes y la cantidad de fotos o imágenes que tenemos en su hábitat natural son sumamente limitadas. Así que siempre es una tarea retadora intentar hacer identificaciones de organismos de aguas profundas a partir de imágenes. Sin embargo, es la principal herramienta que tenemos para conocer nuestra biodiversidad.
Yeah, what was it, 100 or something?
Aprovecho para invitarles, si tenemos personas de La Cruz, Guanacaste, o de Tortuguero, de Salitre en el Pacífico Sur, o personas que vivan cerca de Cocles en el Caribe Sur, les invitamos mañana vamos a tener una actividad donde vamos a transmitir directamente desde el barco. Vamos a estar haciendo un tour por el barco, que conozcan las investigaciones que estamos haciendo. Así que les invito a contactarnos para poder darles más información. Vamos a estar en la Casa de la Cultura de la Cruz, en el auditorio del Parque Nacional Tortuguero, en las instalaciones de la ADI Salitre en el Pacífico Sur y en las instalaciones Playa 506 en Cocles, a las 3 p.m. mañana sábado 9 de diciembre para un ship to shore. Es parte de las actividades de comunicación y educación que nos interesa hacer para que las personas puedan conocer más de toda esta Costa Rica desconocida que tenemos bajo el agua. Durante estas actividades hemos estado conectando con estudiantes, con grupos de profesores y con personas en general interesadas en aprender un poco más de nuestro trabajo, y son sumamente importantes para nosotros.
What's that? You could. I mean, if we want flat, but it's more important that we get it when we're on up the zero. Yes. In case it's not on all continuously.
Thank you.
Mm-hmm.
Fishy. Coscule. We've been seeing many fishes down here from the same order of Ophidiformes, coscules or brotulas. Important part of the fish fauna that we found here, and certainly one of the most important groups as predators in these areas. En estas planicies estamos haciendo, además de las mediciones de temperatura, estamos haciendo recolectas de sedimentos que son utilizados con diversos propósitos, desde propósitos microbiológicos, mineralógicos. También se utilizan para tener una idea de la edad de esos sedimentos. Todo ese sedimento que ven ha sido parte de la lluvia pelágica, a veces también conocida como nieve marina, que es todas estas partículas suspendidas que podemos observar en la columna de agua. Muchas de estas partículas vienen desde la superficie, entre ellas pequeños organismos que forman parte del plancton y que cuando mueren comienzan a caer lentamente hasta depositarse aquí, y se ha ido acumulando por millones de años. Así que si hacemos un estudio de este núcleo de sedimento que se puede extraer de estos sitios, podemos tener una idea, estudiando los fósiles que se encuentran en ellos, de qué tan viejos son. Para eso tenemos a bordo a María Sandoval, que de hecho es la persona que va a estar en la siguiente hora narrando la transmisión. Ella es especialista en este grupo de organismos, estudiando fósiles. Así que estamos hablando de que, aunque no tenemos los datos específicos para este sitio, estamos hablando de que en 1 centímetro de este sedimento tenemos acumulados miles de años de pequeñas deposiciones lentamente desde la superficie. Those scars?
You'll see these circular patterns on the
Yeah, I
bottom.
think they're from medusas, like jellies.
Oh, yes.
You know that sometimes they're in the bottom.
Right.
Yeah, we
Yeah.
have seen some. So they leave the scar. They're quite common here. Este organismo que vemos en pantalla está emparentado con los corales. En este momento no podemos hacer acercamientos, ya que nos estamos movilizando hacia el siguiente punto de muestreo. Si hiciéramos un acercamiento, podrían observar, tal vez en el siguiente punto de muestreo, observemos alguna y podamos hacer un acercamiento. Pueden observar que tienen 8 tentáculos así que son parte del grupo de los octocorales, corales blandos sumamente importantes en estas profundidades. Si no es así, es esto al revés. Lo hacemos. Bastante poco frecuente observar rocas en estas profundidades. En la expedición de junio creímos observar lo que parecía como un tronco o una roca y resultó ser un fósil, un cráneo fosilizado de... Resultó ser un cráneo fosilizado de una especie extinta de cetáceo, una pequeña ballena. Poco a poco vamos a ir encontrando más sustrato rocoso conforme nos vamos acercando a la parte rocosa del monte. Todos estos sedimentos están cubriendo la corteza, así que en los montes submarinos, ya que son bastante empinados, es donde podemos observar o tener una menor tasa de depositación sobre la corteza, y precisamente es por ahí donde el agua puede filtrarse por la permeabilidad de la lava, ingresar hacia la corteza como un sistema acuífero, que es básicamente lo que hemos estado estudiando en esta expedición, cómo este sistema acuífero afecta toda la biología, cómo esa agua viaja lentamente a través de la corteza y se expulsa después de haber ganado algunos grados extra de temperatura.
No, we're just coming up to it here.
We're coming this way. Empezamos a ver esponjas adheridas a las rocas, pepinos de mar, brotulas, anémonas tubo. Tenemos un comentario en el chat sobre lo increíbles que son los pepinos de mar. Estamos completamente de acuerdo. Todo el grupo científico creo que es un poco fanático por los pepinos de mar, animales muy interesantes, bastante pocos estudiados en nuestro país. De hecho, es uno de los principales objetivos que tenemos como parte de nuestras recolecciones científicas. En este momento no podemos detenernos a recolectarlos, ya que tenemos un plan de buceo con tiempos limitados, pero más adelante tenemos un espacio donde vamos a estar haciendo nuevamente recolecciones y esperamos entre ellas obtener algunos especímenes de pepinos de mar. Tim Cook. We'll be doing some scientific sampling for sea cucumbers, or at least that's what we hope so. We have some space later on our dive plan to collect some of these specimens that will allow us to understand better the biodiversity that we have here. We have on board especially two people really excited about sea cucumbers. Sergio and Leonardo will be pushing to try to collect some of this. All the biological sampling that we make, all the specimens that we collect will remain here in Costa Rica as part of the collection of the Zoological Museum of the University of Costa Rica. Estas cicatrices que vemos en el sedimento posiblemente son señas de la vez pasada que estuvimos aquí. Como ven, son ambientes bastante estables. Algunas veces, inclusive décadas después de que se visitan, podemos aún ver las huellas que dejan los ROVs, los submarinos en general, en el fondo oceánico. Aprovecho para presentarles a Leonardo Chacón, un especialista en equinodermos, estudiante de la Universidad de Costa Rica, que nos va a explicar a continuación un poco de la diversidad que tenemos aquí en aguas profundas y lo que estamos observando.
Muchas gracias, un saludo a todos. Quería comentarles sobre un pequeño erizo que acabamos de ver, de nombre Cistequinos loveni. Es uno de los principales objetivos de recolecta en los próximos minutos, horas, y estaremos esperando poder encontrar algún otro ejemplar para recolectar. Hi everyone, my name is Leonardo Chacón. I am from the Universidad de Costa Rica, and I'm just talking about Cistequinos loveni. This is a irregular sea orchid that is one of the most important targets in the future for collecting, and thank you everyone for sharing with us this amazing experience.
Gracias, Leo. Leo es una persona sumamente apasionada por toda la diversidad de equinodermos, desde aguas someras hasta aguas profundas. Tuvimos la suerte de ser compañeros en la universidad, así que es bastante emocionante poder compartir esta experiencia juntos. Son experiencias únicas para nosotros. Tenemos poco acceso, aunque eso ha ido cambiando. Nos sentimos bastante afortunadas de estar aquí a bordo. Son experiencias con las que bromeábamos. experiencias que a veces creemos que no vamos a poder vivir y por suerte estamos viviendo un cambio tecnológico. Cada vez hacemos más exploración gracias al trabajo de personas que nos han tomado en cuenta, como Jorge Cortés o Alice Cabridi, personas con bastante experiencia en este tipo de expediciones. Yo recuerdo que la exploración científica del mar profundo en Costa Rica no inició hace mucho, y principalmente no fue hace mucho donde comenzamos a participar de estas expediciones. Aproximadamente desde el 2009, que el Alvin visitó la costa pacífica de nuestro país, fue donde comenzamos a formar, a través de Odalisca y don Jorge, un grupo de investigación bastante interesado en estos ambientes. Así que de verdad son momentos inolvidables que estamos viviendo.
La estrella que acabamos de ver es posiblemente de la familia Pterasteridae del género Pteraster y es también uno de los focos de interés para la recolecta en el tiempo venidero. The last sea star, the pink one that we just saw, is named Pteraster, maybe from the Pterasteridae family, and it's also a focus for collecting in the few minutes, hours, and we are really glad to share these images with you, because they are the first for this kind of organism here in Costa Rica and Central America.
Yeah. It's just amazing that we are able to transmit to all of you all these images down from 3 kilometers below the surface. For those who are just joining the transmission, we are exploring Caballito Seamount at more than 3 kilometers below the surface in front of the coast of Costa Rica.
This little sea cucumber is from the Peniagone or Amperima genus, and this is also named like a sea pig. El pequeño pepino de mar que acabamos de ver es del género Peniagone o Amperima, no estamos muy seguros, y es del grupo perteneciente a los cerditos de mar.
Cerdito de mar, me gusta. Me gusta el nombre. Estamos escapando a un cangrejo con su anémona. Vamos a encontrar un sitio que no esté tan rocoso, ya que en este nuevo sitio que ya estamos en nuestro sitio muestreo 3, vamos a seguir con nuestras mediciones de flujo de calor. Para esto ocupamos encontrar un sitio con suficiente sedimento, lo suficiente para que el sensor pueda penetrar hasta el fondo del sedimento. Para eso probamos con Excalibur, que es una espada que van a ver a continuación, que utilizamos para saber la profundidad y asegurarnos que el sensor no se va a dañar cuando ingrese al sustrato. Es increíble, cada pocos minutos vemos algo y todos aquí nos volvemos a ver sin saber qué es. Estas son las primeras imágenes, estas y las de la expedición pasada que tenemos de esta región profunda de nuestro país, así que todos los días aprendemos cosas nuevas. y ese sentimiento de no saber qué estamos observando, creo que sin duda es para todas las personas que nos dedicamos a la ciencia parte de nuestros momentos favoritos, cuando entendemos que sabemos sumamente poco.
All right, seemed like it went pretty
Okay.
good.
Yeah, okay. So what we did last time was we,
Share the picture.
we'll let this clear a little bit. Oh yeah, I'll show you a photo. We'll call it
En
out.
este momento el doctor Andy Fisher está dando instrucciones a los pilotos para proceder con la siguiente medición de flujo de
So we stopped
calor.
when the bracket was,
Como ven, Excalibur penetró el sedimento hasta el fondo, así que es un buen sitio para nuestro muestreo.
yeah.
En unos pocos minutos van a tener en pantalla una imagen del sensor real, que es el que está adherido al Sebastian.
Okay.
Este sensor ingresa al sedimento y toma mediciones en diferentes estratos.
Okay.
So I'm stable right now, but just no auto edit. I'm ready.
Sounds good. Okay, we're gonna turn this on and get a few data points first, and we'll give you a holler.
Roger that, and ready to go in.
We got the
Yep.
data sheet. Okay, we're good. Now we're just gonna start the throw.
Yeah, you can start.
Coco?
Yes. No, I was just
Coco Loco.
No, it's already
Coco Loco.
Coco Loco. Hace poco tuvimos un cambio aquí en la sala de control de pilotos. Me acompaña J-Rod, un piloto sumamente capacitado para estos trabajos, muchísimas horas bajo el agua, volando este increíble submarino Sebastian. Una tecnología impresionante. Cada vez que tenemos la oportunidad de ver a Sebastian tiene algo nuevo, algo mejorado. Es un proceso constante de innovación. Y también tenemos el segundo piloto, que es Coco, y me sigue acompañando Sofía.
Right, we're gonna wait just a few seconds here. We're collecting a little
Okay.
background information.
All right.
30 seconds, and then we'll give you the okay.
All right.
Sounds good.
El equipo de Andy Fisher está preparando su equipo,
No, just as noisy.
y desde
Right.
una computadora ellos pueden observar la información que los sensores están enviando a través del cable de Sebastian y comparar qué tan o determinar de cuánta calidad es la medición para obtener todos estos datos de
All right, we're ready
de
to-
si el agua
we're ready to
está
go in when you are.
o si el sedimento está más frío, más caliente de lo esperado, y así tener indicios de si el agua está entrando o saliendo a través de la corteza. Andrew fue una de las personas que encontró o que exploró estos sitios por primera vez. En el 2002 y 2003 realizaron una serie de visitas a este sistema, donde se sospechaba que había flujo de calor a través de la corteza. Así que este es uno de los únicos 2 lugares en el mundo donde tenemos datos realmente de buena calidad para poder determinar este flujo.
Relatively, even overall.
Así que Andrew tiene muchas historias de cómo estos sitios fueron nombrados. Este caballito tiene una historia divertida, ya que uno de las personas a bordo del trabajo en el barco tenía que subirse en una escalera, así que era como subirse a caballito.
So what's odd here,
El equipo tico ha estado bromeando que posiblemente sea por que estamos al frente de la península de Nicoya, caballito nicoyano. Muchas historias. Muy interesante siempre cómo se pone un nombre a los sitios, por alguna anécdota que sucede a bordo, por algo que se observa. Y como les hemos estado comentando, parte de nuestros objetivos en esta expedición es sugerir nombres específicos, oficiales, para que todos estos sitios comiencen a aparecer en los mapas oficiales del fondo oceánico. Nos está esperando Tengo Sed, Caballito, Dorado, lo que queremos nombrar como la pulpería, ya que es un lugar pequeñito y variado. Y por supuesto lleno de pulpos, así que es parte de toda la idiosincrasia costarricense, un término con mucha historia, con el que podemos identificarnos como costarricenses. Son para otras personas que habla hispana que no conocen el término. En Costa Rica las pulperías son las pequeñas tiendas, los pequeños mercados que tenemos en los pueblos, donde literalmente se puede encontrar de todo. Y por supuesto, suena a pulpo.
Again, you can adjust the towel window to allow for that. And what's odd, I guess we are seeing now, we did see a rise for T4, right?
Yeah.
I mean, they all went up
Yeah.
a little bit, but definitely seeing the biggest rise for.
En el margen, en la esquina superior izquierda, pueden ver el verdadero sensor. A la derecha es Excalibur, solo para ver la profundidad del sedimento. Y a la izquierda tenemos el verdadero sensor, que está recopilando información de temperatura a diferentes profundidades en el sustrato. Un instrumento que parece sencillo, pero que da información sumamente valiosa.
T2 was below the red here, now it's above the red.
Oh, yeah.
T3, look at the space from
Vamos a quedarnos por acá algunos minutos.
or from the, we should look at the space from the blue. So here,
Vamos a explorar por acá a ver qué vemos. Estas son los organismos unicelulares que les estoy comentando anteriormente.
I mean, I wonder if there's enough of it till we actually only have two. We can actually call that penetration.
Vamos a hacer zoom en uno de ellos para que lo puedan observar.
Make that penetration. So this will the heat pulse is going to fire a little early
Okay.
from that perspective, but it's still probably fairly early.
Acá tenemos dos en pantalla. Son organismos de una sola célula. Y hace poco les estoy comentando que muchas veces podemos encontrar otros organismos viviendo dentro de ellos, así que son bastante importantes porque son un componente principal en este tipo de planicies, dando un poco de tridimensionalidad al sustrato. Hay muchas estrellas quebradizas enterradas. Tenemos por acá un animal un poco extraño, vamos a ver qué es. Ya. Ah,
Well, what's really strange here is that it really looks like
okay. We are all looking.
the first two deepest are a little bit more younger.
Estamos aquí todo el equipo que está en la sala de control volviéndonos a ver,
We ended up
preguntándonos qué es. Gusano, definitivamente. Probablemente un emertino. I think we saw some in the last cruise. I think it's I think we saw one on the last cruise.
That is creepy.
But it's really.
Well, and this
That looks like a blue alien.
place that Rachel did her last
It's been
visit.
tied in various places.
Oh, is this the logic on her line? Okay, I was wondering about that.
Yeah, so I pulled up that coordinate,
Okay,
just so you have another tie point,
thank you.
and then we had more data here anyway for getting the push cars. Yeah? One at a minimum, if people need one, I don't know if it's less than a year.
Estos son parte de los momentos que más nos gustan de estas exploraciones. Ver animales y no saber qué son. Y por supuesto intentar averiguar. Ah. Hay un grupo de pepinos que es similar, nos comenta Leonardo, pero sin embargo con algunas estructuras, sin poder ver algunas estructuras no es posible determinarlo. Yo personalmente creo que es otro filo, un emertino, filo nemertea, o podría ser un pepino bastante extraño. Aprovecho que estamos por acá en estos sedimentos para dejarlos con una persona amante de los sedimentos que les estuve comentando anteriormente, la doctora María Sandoval de la Escuela Centroamericana de Geología. Ella es micropaleontóloga y utiliza todos los organismos que van cayendo de la columna de agua hacia el fondo y que poco a poco se van fosilizando para poder determinar la edad de estos sustratos. Así que fue un placer acompañarles, nos vemos mañana, sigan nuestra transmisión y muchas gracias por su interés en conocer más sobre nuestro mar profundo, la Costa Rica desconocida. I leave you now with a sediment lover. We have here on board Dr. Maria Sandoval from the Geological Department of the University of Costa Rica. She's a micropaleontologist that is actually working, studying these sediments that we are seeing. So it was a pleasure to be here with you. Thank you for your interest in our Costa Rican deep sea environments. Have a nice day.
But we have to get something that's visible from the screen. Radio Larry.
Sí, estamos aquí. Ya hicimos esto. Y estamos hip flow, push forward,
Sí,
skin.
exacto. Me toca eso. Qué bien que cambiamos.
Y así que, de hecho, sería interesante traer eso. O sea, aquí mismo tenemos que hacer la colecta.
Entonces sacar ese abyssal.
Yo diría.
Okay.
Y preguntarle a Leo ver si hay algo que él quiere. Cuando empecemos los transects es importante enseñar esto. Es con lo que estamos haciendo el fotogrametría. Thank you guys. Pero esto es como
La lista de
igual,
wishlist.
sí, igual vamos a venir aquí a ayudarle.
Sí, para lo de la colecta.
Sí.
Ok. Muy buenos días a todos y a todos. Les habla María Isabel Sandoval de la Universidad de Costa Rica, de la Escuela Centroamericana de Geología. Yo soy geóloga y justamente este sitio vamos a colectar unos sedimentos con los que hemos estado trabajando un equipo interdisciplinario de la Escuela de Geología, así que ahora les contaré un poquito y estaré aquí con ustedes esta hora. Hello everyone, this is Maria Sandoval from University of Costa Rica. So I am a geologist from Central America School of Geology in Costa Rica. So I especially work with this sediment, so I will be saying some details about the sediments that we will collect in some minutes. I will be with you this hour, so just let me know if you have any question on the chat. I will be principally speaking in Spanish, but if you have any question regarding sediments and rocks, just let me know. Okay, so Les comento que estamos acá tomando unas mediciones de flujo de calor, como les explicó bien Beatriz, que estaba anteriormente narrándoles. Acá este flujo de calor, estas tomas se realizan para poder entender cuál es el mecanismo del flujo de calor, cuáles son las variaciones de flujo de calor. Se toman aproximadamente por unos 15 minutos. Este aparato que tenemos enfrente, que es el Excalibur, mide la profundidad. Aquí estamos a 1 metro de sedimentos, de acumulación de sedimentos, y justamente en sedimentos, en estas planicies abisales, es donde vamos a tomar estas medidas de flujo de calor, ya que podemos insertar la medida o el medidor de flujo de calor, que lo tenemos hacia un extremo, no lo están viendo en cámara, y este llega a las medidas y las variaciones de flujo de calor, de temperatura en el sedimento. Conmigo acá en el cuarto de control tengo a los pilotos, quienes están, y al asistente y a la técnica de multimedia, y también al doctor Andrew Fisher, que es el encargado y experto a nivel mundial, uno de los expertos a nivel mundial de geofísico, hidrogeólogo, trabajando con flujo de calor en estos sistemas de fondo oceánico. Al doctor Andrew Fisher de la Universidad de California de Santa Cruz, y a Ryo Akiba, quien es estudiante también del doctor Fisher y trabaja en la Universidad de California, y estudia en la Universidad de California, en la Universidad de Santa Cruz. Bueno, para contarles un poco lo que se ha trabajado de la expedición pasada con estos sedimentos. Entonces se colectan los sedimentos con unos muestreadores al vacío, los cuales ahorita vamos a utilizar, y luego estos se extraen y se estudian en el laboratorio. Cada centímetro se va muestreando, y este centímetro del tope hasta la base del sedimento se recolectan unos 20 centímetros de sedimento, ahora verán en unos minutos, y luego esto se analiza, como les digo, se va cortando cada centímetro y se ven esas variaciones a través del tiempo de la influencia de estos sedimentos o las variaciones en sí. ¿Qué vemos? Bueno, vemos desde qué son, o sea, qué tipo de sedimentos son. Bueno, si son limos, si son arcillas, su plasticidad, su contenido, porosidad, etcétera. También se observan, se hacen mediciones se observa la mineralogía. Aquí ya estamos removiendo lo que es la medida de flujo de calor, o la toma. So, now we will continue with
All right, so if you could power down the heat flow probe, please.
Heat flow is off.
All right, thank you.
Thank you.
Yeah. You want to do them right here?
Yes, we can do it right here, and also the one Niskin bottle 5 liters. No, you prefer?
Using this one first before we
Yes.
get it all
Yeah.
muddy.
Yeah.
Just like what you got there? Maybe there? Yeah, just look at this right now. We'll see if I rotate.
Mira, ¿usted quiere que conectemos también el gusano? ¿Sí? Ahora, después de los push codes, podemos
You know, the
conectar
other
el
way we
gusano,
could do this is
o lo conectamos antes de los push codes. Bueno, en realidad tienen primero los push codes y
and then
luego el
come back
gusano.
out.
Me da miedo que se nos vaya, pero no sé.
Because the only thing we can do this,
Eso no es prioridad. La prioridad es toda la que nos usa. Entonces, me lavo las manos. Porque acaba de decir Beth que la cosa se la toma ahora. Entonces no quiero como...
De la colecta. Pero Oda está en turno. Entonces, voy a preguntar en el chat, ¿ok?
Going for Niskin 1, correct?
It's 5 liters. Yeah.
Niskin 1's okay?
Yeah, it's perfect. Niskin 1. Leo, tomaste la botella de Niskin, apúntale, 5 litros.
¿Cuál? ¿Qué número?
No, número 1.
Go ahead.
5 litros o números.
Fire.
¿Ah?
That's Niskin 1 fire.
Ya, perfecto.
Go ahead and
Bueno, aquí estamos tomando en el sitio donde se toma el flujo de calor. Lo ideal es tomar también el agua del sistema y también los sedimentos asociados. Entonces en este momento vamos a estar realizando esto. Y como les comentaba, pues el análisis de sedimentos y de agua se va a realizar en la Escuela de Geología y en el CIMAR. Lo que es el contenido de agua y la caracterización del agua, esto se lleva a cabo por la doctora Celeste Sánchez del CIMAR, y en la Escuela de Geología, que trabajamos la composición de sedimentos, tanto a nivel mineralógico como a nivel de microorganismos. No me refiero a microbiología, sino a nivel de plancton principalmente. Y también hay otros investigadores asociados que están en tierra en este momento, que trabajan, por ejemplo, los hongos. Hay unos investigadores acá que trabajan, bueno, el doctor Gustavo Ramírez, que trabaja principalmente las bacterias asociadas a estos sedimentos.
How many do you need? How many are we doing? How many?
6 push course.
6
Yes, please. Yeah. No worm. Beth, she said that no. No, solo el Niskin. Ahorita vamos a tomar los push course, porfa. Son 6 push course. Bueno, vamos, espere que lo saquen y ahí vamos. Ajá.
Let's start with 5. Huh? Okay, that's in the one spot. That's what you use one to start off with. Then I'll turn those bowls off so you can see. So you're gonna take that cover off. And you got to put it on one of those. Or do you want to put them all in and leave them and then put them all away? That way we don't disrupt them?
Yeah, perfect. Yeah.
You're gonna wanna drape them over onto the side, you don't stick them. So just pick it up and bring it inboard.
Bueno, estos son los famosos push course, son los primeros que tomamos en esta expedición. en esta expedición de acá a diciembre, ya que en junio sí colectamos en diferentes sitios. Así que aquí es un tubo de PVC que se introduce en el sedimento y al vacío pues se introduce lo que es el sedimento y luego esto se extrae y estos posteriormente son analizados por diferentes investigadores, así que por eso vamos a tomar unos 6 de estos testigos de sedimento para poderlos estudiar con diferentes objetivos. Para recapitular, hoy estamos desde el sitio Caballito y estamos en el buceo 625. Para las personas que no estaban conectadas hace un ratito, nos ubicamos a 200 kilómetros fuera de costa del Pacífico Norte y enfrente de la península de Nicoya, en una serie de volcanes, de antiguos volcanes submarinos que provienen desde la dorsal del Pacífico. En estos montes submarinos o este sistema de volcanes antiguos se generó en la dorsal, como les comento, y ha viajado hasta acá al día de hoy, lo que hace unos 23 millones de años hasta el día de hoy en su posición. Por lo tanto, las rocas más viejas que tenemos acá, que son las lavas, que son unas rocas negras que hemos estado viendo donde viven los pulpos, por ejemplo, en el Dorado, tienen aproximadamente 23 millones de años. Y los sedimentos, bueno, la idea es sacar edades también, se acumulan a través del tiempo por lo que es la caída de la lluvia pelágica o nieve marina, que se llama. Estos son organismos que viven en la columna de agua y... Yes. Yeah.
I'll put some lasers on, and then I'll put a target area. Let me know if you're happy with that.
Mm-hmm.
So I'm thinking, what do you think about like right
Yeah,
there?
right here.
In between the two lasers?
Yes.
Yep. In between the two. For some reason, you're not using your yaw, but you're bringing the arm close in. Now, use your shadows. Your shadows will let you know how lined up you are and how close you are to the bottom. So you're still far away from it. Your shadows. You're crooked.
Aquí estamos viendo estos puntitos verdes que se indican la distancia. Estos son unos láseres que indican entre un punto y el otro, indican unos 10 centímetros.
Sit there and finesse the seat. You have to get lined up, be over it. If you're doing that, that's not your fault. So I'm gonna give you a número uno.
El número 1.
I'm gonna move it
Pero
just
tiene
over a
que
little bit.
esperar a que se recoja para poner si es push cord
So get your
tal, en cuál rack.
See, this guy looks right straight there. And you make that straight. Push cord. Edge out. Push cord.
Exacto.
Edge is pieces of pulp.
Si uno se cae, todo el
Just right above. These units, any sun chart, it's gonna pop this up. And then travel down. Just go down.
Creo que el número... Which number of push cord is this one?
That was 5.
5.
Yeah. Go down a little bit more.
Cool.
Are you? Your mic open? Mic open, yes. Are you coming up? Go up here. Get in the center. You're moving the arm a lot when you go to the floor. Okay. You see all this right here? That means you came in like that. Just go straight.
Bueno, el tipo de sedimento que se analiza o la granulometría en estas zonas abisales es generalmente fino a, digamos, en un limo y puede variar a una arena fina. Y todas estas variaciones se pueden ver a través del estudiando todos los niveles que se sacan en el push core y entender un poco sus variaciones. A veces, por ejemplo, si hay mayor cantidad de foraminíferos cayendo en la columna de agua y acumulándose en el fondo, pues esto se notará en los sedimentos y todas esas variaciones se van a ver. A veces vamos a tener, por ejemplo, un mayor contenido orgánico o vamos a tener variaciones, como les explico, entre limos y arenas, y esto puede ser por una variación inclusive de organismos, como esto que les explico de foraminíferos. A veces los foraminíferos, el tipo de granulometría que tienen sería equivalente a una arena, aunque no es la arena como tal, ¿verdad?, que uno se imagina, pero el equivalente en tamaño, en granulometría. Y todas estas variaciones se ven. Entonces también, imagínense si hay una producción o mucho más corrientes en la superficie, y esto genera mayor productividad, mayores organismos en superficie, y cuando estos mueren pues van cayendo, se van acumulando, y estos cambios los podemos ver a través del tiempo en el sedimento. También podemos ver edades. Acá las tasas de acumulación son muy lentas en el fondo oceánico, por lo tanto podríamos esperar 3000 años en 1 centímetro, por ejemplo. Entonces, toda esta historia podemos reconstruirla utilizando estos núcleos. Y por supuesto su contenido de microbiota y microorganismos que se analizan también por algunos investigadores acá en el barco. Este es el 1. It's 1, right?
What number is this?
What?
The number is 6.
It's 6, okay.
Alright, then you put it in undisrupted sediment, so we can try coming over here. Right here. Is this spot okay? Where the lasers are? In between the lasers?
Yes, please. That's great.
Good.
Algo que es muy importante en la colecta de estos núcleos es que no se pueden, la idea es no mezclar el sedimento, puesto que si lo mezclamos perdería su relación en el tiempo y sus variaciones en el tiempo de lo que queremos entender. Entonces la idea es cuando este núcleo se corta, unos de ellos se cortan cada centímetro, apenas ingresa acá en el barco. Hay otros que también los movemos directamente y los pasamos a congelar y luego son cortados en el laboratorio. Se parte a la mitad del núcleo, se le toma fotografías por si ver si hay variaciones notables, por ejemplo en color, si hay algún evento que nos pueda indicar, por ejemplo en color, ¿verdad? Y entender después posteriormente qué es lo que pasa para poderlo describir. Y después se muestrea, o sea, ya se va muestreando o pedaceando, por decirlo así, en cada centímetro o cada 2 centímetros, cada 3, dependiendo del objetivo del estudio. Además, acá en el barco, desde que llega el núcleo, también se hacen algunas como láminas, se raspa un poquito del sedimento o se toma un poquito de la muestra, se pone en un portaobjetos y luego se describe bajo el microscopio que tenemos acá, y tenemos una descripción preliminar de los primeros sedimentos, de los primeros centímetros del núcleo. Es para entender qué es lo que está cayendo en este momento ahí. Acá generalmente vamos a tener, como les explicaba, organismos pelágicos que viven en la superficie, pero cuando mueren van cayendo y se acumulan. También podemos tener materia orgánica de organismos, ¿verdad? Lo que es todos los residuos orgánicos de los organismos, esto forman un tipo de material fecal y se ve arcilloso en los núcleos. Y todo esto también el contenido mineralógico que se tenga. Vamos a sacar el 7. Some of the objectives that we have used in this course and this sedimentary push course is to get an idea what is in the sediment through time, because this is usually the sediment takes long time to accumulate in those depths. For example, we can have in 1 centimeter 3,000 years. So imagine all the changes that we can have through time in 20 centimeters long core. So usually we can have variation in granulometry, in the size of the sediment. Also we can have some variation in biogenic composition and in mineralogy also. So all of those we analyze in the geology department of University of Costa Rica, but others studies as Gustavo make in his lab is regarding the microbiome on those sediments too. That's why we take several courses to share the sediment for different studies. Also, we at the University of Costa Rica. There is a fungal expert. So he works on that sediments too, and also microplastics we can see on the cores and can be analyzed here, and several studies can be made. Here, it's perfect, yeah. Mhm. Acá nos encontramos en el sector noreste de Caballito, de este monte, y nos encontramos sobre todo en la planicie abyssal. Es por eso que tenemos esta, bueno, acá se pueden tomar las medidas de flujo de calor, ya que tenemos mucho más sedimentos en la base, en la planicie, y el espesor es mayor. Posteriormente, avanzando más tarde en el buceo, vamos a ir subiendo a la cima de Caballito, donde ya estaremos en la parte más rocosa. Aquí iremos subiendo por la ladera a partir de, ya les digo más o menos, a partir de las 12 y casi 1 de la tarde ya estaremos, se supone, subiendo la ladera del monte y observando estas variaciones. Siempre es interesante ver estas variaciones, de cambios tanto del abyssal y ver los organismos asociados. Por ejemplo, acá hemos observado más equinodermos, algunos peces, este gusano que tenemos por acá, poliquetos, algunos estos foraminíferos gigantes que observamos acá. Vamos a darles un zoom. Ceniophéforos. Sorry.
You want 6 of them, right?
Yes. Y ver las variaciones, así que en la tarde ya iremos viendo otro tipo de organismos ya que están más atados a las rocas. También las variaciones en las rocas es muy interesante de analizar acá, así que están atentos y atentas de estas variaciones y qué organismos se van encontrando asociados a estas morfologías. we can place it right around here. Yeah.
Oh, okay, I was gonna
Yeah,
start
yeah.
a little further out and work my way back,
Okay.
but I can come up here first. Where do you want, right about here?
Yeah, a little bit back. Yeah.
Where
There.
the lasers are?
Yes, please.
Okay, there we go. Zoom in. Zoom in.
Aquí estamos colectando seis testigos de sedimento con diferentes objetivos, como les comentaba. Por lo tanto, se colectan estos 6 para poder repartirlos entre distintos análisis, unos que se quedan acá en la Universidad de Costa Rica, así como otros que van para Estados Unidos. It's number 2, yeah.
All right, just a little bit further back from this one, the other one?
Yes.
Like right around here?
Yes. Perfect.
Go to right here?
Yeah.
Sorry, which is this?
Push cost.
And this one, are we gonna be able to, after I take this one, can you just put it right back where it belongs, or do you want it to marinate for a little bit? Do you want me to put this one in,
Yeah.
and then I can stow it?
Yeah.
Or
Perfect.
do you want one of the Xenos?
Yeah.
You want a Xeno?
Yeah. Perfect.
Do you care the back, this one right here?
Yeah, this one. Acá vamos a aprovechar y colectar este semiofósforo con el core, aprovechando. Estos xenofióforos son un grupo de protistas unicelulares gigantes que pertenecen a lo que es a lo que son el grupo de los foraminíferos y viven en estos fondos abisales.
Tree, isn't the tree?
Yeah, and put it back in where it came. Our plan is to put them all back where they came from. Zoom out this stuff.
Bueno, este monte submarino se le ha asignado el nombre de expedición pasada en el 2013 como Caballito. Estos nombres, como les comentaba hace unos días, son nombres que no son oficiales, por lo tanto estamos justamente en esta expedición llevando a cabo el análisis y vamos a solicitar ya lo que es oficializar los nombres a través de las gestiones que se deben realizar tanto a nivel nacional como a nivel internacional. A nivel nacional, los encargados de esta nomenclatura sería la Comisión justamente de Nomenclatura del Instituto Geográfico Nacional, y posteriormente se realizan ya lo que es la oficialización. Ellos mismos la realizan para que queden ya en los mapas y demás. La idea es poder nombrar todas estas estructuras que ya han sido bastante bien estudiadas, se conoce sus profundidades, su batimetría, etc. Bueno, aquí podemos observar, can we take a picture? Yes.
Can I do it like when it's zoom? Will it zoom when it's over the thing?
No,
When it's
nice.
over the thing.
Se pueden observar los cambios de color, justamente estos cambios de color se analizan en la mineralogía.
Do frame grabs if you can.
I got it.
Yes. Yeah, thank you.
Thanks. Yeah. Something like see how it might be hitting that other character soon? Keeping that in mind, right? And just gonna help in here before I get all the way down. And then do the rest.
una... ¿Cómo se llama? Una medusita, ¿verdad? Ajá. Ahí vimos pasar una medusita pequeña, muy bonita.
That's what I'm a little worried about, so get a zoom in as I come, so that they can get,
Estos testigos generalmente miden unos 15 a 20 centímetros.
appreciate Joe.
Ahí vemos en la superficie un sedimento un poquito más grueso y ahí vamos viendo cambios de color a través del tiempo. Y justamente esos cambios y de todo tipo, pues la idea es estudiarlos y comprender cómo cambia el sistema a través del tiempo, también conocer la edad. Para la edad, dependiendo, pues se revisa. Si hay microfósiles, pues se puede sacar la edad con microfósiles. Si son organismos más recientes, pues entonces menor a 50.000 años, entonces tendríamos que utilizar análisis como carbono 14 para poder datar estos sedimentos. Y con esto poder calcular las tasas de sedimentación de los sedimentos en el sistema.
Yeah, if it's hard sediment, hard to sink or something, that would be This is the good sticky stuff, so. Alright, are you ready to go? You want me to go, or you want me to get You want to just have the last one? You want to just keep going, and do that front one, which is easiest? Okay, okay, let's do that. Alright, so next one is 5, which is furthest out, right? 7. 7 is, so this is 7 right here, right? Yep.
Este es más pequeño. Este es más pequeño. A veces dependiendo cómo ingresa el tubo hacia el sedimento y toma vacío, pues tenemos mayor o menor recobro de sedimentos. Yeah. Bueno, posteriormente de la toma de estos testigos, vamos a iniciar la colecta de algunos especímenes en este mismo sector. Y también en lo que es la subida a la ladera, como les comentaba, pues ahí se estarían colectando. Así que va a estar interesante porque vamos a ver otros organismos y... Yes, 5. Sí, 5.
Oh, sorry, yeah. Go for 6, my bad.
Okay.
No worries. I was going for the wrong one. No worries.
Este viene con un cambio muy marcado, ¿verdad? Como hemos notado, este sedimento de material más rojizo, posiblemente óxidos de hierro que se forman en la superficie, entonces hay más oxidación y se alteran lo que es la materia orgánica y este sedimento un poco más blancuzco, en donde generalmente registramos lo que es plancton marino a estas profundidades, constituye principalmente diatomeas, foraminíferos, coccolithofóridos, radiolarios, silicoflagelados, todos estos organismos que viven en la columna de agua a profundidades someras y se van acumulando conforme mueren. Acá sus esqueletitos, los esqueletos están hechos de carbonato, en el caso de los coccolithofóridos y los foraminíferos, y de radiolarios, diatomeas y otros en sílice también a veces y en menos registro, pero a veces podemos tener el registro de dinoflagelados también. Y estos organismos, pues dependiendo de las variaciones que tenemos en el sistema oceánico, por ejemplo, si hay momentos en que estuvo más cálido el mar, más frío, cambios de corriente, etcétera, pues los organismos van a variar también, y esto se registra en el sedimento gracias a esta acumulación, y estos son cambios que medimos y estudios que realizamos desde la Escuela Centroamericana de Geología con otros expertos. Por ejemplo, la doctora Viviana Gamboa, que estudia los foraminíferos y estos cambios en los foraminíferos. Justo ayer tuvimos unas charlas en el CIMAR, en el Centro de Investigaciones Marinas de la Universidad de Costa Rica, y presentando algunos de estos datos en otros sectores del país. Pero también tenemos el estudio de radiolarios que fue presentado por Alexis Rodríguez, un estudiante de la escuela ya licenciado que trabajó con estos sedimentos acá, pero sobre todo en el Pacífico Central, y esas variaciones de radiolarios a través del tiempo en tipo de sedimentos marinos. Así que se realizan múltiples estudios dependiendo de los grupos y grupos de organismos, y también tenemos el estudio de la parte mineralógica. Por ejemplo, la máster Stephanie Murillo, y los cambios de granulometría y demás son llevados a cabo por Maximiliano Garnier, que también es de la Escuela Centroamericana de Geología y realiza estos esos análisis de cambios en las propiedades físicas y mecánicas de los sedimentos. Así que estarían trabajando posteriormente con estos núcleos también. Ya hemos llevado varios estudios a cabo desde el, como les comento, desde núcleos del Pacífico Central hasta la isla del Coco, y ahora este sector que nunca habíamos visitado y tomado muestras. Entonces es bastante provechoso y comparativo también a nivel de lo que es todo el Pacífico costarricense. Todo este estudio integral geológico que realizamos desde la Escuela de Geología. Este está muy bonito, bastante completo este núcleo. Marino.
Yes.
Yes. So we already did that.
Okay.
We finished that
Yeah.
right now. So we will continue with those opportunistic specimen collection.
Yeah. So should I send Bea or Diva or Ora in here?
Yeah. I think Ola is in a meeting,
Okay.
but maybe one of the others. And
Otherwise, I'll come in.
Once you get into a bind like that, you can freeze and then come live again. You can try to come down, or you can just relax your grip.
bueno, ya estamos culminando lo que es la colecta de estos sedimentos. Así que pasamos posteriormente a recolección de especímenes biológicos. Y yo estoy terminando mi turno, así que muchísimas gracias y fue un gusto estar con ustedes. So we are finished the collection of the sampling of the cores, and we will continue collecting some biological specimens. So be tuned. I will leave you for now. So thank you so much, and see you tomorrow.
Try one more time. And I think we're good.
O sea, porque él puede estar hablando mientras usted está dirigiendo la colecta, ¿no? Sí. Mira, sí.
¿Han visto algo aquí? ¿Algún animal interesante?
Sí, igual, pero
No, es que
digo
se
que
va,
no.
no, es que se va a quebrar de todas formas. Es difícil recolectarlo.
Ah, es que Marino está en reunión.
Pero no hizo.
Sigo yo. Si quieres que siga yo, si no está.
Did y'all take my,
Oh, you know what? It's this one?
I had one sitting right here. It wasn't on the clipboard though.
Oh, yeah. You have this.
Okay.
This is the light view.
Yeah, I looked at it for just a second.
No, espero sigue entonces. Bueno, volvemos con Beatriz Naranjo, que va a estar aquí recolectando algunos especímenes biológicos. Ella es ex bióloga de la Universidad de Costa Rica y especialista en peces principalmente, así que les pueden estar preguntando sobre esto. Bueno, muchas gracias, hasta luego, hasta mañana.
Gracias, María.
Okay, go ahead and spell that out.
Buenos días nuevamente. Mi nombre es Beatriz Naranjo, soy de la Universidad de Costa Rica. Vamos a proceder a hacer algunas recolectas biológicas para el Museo de Zoología de la Universidad de Costa Rica, mientras avanzamos a nuestro siguiente punto de muestreo. Primero tenemos que terminar de recoger el equipo, los núcleos que estuvimos recolectando de estos sedimentos. Tenemos alguna lista de prioridades. Estas colectas se discuten previo al buceo de acuerdo a las necesidades que tenemos. Fueron sitios que ya visitamos en junio, así que ya tenemos algunas recolectas científicas que necesitamos mejorar para llenar esos vacíos de especímenes que aún no hemos podido observar aquí en el laboratorio.
So I've got plugged in, and you're gonna have to stow it, so. Alright, what's the next task?
We will do some collections, some biological sampling, but we should move a little bit to explore. We can be moving to
Towards waypoint one?
24.
I'm gonna have to dust off a lot.
Yeah.
I'm
All right.
really
Okay.
late. So,
And if we see something, I'll let you know.
okay, I'm gonna come off bottom, and while he
Alright.
stows this, I'm gonna be dusting off.
Okay.
Oh, you're okay. So let me fill in that right there. I'm just gonna be dusting off real quick.
¿Se acuerdan que también nos estaban? Los caracteres que también nos estaban. Póngale sopa. Me la dicta para dárselos.
863.
Voy. Ujú.
463.
Ok.
8733. 5024. Y el camino a eso está también el disco irregular y el.
Menos 87.
Sí.
Ujú.
Thanks, man. Jim, go first, though.
Como ven, el ROV quedó lleno de sedimento, así que vamos a elevarnos un poco en la columna de agua para limpiarlo un poco.
That's how dirty you are. Just full of mud. So much. Really fun.
Good morning, everyone. I'm here again. My name is Beatriz Naranjo. We will be doing some biological sampling. Then we have some transects to do as well while we move to our next waypoint. We are cleaning a little bit the ROV. A little bit. And J-Rod doesn't like to see all this dust.
No. You always want me to stop and look at stuff from all the dust. For right now, let me just get dust off before. Go there.
Yeah, we saw some star. And afterwards you can maybe start up.
Was that where we saw? Is that where we saw that number?
Close to. There was a star. It's a star.
It's a pink one.
Okay.
Beautiful one.
Yes. Yeah. Look at that.
Hopefully we are going to see
Can
it
you zoom
before
out?
to reach this one because it
Okay.
wasn't the way.
On the same path. Okay. En estas planicies abisales estamos interesadas principalmente en recolectar algunos equinodermos. En el país tenemos alrededor de ¿cuántas especies de equinodermos de aguas profundas? 150.
112 para el Pacífico.
112. Alrededor de 112 especies de equinodermos de aguas profundas. Equinodermos de aguas profundas solo para el Pacífico. Y esos son datos obtenidos a partir de revisión de literatura. Muy pocas de esas especies están realmente en el Museo de Zoología. Y eso es una de las formas en las que se ha hecho ciencia por tanto tiempo. Muy pocas veces las muestras que se recolectan en nuestro país quedan en nuestro país, aunque por ley así debería ser, y es algo de lo que poco a poco hemos ido logrando solucionar, y esta expedición es un ejemplo de ello. Gracias a la co-chief, la cojefa científica de esta expedición, es un punto en el que tiene mucho interés en realmente mejorar nuestras capacidades locales y mejorar nuestras propias colecciones científicas.
What does this thing look like? Was it a white one?
It was a pink one.
Pink.
Can we go closer to the floor because it's
Yeah, let me just,
sorry.
we're going downhill, so I don't want to disrupt this. Let me get you on the east side of this, and then I'll turn around and come towards that way.
Y tal vez aclarar que el hecho de que estos especímenes estén en Costa Rica y no en otro país no significa que otras personas no puedan tener acceso, otras personas expertas, sino más bien que hay un proceso debido que hay que seguir para poder solicitar una colaboración. Somos un grupo de investigación bastante abierto a colaboraciones, pero por ley todas estas recolectas deben permanecer en el país.
Was it a small one or a big one?
It was a very small,
It's a small one.
small one.
I think it's could be in front of
Este pepino que estamos viendo,
over there. I don't know. I'm not sure, but
Yeah, you're probably right. I moved, I went past it, so we
este
can.
pepino que estamos viendo es del género Cicropotes, y me comenta Leonardo que es bastante interesante porque prefiere alimentarse en sedimentos que ya han sido
it was a rock.
que ya han tenido actividad bacteriana, o sea, prefiere sedimentos viejos, no sedimentos nuevos. Así que los equinodermos son un grupo importante en estas planicies y nos sirven como bioindicadores.
Oh, like that thing? No,
No.
that's one of those
No,
carrier
that's a
crabs.
dog.
Alright, I've passed the area in yellow. I'll work my way back a little bit. There's one right there.
Yeah,
Brittle
no,
star.
no, it wasn't a viral star, it was a sea star.
It's there here in the corner.
Oh yeah. Mm-hmm.
Great.
Right,
Thank you
this
so
one.
much, guys.
Yeah, that's
Yeah,
it. I
okay.
got another one.
Yeah.
Lasers on?
We are we are trying. We will try to collect this. Well, we'll not try. We will collect this. How do you call it?
I'm not sure. Could
It's
be,
a Pterasteridae, probably the family, right?
yeah, or maybe
slime star?
Hymenasterid.
Okay. Or maybe Hymenasteridae. Mm-hmm.
I'm not sure if it's Hymenasterid.
We didn't collect this on our last cruise, so it's really important for us to have the specimen and have the time to take a closer look on the lab and in the zoological collection to be able to inform of all this biodiversity we are seeing. Slime star. We are seeing also some tube worms. We tried to collect some on the last cruise, but they were empty. It can be Hymenaster, but it can also be another one, another genus.
Of course. I got eyes on him. He's flying away. Come on, little guy. You pick me up a little bit?
Esta estrella que está en este momento envuelta en una coral quiver. puede ser un himenastéride o un terastéride, según nos informa aquí el experto Leonardo Chacón.
Go ahead.
Se está riendo, pero
Start opening up,
todos sabemos que es cierto.
Start opening up that folder. She said we can go to one, so I assume so.
No, tal vez sí, pero pero ya está. No sé, diferente.
How soft and
It's really soft, I think.
Okay.
yeah, go ahead and just open folder one. I'm gonna free fly here for just a second.
Okay.
Or go for another special game.
Okay. Please remember to zoom in so we can have some frame grabs.
You need more frame grabs?
Yes, we didn't have
Oh, y'all
some.
didn't get them when I was flying in?
No, we were like passing, like flying.
No, just a few minutes ago. when I just got
Okay.
them.
You took the frame grabs? With the
Last
laser
time?
sound?
No, just a few seconds ago when I was
Okay.
here.
Yeah, but there were not a really good picture.
Okay.
Now y'all get paid. I got you. Do me a favor, now grab that suction sampler handle. I'm gonna start coming in for a land.
Cada vez que hacemos una recolecta biológica, nos aseguramos de tomar buenas imágenes con acercamientos para poder ver los detalles. Muchos organismos, cuando llegan al barco, algunos cambian de forma o algunos incluso pueden cambiar de color, así que todas las imágenes que podamos obtener, tanto cuando están en el agua como cuando apenas llegan, tenemos toda una estación de fotografía aquí en el laboratorio. Son imágenes bastante importantes para luego poder
You got it?
caracterizar todo.
Yeah.
Alright, coming down, get that out a little bit further, you're gonna need to come straight on top of it for the most part. What? I need you to have the nozzle facing down, like that facing out. Facing down.
Entonces pueden notar que en este momento el ROV no está sobre el fondo y por eso es un poco más complejo hacer estas recolectas. J-Rod lo que quiere es evitar volver a sentarse, volver a llenar el ROV de sedimento. Así que vamos a
You don't need to do it all right there.
succionar esta estrella porque es bastante suave el cuerpo, así que queremos evitar recolectarla con el brazo para que no sufra
Nozzle pointing down.
o para que sufra el menor daño posible.
I'll go out. There you go. Sorry.
Sí.
De una.
I need to get
Porque habían otros ventos tuyos.
shoulder up, please. You're lower than the south. I need to get an image of this thing. Your arm is just nothing but in the way right now. I just needed you to have the thing pointing down.
Un vento tuyo por ahí.
Me dice cuál es.
Por ahí.
Bastante complicado trabajar aquí en estas planicies sin levantar sedimento. Later we will also want that sea urchin that's over there. The one the white one.
That's here?
Afterwards.
Okay, I'll try to get in close enough to get both.
Yeah. Okay.
You're not lower than the sub, right? I'm not gonna put that in the
Yes, please.
Okay. Good?
Yes, thank you.
Zoom in.
Oh, nice.
Beautiful image
Happy?
of
Yeah,
this
really happy.
slime star, or
So,
what seems to be a
uh,
slime star.
Gonna get this on just a little bit of section.
They're really soft,
And
so we will try
you're
to
gonna
put it with
put it right over the top of it.
with slurp.
Doing weird things. What's that?
Wow.
What's that? Did you see that? Did you see that?
Yeah, it opened this part here.
That was a Stargate. It opened the Stargate.
Yeah. ¿Qué es eso que estaba haciendo?
Nice, es el ano.
El ano.
I think I have enough. You're not gonna wanna touch it. I don't wanna get too much more. Just barely over it.
Alcanzas ahí, chinga. Sí, sí pasa.
Go closer? Yeah, closer. Can you go away from us? Yep, come down there. Right, I do have suction on, I see that, come down a little bit lower. Pull back. Just gonna increase the suction a touch. And let's cut it off. Alright, cut my
Whoa.
suction down.
Woo.
Alright, suction coming down. Hold there, hold there. I wanna get the least amount of section. Alright, that's
Aquí
good.
vemos como los pilotos están intentando succionar la menor cantidad posible de sedimento para que la muestra conserve su mejor estado cuando llega al barco.
All those jerky movements you're always doing. Why did you stop when you told it? You had nothing but time to go to it. What are you doing? What are you doing right now? Go over there. Dude, just turn it up and you work it right there. Like
Oh no.
Lift your arm. That arm movement.
Jerry is quite experienced, so. Second try to escape. Amazing.
Follow me with the camera.
I got it.
Further out. Yes, yeah. So,
¿Perdón? Todos están aquí.
so it's lifting up. Got the suction off, right?
Yep. Great, guys.
Thank you.
Thank you.
Alright, when I drop the nose.
Buen trabajo. Vamos a también intentar recolectar un erizo que está justo enfrente para aprovechar. Ese tampoco hemos tenido muestras anteriormente, así que son dos colectas bastante importantes
Is that a sea urchin right there?
que estamos haciendo.
Great.
Y después de esta recolecta vamos a empezar a realizar algunos video transects. tal vez varios de nosotros hemos comentado, el tiempo es bastante preciado, limitado en estas inmersiones. Tenemos un plan de buceo muy riguroso, ahorita estamos un poquito atrasados, así que son muchas las actividades que tenemos que cubrir y por suerte estamos trabajando con un equipo sumamente profesional en el ROV que nos permite hacer todo de la mejor forma posible. Right now in the control room are with me the two pilots of the ROV Sebastian, Andy and Adam. Adam is manipulating the arm right now. And we have Sofia from the multimedia team. Me acompañan en la sala de control Andy, que es uno de los pilotos del ROV Sebastian, y Adam, también otro piloto que está en este momento a cargo de la manipulación del brazo robótico. Y Leonardo Chacón, que conocieron hoy, que nos ha estado dando algunas explicaciones y que está bastante emocionado por todas estas recolectas de quinodermos que estamos haciendo. A bordo tenemos un equipo científico de costarricenses, somos alrededor de 10 costarricenses. La mitad del equipo científico es tico. También tenemos otras personas del Caribe y de México, así que una representación de Latinoamérica y el Caribe bastante importante en esta expedición. Okay, yeah, it's your turn.
Where do you want to put him?
In another current river, all of them are empty.
Oh, sorry, you want to put, okay, which one?
Number 3, number 2, whichever you want, all of
Okay.
them are empty except for number 1.
Urchin.
So two's empty, you said?
Yeah.
And you also need some close-ups.
Sure.
Thanks. Cada vez que abrimos uno de los, lo que llamamos los coral quivers, estos contenedores, ven que el agua se ve un poco diferente. Eso es porque bajan con agua dulce. Y en el momento donde los abrimos vemos como esta se mezcla. Esto es para evitar cualquier espacio aéreo tiene. Okay. We have that one. I don't know if we are able to do a little bit more zoom on it. Yeah, just to have a closer. Yeah, amazing. Yeah. Okay. Yeah, it's okay. You have that?
Got it.
Okay. Thank you guys. I think we are able to collect it now.
Yeah, we'll have to look at, do you think it'll fit the floor cover?
Yeah, because of the spines.
I mean, I can
Um,
gently help it fit.
Can we try it?
Yeah, I can try. I just, some of the spines might
If you
fall
can,
off.
it would be better to leave the bioboxes
Yeah,
for
sure.
later.
Yeah, we'll look at that.
Este grupo de erizos son un componente también importante en aguas profundas. Sideroida, un orden, ¿cierto? Del orden sideroida. Vamos a intentar colocarlo en un contenedor de los que llamamos los coral quivers. No estamos seguros de que vaya a ingresar por las espinas. Sin embargo, queremos intentar ponerlo ahí para guardar las cajas que tenemos, que son mucho más espaciosas, para otras recolectas que podríamos hacer cuando nos encontremos en la cima del monte Caballito. Yes. Can we adjust a little bit the brightness? Yeah, it's great. Thank you. Okay, thank you guys.
Thank you.
Si se quiebra un poco también, o sea, entre los que no se ven ahorita. if you push it a little bit, and it might break some spines, but we need the space on the biobox. So.
It's right on top. Check it out.
Yeah, so man.
This is currently right too, right?
Sí.
Keep it in it. Like, I think it got one of the jaws in there. Let's see anywhere else. Just put it on there. Let's see something down there, eh? Otherwise, it'll just be pure white.
Sí. It felt
Yeah, he's down in there.
Yeah, it's like this.
okay. Amazing. Thank you.
Esto es cerca del waypoint 3.
Estamos casi en el hueco. Okay. Right now I will need to start the transects. So we want to go to waypoint 4, but we need like zigzags because you need 100-meter length transect each length. We are expecting to be able to do 5 of them, so we can like plan a zigzag where we can cover 500 meters divided in 100 segments and some zigzag towards waypoint 4.
Just before we take off, do you mind if we just swear on the house at the end of 3 so we can some of these things? So that's
En este momento estamos planificando nuestros videotransectos que tienen una longitud de 100 metros mientras nos vamos acercando a nuestro siguiente punto de muestreo, que será el número 4 de 9 que tenemos planificados para hoy.
just restart this.
En este momento estamos preparando la misión. Tenemos una pantalla donde se muestra un mapa con toda la batimetría o las líneas que nos permiten saber la profundidad de todo este fondo oceánico, y en la pantalla los pilotos son capaces de ir poniendo puntos, de ir midiendo distancias de acuerdo a todo lo que necesitamos. Así que estamos haciendo una misión donde colocamos 5 transectos de 100 metros de longitud cada uno. Right now we are preparing our mission to start video transects that will allow us to collect some quantitative information about the abundance and of all the biodiversity we are able to see on the screen. We have been doing this in all of our exploration sites, and we will compare also with the ones that we collect from the past expedition. We have made also other expeditions in the past, so all these video transects are really useful for us and will allow us also in the future to visit the sites again, hopefully, and see possible changes over time. Okay, so we need the laser zone, the zoom on the camera.
Lasers are on.
Okay, yeah, I see them. During our video transects, each of them is 100 meters long, and we use these lasers that measure 10 centimeters that will allow us to measure the animals and the area we are sampling. So we will have the lasers on all the time, and we are not able to stop. And the idea is that we move at the same speed, around 0.1 meters per second, and we try to reach an altitude of 1 meter above the seafloor. Sí, pero sí, estaban limpiando un poco nada más. Okay. En cuanto esta nube de sedimento se limpie, vamos a iniciar nuestro biotransecto. Cada segmento de nuestro transecto mide 100 metros de longitud. Utilizamos estos láseres que ven en pantalla para poder medir los organismos. Los láseres miden 10 centímetros de longitud e intentamos mantener una altitud de 1 metro sobre el terreno, movernos a una misma velocidad de 0.1 metros por segundo aproximadamente. we're starting the bigger transits, but we are having a lot of sediment.
Mm-hmm.
So they're just trying to.
Well,
Really?
yeah, and we don't actually want to transect on the sedimented area. We want to get towards the outcrop.
Okay.
So I would say maybe if we just head towards the next waypoint.
Okay, so you want to skip this one?
Not necessarily skip it, but just, I don't know, how far away is waypoint 4?
It's there. We already planned a mission to get there.
Oh, you
So
done?
there-
Oh, okay. So you
So
designed.
this is 5 transits, yeah.
Yeah, okay. Then just do that.
Yeah. Do we turn on the M3 data, please?
It's on.
Okay. Thanks.
Yeah, that's all you wanna do these, this was gonna be the
So-
third, 1, 2, 3, 4, 5.
Yeah, maybe I would suggest to you, Bea, that we just go to the
Just-
second point, and then
Okay.
maybe,
This one, just 2 transits?
yeah, I think so.
Okay.
Just so we start getting up on those.
Okay, it's okay. Yeah.
Yeah,
We
because
are
we're
kind of
behind
like-
schedule.
Yeah. Okay.
Like this one here, Beth? Start
Yeah.
here, and
All right.
Yeah.
Yeah.
Right.
Okay.
Sound
It's
okay?
Yes.
Okay.
It's the same area, so.
Yeah, exactly.
Yeah. Okay. Okay, estamos un poco atrasados en el plan de buceo, así que vamos a hacer únicamente 2 de los 5 transectos que tenemos preparados en esta zona para poder avanzar un poco con el tiempo e irnos acercando rápidamente hacia el monte como tal, allá la zona rocosa.
that's an updated waypoint for you.
Since we are a little bit
Ahead, behind.
not
Yeah.
behind, we will do only 2 transits here,
Okay.
and so we can move to the outcrop.
Okay.
Alright.
So we're going to the green marker
Yeah, we are going to the
on the line.
yeah, exactly, to do the ones on the line. Yeah. Empezale.
So we're going there to there to there.
And we will
Now
do
tell
just
me.
2. And then we'll do just this one, these 2. I mean, like
Oh, in the along the
marker to
line.
marker and marker to waypoint 4.
Not that one way over there.
No, yeah,
Okay,
it's
got ya.
because we planned a mission with 5.
Okay, got ya.
Uh-huh.
Thanks for this moment.
If you wouldn't mind, if you wouldn't mind, can you come back down like 10 minutes?
I
to
don't
12:30?
know, you can do.
No, you go first.
No, I can wait.
No, you go.
Okay.
And then you come back 10 minutes to 12:30. So at least I have 10 minutes to go get lunch.
Okay, yeah.
Yeah.
Before
Before lunch ends.
Yes.
Yeah.
Okay, it was a pleasure to be again with you. I will leave you with Dr. Diva Amon. Buenos dias.
This is
Do you
transect
want
1. We just started,
Yeah,
right?
I just started. We'll put anything here.
I can always fill it out as long as it's
You want me to leave my computer there?
whatever you want. I don't mind. If
I
you
mean,
want.
if you want to log transits.
Sure.
Okay. All yours.
Thanks. Hi again, guys. Didn't expect to see you so soon.
Before you do anything else, please clarify what I'm going to.
Okay, wait. So we haven't started the transaction.
No, I was told you were going to this one.
Okay, wait. Hang on.
I'm gonna clear out these markers.
So from where? Okay, so put transect 1 end. So we're gonna go from here 100 meters. I think this to this was meant to be 100, and this to this was meant to be 100. So those are gonna be the 2 transects we're running. But since we've now lost a little bit, can we just make 100 meters from where the RV is, and then we'll do 100 meters from that point onwards. And that's all we're doing. Oh, perfect. Great. So then let's go to this.
So
Yeah,
just
right.
go to the middle, the midpoint.
Yes, please. And then from that blue on towards waypoint 4. Thank you.
Yeah. So you're just gonna go from there to the blue dot? and then
Yeah.
That's transact, okay. So I'm just kidding.
What time is it? Okay. Hello. Good morning or good afternoon. Buenos dias. Buenas tardes, todos. My name is Diva Amon. I'm stepping in while Bia's going on lunch, but both of us are actually stepping in for Marino Proti from Universidad Nacional in Costa Rica. We are currently running video transects, which is start of transect 1, please. Thank you. Oh, can we come down a bit in altitude? So ideally we would be at, yes, but we understand a bit more, but try not to go above 2 if possible, please. Thank you. So we're running some video transects right now that we're going to use for quantitative analysis of the animal communities here. We're at a site called Caballito in the Dorado area, about 200 kilometers off the west coast of Costa Rica, but still within Costa Rican waters. We only have until our last dive here is going to be on the 13th of December. So this is a really compact second leg of this expedition. The first one was in June, but it means that we have a lot of priorities during this expedition. A lot of things to collect that we left on the seafloor. We also want to do some exploration, which is what this dive is today, which is really great. Moving on from here, this is really all about exploring this site, doing video transects, doing animal collections of potential species we haven't encountered yet before. So this is going to be a really exciting dive. We're going to work our way up the slope of Caballito. It will likely progress from this sedimented area. We can already see some of these hard, rocky areas starting to come, and that will gradually increase, I'm assuming, as we head up slope because things get steeper. While we're exploring, later on, we're going to be looking for signs of venting, which is what we've seen on Dorado and La Puperia, other sites here. So we're going to be looking for venting. We're going to be looking for octopus nurseries, skate nurseries. This is an exciting dive. New places. This is great. Thank you. So as we're heading up the slope, we're seeing a mixture of sediment animals that live on soft sediments, so things like xenophyophores, holothurians, brittle stars, but we're beginning to see a bit more hard substrate, these little rocky areas. Here's a parapagurid with the anemone hat or butt feature. But because of this mixture of hard substrate we can see the diversity increasing. We're seeing animals that can't live on soft sediment coming in as well. So here lots of sponges, lots of brittle stars, some corals in between, some very, very tiny corals in between. And this is exciting. Thanks, Andy. The rocks. Okay. I understand. Understood. I'm kicking out. Got ya. Balancing all of that.
Look at that, you'll see that. Just touching the bottom, just altitude.
Okay, sounds great. Thank you, Andy. How was lunch, Tyler?
It was pretty good, David.
Okay, great.
Yeah. When did you get a break? Did you already have one?
Bia's gonna switch with me in a bit.
How's your morning going?
Good. Yours?
You know the answer.
Great.
Great.
Some sort of fried seafood spread. Got some roasted vegetables.
Oh, exciting. Okay,
Pasta.
okay.
There are brownies.
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 Also brownies.
And this is still Transect 1, right? Ethan?
Yes, I'll tell you when we stop. We're gonna stop when we get to that blue square, but I'll tell you. Yeah.
Roger that.
Interesting. That's some interesting.
A few little sea cucumbers in there. Some more different types of sponges. Some worms living on the rocks. Hi. Oh, are you 12?
Yeah, I'm
Oh,
12.
great.
So where are we?
Okay, so we're in the middle of transect 1, so we're very behind time. Okay. So we were supposed to sell this at 11:15. We're only now on transect 1.
Okay.
So we're only going to do 2 transects here.
Instead of 5?
Instead of 5. And right now we're going to mark will be the end of transect 1. And then we're going to start transect 2 immediately and continue to the orange, which is the end of transect 2.
Okay, and are they doing it in zigzag or they're doing like in a
No,
straight
straight
line?
line, yeah.
Okay, just
Yeah.
from blue to orange.
Yeah.
Okay.
And so, yes, that's it. Then when we get to the waypoint 4, it's sampling.
Okay.
So I'll hang
Is
around.
okay, that was my question. If someone
I'm gonna
can
hang around
until
until Bia's finished eating and then we'll swap. So
Okay.
we're here.
Okay, perfect. Cool. Nice. Hi guys.
So what's happening?
Is this your laptop?
No, Bia's.
Oh, okay, okay. Okay, good.
Good show.
No, it's okay. You can leave it there.
No, I think she's.
Yeah. So you have to record the end
yeah.
of the transect, and
Yeah.
then when we're starting the transect, you also have to press like start
Yeah.
and then finish this next. Yeah.
Yeah, it's still going.
Yeah,
they
yeah, yeah.
got that.
Yeah, exactly.
In terms of the specs. Tyler, if you can, I know there are rocks, but if you can drop down any more, please do. Let's get rid of they're not on here. Unless I'm back. Okay, I know them by heart. So
Okay.
we're trying to hover. This RV speed is 0.1, which it is. The altitude is between 1 and 2, ideally as close to 1 as possible, but when there are giant rocks like this, it's hard. Lasers on. And then we're not going to change the camera settings, so those are fine. So it's mostly just making sure those 2 things are.
Okay, so 0.1, that's the...
For the speed?
Yeah, for the speed. And for the altitude, 1?
Between 1 and 2 ideally,
okay.
But it's hard when there are big
Yeah,
rocks.
yeah,
And when we're on an incline,
And when-
it doesn't
yeah.
necessarily read accurate.
Yes, exactly.
Okay.
And you just-
yeah. Good. Thank you.
Let's get that as close as we can get.
Muy buenas tardes, les saluda Celeste Sánchez Noguera de la Universidad de Costa Rica y voy a estar acompañándolos por la próxima hora de este buceo. Para las personas que acaban de conectarse, les comentamos que hoy estamos explorando el sitio conocido como Caballito y en este momento estamos haciendo unos transectos. Básicamente transectos en este caso son
por así decir, una línea recta de una longitud determinada, conocida. Y lo que hacemos es que básicamente transitamos con el submarino a una velocidad constante y a una altitud con respecto al fondo submarino bastante estable también. Y eso lo hacemos con los láser encendidos. Si pueden observar en pantalla, se ven dos puntitos verdes que son los láser que utilizamos como referencia para saber cuánto es la distancia y así poder estimar el tamaño de las diferentes especies que observamos. Entonces, con estos transectos nosotros posteriormente podemos hacer un análisis cuantitativo y saber que en una determinada distancia pudimos observar tantos organismos de tal especie, tantos organismos de la otra especie y con tamaños aproximados de tal tipo. Entonces eso nos permite generar información bastante valiosa para poder caracterizar este sitio y estos fondos que estamos estudiando el día de hoy. Are we almost there?
Are we going to waypoint 4? Is that the goal?
Just let us know when we are exactly on the mark of the finish, so we can say like that's the end of the first transect.
And that is waypoint 4?
Yeah, I think so.
Yeah,
Is the blue is with one?
It's not a waypoint, it's just the halfway. It's
Yeah.
It's not anything, it's just the
Okay.
end of the transect.
Okay, so blue's end of transect?
Yeah.
Yeah, so whenever you get to that, tell us and then we're just gonna start number 2 again. Number 2 transect straight away and head to waypoint 4.
Yeah, exactly.
And that's the end of it.
We're almost to the
There.
Can you reel in some tether for me, Claudia?
Wow, beautiful.
Are we there, Jeff? Are we there, Jeff? Are we there, Jeff?
We're almost right on there. What's that? Oh, pull Delta in, sorry.
So I think let's
Why-
just end it in the transect here.
Should we end
It's
it
a
here?
word feature.
Okay.
Transect
So yes,
Transect
please.
1 end, please. And then we can drop down and start
The
on the
next
flat
transit.
tish.
Yeah.
It's a minor option.
We haven't started number 2 yet.
Standing back.
Oh, what a weird feature.
Yeah.
Yeah,
It's like protruding bars.
Lots of nice like llamas.
Yeah, but it's really cool.
they're real in a bunch.
Yeah.
Yeah, it's like valley.
Mhm.
Wow.
Okay, when we're facing,
Yeah.
just tell us when you're ready to start that transect. So Tyler.
Just make sure I'm back inside.
Yeah.
Back that wall. Okay, we should be good to start.
Can we drop down a bit?
Yeah.
Yeah.
Yeah, yeah.
Now?
Start transects.
Yeah.
UI point, thank you.
Oh yeah, beautiful.
Estamos dando inicio en este momento con el segundo transecto que vamos a hacer en esta hora. Lo que hicimos fue alejarnos un poco de la zona rocosa porque en realidad, como les comentaba antes, la idea es tratar de mantener los transectos lo más estables y homogéneos posibles. Entonces, para poder hacerlo a la misma profundidad, teníamos que buscar una zona un poco más plana, con menos rocas de gran tamaño, para así poder tratar de hacer un transecto que fuera similar al transecto que hicimos antes. So what we are doing right now is just like our second transect of this hour of dive. We are basically doing 2 transects at the moment, and the transects will be used later on to estimate or quantify the biodiversity in this area. So what we do is conduct this line transect of a known length, and we try to do it at the same speed, so we can have something that is actually comparable between each other. And of course, we are going to use the lasers as reference to estimate the size of the different animals that are inside of the transect. Podemos observar varias esponjas, algunos crinoideos. Esto que están viendo en pantalla en este momento es una esponja que de hecho tiene sobre su estructura o sobre su cuerpo también un crinoideo. Los crinoideos los hemos estado observando bastante en los últimos buceos. Son, por así decirlo, parientes de las estrellas de mar, de los erizos de mar, los pepinos de mar. Todos esos organismos pertenecen al grupo taxonómico conocido como equinodermos. Y acá, sobre todo en los fondos de sedimento y también en las planicies abisales del mar profundo, en realidad los equinodermos son bastante abundantes y bastante diversos. Una vez que finalicemos este transecto, vamos a continuar con la recolecta de organismos. El buceo de hoy se ha caracterizado porque se han realizado algunas mediciones de flujo hidrotermal en esta zona de sedimentos. Eso lo estuvimos haciendo durante las primeras horas del buceo, y adicionalmente se han estado recolectando diferentes organismos en estos sitios o en estas zonas del sitio que se denomina Caballito. Al final del día, al final del buceo, lo que vamos a hacer es movernos un poco hacia lo que sería la cima de este afloramiento rocoso para explorar una zona que no se exploró durante la expedición de junio. Lo interesante de esto es que en realidad los diferentes ecosistemas acá en el mar profundo tienen además una biodiversidad bastante característica. Entonces, el tipo de organismos que vemos o encontramos con más abundancia en las zonas que están cubiertas principalmente por sedimentos son bastante diferentes a los organismos que encontramos en las zonas donde lo que predomina mayormente son las rocas. Así que por eso es tan importante también hacer transectos tanto en las zonas dominadas por sedimentos como en las zonas que están dominadas por las formaciones rocosas expuestas. Recordemos que el fondo oceánico en general es un ecosistema que de hecho constituye el ecosistema más grande del planeta Tierra y pese a eso en realidad es el más desconocido. Nosotros en este momento podemos decir que se conoce más de la superficie de la Luna que de lo que se conoce del fondo oceánico. Por eso este tipo de expediciones son tan importantes porque toda la información que se genera es información casi que siempre completamente nueva para la ciencia. If you have been following the previous dives, you can tell that the biodiversity in the sediment flats is very different from the biodiversity in the rocky outcrops, and that's one of the reasons why we are conducting these transects here in this area. We have been working before in Caballito Outcrop, but we didn't have the chance to explore all the outcrop in the previous expedition. So at the end of the dive today, we are actually going to try to head up to the upper part of the outcrop to explore an area that it's unknown at the moment for us. Yeah, in the second one.
The end of the mine will do the orange. Yeah, but for some reason we're like behind.
Yeah, we started late. But then it's okay. But
La mayoría de cosas que estamos observando en este momento son muchas esponjas, algunas de crecimiento erecto, con formas bastante peculiares, algunas un poco con formas de tipo campana, pero también podemos observar otras esponjas de crecimiento más costroso o laminar sobre las rocas. También observamos en este momento algunas estrellas, tanto estrellas quebradizas como estrellas de mar, que como les comentaba al inicio del buceo o al inicio de esta hora, son en realidad organismos que pertenecen todos al mismo grupo de los equinodermos. Una vez finalizada la expedición, todo este material que se está generando, este material visual, se analiza básicamente manualmente. Entonces a la mayoría de nosotros nos esperan horas durante meses de revisar detenidamente todas las fotografías y todos los videos que se generan en cada uno de los buceos. Para eso contamos con una plataforma virtual que nos permite básicamente hacer anotaciones sobre el video. Entonces nosotros lo que hacemos es que vamos pausando el video y vamos anotando cuando observamos un organismo, qué tipo de organismo creemos que es. Si no sabemos con certeza cuál es el organismo, entonces nada más se deja, digamos, identificado hasta un grupo mayor, y posteriormente todas estas fotografías se le pasan a expertos para que puedan colaborarnos con la identificación específica de todas las especies. Todo esto finalmente va a constituir una base de datos que nos permitirá hacer una caracterización no solamente cualitativa, sino también cuantitativa con respecto a la biodiversidad de estos sitios. En algunos casos, cuando observamos que hay algún organismo que resulta de particular interés para nosotros, entonces se realiza la colecta, y una vez que se tiene el espécimen a bordo, entonces ya se puede también realizar una identificación más específica con base en las características morfológicas del organismo y también con base en la genética. Acá vemos más esponjas, vemos una anémona, varios equinodermos. Algunos corales suaves también. Esto que se ve como un palito, digamos, blanco, lo que se conoce como un coral bambú, y pertenece básicamente a los corales suaves o corales blandos. Vean que conforme empiezan a aparecer rocas de mayor tamaño, la diversidad o la biodiversidad comienza también a cambiar. Sí se observa una diferencia con respecto a lo que vimos al inicio del transecto, donde lo que habían eran principalmente rocas pequeñas con sedimentos. Acá vemos un pepino de mar. Ese ha sido uno de los favoritos de estos buceos por su forma tan peculiar. Los pepinos de mar nuevamente son organismos que pertenecen al grupo de los equinodermos, y son organismos que cumplen una función ecológica muy muy importante. Ellos básicamente son de alguna forma detritívoros, y lo que hacen es que se alimentan de todas las partículas que se encuentran en el sedimento. Entonces lo que se dice a veces es que toda la arena y el sedimento que se encuentra en el océano en algún momento ha pasado por el tracto digestivo de un pepino de mar. Así que eso sería el dato curioso del día en ese sentido. Vea, ¿qué es eso?
Poliqueto.
Ajá, con esas cosas en la cola, como el, ¿qué sería el iglio? No.
Un poliqueto.
Ok, eso que acabamos de ver nadando en la pantalla es un poliqueto, que es un gusano marino. Observen que las estrellas quebradizas, además de encontrarse, digamos, dentro de las grietas, también suelen asociarse mucho con otros organismos. Entonces es bastante usual encontrarlas, digamos, viviendo sobre esponjas o sobre corales blandos. Como esto que estamos viendo en este momento, que es básicamente un coral blando colonizado por lo que parece ser tres estrellas quebradizas. Si han tenido la oportunidad de seguir los buceos en días anteriores, por ejemplo el día de ayer que estuvimos buceando en el afloramiento rocoso dorado, donde se encuentra en realidad una de las guarderías de pulpos que estamos explorando en esta expedición, pueden notar la diferencia en el tipo de sedimentos. En esta zona, de rocas. En esta zona las rocas están cubiertas bastante por sedimentos, mientras que en el caso del dorado las rocas se encuentran bastante limpias. Esta diferencia es en parte producto de la emanación de flujo hidrotermal que sale entre las grietas en el dorado y que, pues, además de proveer un sitio con temperaturas un poquito más cálidas, también lo que hace es que remueve los sedimentos que se encuentran encima de las rocas, y de alguna forma esto le proporciona un sustrato limpio a los pulpos y también a otro tipo de organismos. Eso es lo que se cree que podría ser una de las razones, no la única, pero uno de los motivos por el cual los pulpos han escogido estos sitios de emanación de agua más tibia para poder colocar sus huevos. Vemos ahí otro erizo de mar, no sé si lo pueden observar, se ve como una bolita con varias espinas alargadas bastante prominentes. Y esto que estamos viendo en este momento es una anémona. For those of you who have been following the dives from the previous sites, you can tell there is a difference between the rocks, for example, in Dorado and from the rocks here. Here we can see rocks are mostly covered by sediments, while in Dorado they are kind of clean. And that's actually one of the reasons why we think the octopus use Dorado and La Pulperida as a brooding point, because the sediment-free rocks provide a very good substrate for laying the eggs. We are getting closer now to the end of this second transect, and immediately after we are just going to continue with the opportunistic collection of different specimens on this seamount. The main goals of today's dive are basically do some measurements in the sediments, heat flow measurements. Specifically, we also collect some sediment cards earlier, and now we are doing some transects and collecting some animals on this part of the Caballito Outcrop. That's a funny shape of that. Vemos otro pepino de mar. Este es diferente al que observamos antes en el mismo transecto. Y como les decía, las luces de los láser nos van a permitir posteriormente estimar cuál es el tamaño de estos organismos. La distancia que hay entre cada una de esas luces es de 10 centímetros. Así que eso los puede ayudar también para darse una idea estimada de el tamaño de los diferentes animales que estamos viendo en pantalla. Están conmigo acá en el cuarto de control los pilotos Tyler y Claude. En la parte de multimedia tenemos a Sofía, y por parte del equipo científico están Oscar Almacén de Cal State University en Los Ángeles, Beatriz Naranjo Elizondo de la Universidad de Costa Rica y el colectivo Pélagos, y mi persona Celeste Sánchez Noguera de la Universidad de Costa Rica. Una vez que finalicemos el transecto, entonces vamos a comenzar con la recolecta de organismos, y para eso vamos a contar con la ayuda o la dirección de Beatriz, que es parte del equipo de organismos o el equipo biológico que tenemos a bordo de esta expedición. Sí, justo después de esto. El wishlist. Ah, aquí está, acá está, ¿verdad?
Sí, ahora agarramos una slime store.
Deberían ir tachando lo que ya agarran, porque
Sí, bueno, ya es que va a ser diferente porque ya no estamos en la planicie.
So do you count the end of the transect when the ROV is just like exactly in the middle of it, of the point, or?
Yeah, usually.
Okay.
But if you want to call it now.
No, I mean, if we do it like in the middle, we can just do it in the middle.
Yeah.
Creo que se suponía que empezaba esto a las 12:15. Estamos 15 minutos.
Sí, no es tanto. Bueno, en realidad sí es más porque solamente hicimos dos en lugar de
Sí, sí, ya lo habías mapeado y
Ajá.
fue como es demasiado tiempo. Hicimos solo eso.
There? Right? Okay, thank you. Oscar, that's the end of the transit, please.
Alright, marked.
Yep, perfect.
Transect to end.
Okay, so according to this, we have 30 minutes to collect animals, right? Okay.
Yeah, but I think we can start like moving it to see if we see something that we want.
Okay, so you mean moving to waypoint 5?
I would say so.
Okay.
We are already here.
Yeah,
waiting for-
exactly, yeah.
Mhm.
Okay, then just
Yeah, yeah.
move around to
It's
that.
not a transit, so I know we
Yeah.
are not supposed to stop, but
Okay. Yeah,
This
but
is
it's like,
something-
yeah, exactly. It's like adjusting. Okay.
oh, that's correct.
¿Quiere conectarlo? So we are going to sample these guys. The Assyrian? Ah, the crinoid. Okay.
It's not a crane.
No?
It's a BC here.
Ah, okay.
Yeah. So we stay here for a while?
So we are going to stay here for at least 30 minutes, not necessarily on this spot, but on the area. And we are going to start collecting animals. We are going to spend 30 minutes on that. But we can kind of do it here and also moving towards waypoint 5, kind of.
Yeah.
So,
I think this would be a nice collection.
Okay.
We don't have any of those.
okay, so then we are going to get that little friend.
Okay.
Thank you. ¿Eso está aquí, no?
Es un... O sea, está como entre estos.
4 horas.
Sí, o sea, es equinodermos, pero es como en general.
Okay.
La mayoría de esos eran en la provincia abyssal, pero no todos lo vimos.
Acabamos de terminar el transecto, el segundo transecto que estábamos haciendo, y ahora vamos a dedicar una media hora a la recolecta de organismos. Entonces, en este momento acabamos de avisar el primer organismo que vamos a proceder a recolectar.
Yeah. And maybe we can like start moving towards it on its waypoint. So we see something we can collect. I think one of our priorities besides this one is here, so okay, put this and move over. Where are we?
We finished waypoint 4.
Okay,
Yeah.
let's do that.
Yeah? Okay.
Okay, great.
Okay. Okay.
We have space for that?
Yeah, I think so.
We're cheap if it comes to us to stop.
Slow stop, thank you.
Can we take a picture with the lasers on close to the specimen, please? So, Oscar, we're going to take the picture, like the general picture with the lasers on, and then with the lasers off, and then a close-up, okay?
Sure. I think it doesn't fit here, where we can do it. Let's see how big it is. Because it's big, but it's flexible.
Yeah, it's flexible. Yeah.
It's a seen its sister.
You let me know when you have the graph, the frame graphs.
Yeah, we need to never collect all of this, so we will have to
Okay, there is with the lasers on.
but it doesn't fit in a part of the group. I think it's flexible, but I don't think it will fit.
Do you have it? Okay.
Go for a close up.
Yeah, we're going to wait for the close-up.
So grab him by the face there.
Yeah, exactly.
Muchas gracias a las personas que nos están escuchando. Saludos también allá a la gente de la Isla del Coco que está en sintonía en este momento del buceo acá en el sitio de Caballito.
I don't know how strong they are.
Es buenísimo ver que los ticos estén, la verdad, siguiendo este tipo de exploraciones de nuestro mar profundo tico. Yeah, can we have a close-up, please?
Yeah.
Thank you.
Sorry, my bad. Good, except for it'll be right back. I don't know. Yeah, so I forgot to test that. Leave that for later.
Yeah, that's good. Nice. Yeah. You got it? Yes? No? Yeah? Okay. Yeah. Yeah. Okay, so we are good to go now. We can try to get it.
You guys want a box? Do you have a preference?
Este organismo que estamos recolectando pertenece también al grupo de los equinodermos y son organismos bastante inusuales, así que por eso vamos a aprovechar para recolectarlo. Recordamos que todos los especímenes que se recolectan en esta expedición están bajo los permisos de investigación que otorgan las autoridades nacionales. Todas las colectas son bastante planificadas, no se recolectan más organismos de los necesarios y se establece una lista de prioridades para saber qué es lo que se va a recolectar en cada buceo. Adicionalmente, lo que hacemos es que una vez en tierra se llevan al Museo de Zoología de la Universidad de Costa Rica, que es el repositorio oficial de organismos.
It might be, but we can use the nozzle to work with it. Just if you knock them off, you pull them in the
Giants get flush.
yeah, that's why I have no bait right now. You just go full suction right now, get rid of that bird. Yeah, that's why it's on 8. Yeah, it's full shot.
Yeah, but it's the nonsense right up here.
Full suction. You can get 1 or 2 legs in there if you want, but you can try in the middle first and then we'll let go.
Como pueden ver, en este momento para recolectar el organismo lo que van a hacer es tratar de succionarlo y sostenerlo con la succión para así poder trasladarlo a una de las cajas que tenemos disponibles para poder colocarlo.
Hold your back, come off it. Okay. You might have to get 2 legs in the jar. And then nozzle. Like, come in from the right, get 2 from the bottom of the barbie. Yeah. 2 legs in.
Right now the pilots are basically discussing what is the best strategy to sample this animal.
Start working it up. Really scoop up so it's figuring out your pitch. That's
Okay.
yeah, full suction on it.
Oops.
You got lost 2 of the legs.
Perdimos 2 de los brazos. Es un organismo bastante frágil y de hecho por eso. So I think that's going to buy a box a.
What it?
Very cool.
Do you have a picture of that, Oscar?
Yeah,
Yeah,
I got
okay,
a picture
good.
of at least one of the legs.
Okay. Oh.
Just get your jaws underneath it. Get your jaws underneath it.
O sea, tratar de sostenerlo con la tenaza. Como les comentaba, son organismos bastante frágiles, así que por eso el proceso de recolecta es bastante delicado para tratar de evitar que pierdan brazos. Los pilotos del submarino son realmente muy diestros y en realidad tienen que ser muy ingeniosos también porque todos los organismos son diferentes, algunos son más delicados que otros, algunos están en superficies o sustratos más complejos que otros, así que casi que tienen que analizar cada caso individualmente para poder determinar cuál es la mejor forma de realizar la recolección.
Suck it, crush it would be.
Yeah.
He said
You got
it's
the suction sample right there, so you grab that now.
Are you trying to get the arms?
Don't try to get up this way, because this is like,
Yeah.
get right in the middle of it. If you come up to the side, it's gonna go up to something.
It's going up?
You wanna come almost
Yeah,
dead on.
because some means like
It is so hot out now that the wind has died down. I was like, oh, you know, it feels more like when we were in port.
Oh, really?
Yeah, because the wind has totally come down.
Oh, good.
Yeah. This is the glass pond that was promised.
Van a tratar ahora de recolectar los dos brazos que perdió. Vamos a ver si lo logran.
Yeah, you might have to grab it. I don't know very good. If you come from the side like the other way, it'll go to something's gonna get stuck.
Al 5.
si vemos algo muy particular, preguntamos.
Como que, bueno,
Ya lo
usted,
sé, el
usted,
otro que vemos aquí.
usted decide. Usted la jefa aquí.
Mucho poder, mucho poder.
Conlleva una gran responsabilidad. Okay. Esto nos va a permitir poder hacer la descripción morfológica del organismo, aunque los brazos estén separados, pero igual es importante poder tenerlos. Y para poder hacer también análisis de ADN. Como les comentaba antes, en realidad todos estos organismos que nosotros recolectamos se identifican de dos formas. Uno es mediante las características morfológicas, pero también con muestras de ADN que se recolectan. Y así podemos tener un banco de información de toda, digamos, la información molecular de todos esos organismos que se están recolectando en estas expediciones. Saludamos a todas las personas que se encuentran conectadas, tanto acá en Costa Rica como en otros países también. De momento J-Rod ya no está en el cuarto de control, pero estamos seguros que va a haber los saludos después cuando regrese. Okay, so now the plan is we continue our way to waypoint 5, and if we spot something really cool, then we stop and collect it.
Cool.
Good? Okay, thank you. Ahora vamos entonces a continuar nuestro trayecto hacia lo que sería el punto 5 de lo que tenemos identificado en el plan de buceo del día de hoy. Si en el trayecto vemos algún organismo que se encuentra en la lista de prioridades de colecta, entonces nos vamos a detener a recolectarlo, y de lo contrario básicamente continuaríamos con los transectos que tenemos planificados. So we are now heading to waypoint 5, and if we spot something cool on the way, then we will stop. Remember that we have a list of priorities to collect, so all the collection of animals are actually following a very specific biology collection priority list.
This is not a transect, this is just...
It's exactly, it's just getting to waypoint 5, exactly. I'm hovering to see if there is anything cool on the way. Some cool stuff. Let me see. We have on the wish list some sea cucumbers, the stock crinoids, irregular orchids.
M3 data.
No sé qué es
I
eso.
think we have this para fotogrametría.
Okay.
Sí, hay que apagarlo después de los transectos.
Ah, ¿en serio?
Probablemente ellos lo hicieron, pero tal vez les pregunta.
Okay. Do you know if the M3 data is on or off?
It's on.
M3, it's on? Okay, I think
Yes.
you have to turn it off after the transect.
Sure.
Thank you.
No problem.
That's it.
That's the one that you want? Wait, I think that's part of the.
I think that's what.
We have ventoturia y ventodites. Okay, yes, a moment. She's asking the expert.
It's over here, right? Just
Yeah,
It's just underneath this.
it's just underneath, exactly. So we think that sea cucumber is actually on the list of priorities. So we are confirming with the expert on board. And if yes, then we will proceed to collect the animal. Al parecer este pepino que estamos viendo en este momento puede ser que esté dentro de la lista de prioridades de colectas para el día de hoy. Entonces, de ser así, lo que haríamos sería recolectarlo. Pueden ver que tiene un tamaño aproximado de 10 centímetros de largo. ¿Es?
sí, no creo.
¿Segura?
Sí, no me dice nada. Pero sí crean uno de los videos.
Okay, so then yeah, we are going to sample these guys.
Okay.
Yeah. So
Rich, can you come here for us? Please. Yeah, sorry about that. We have to run out of sample.
So we do the same, Oscar, like frame grab, general with the lasers on, with the lasers off, and then the close-up.
Where do we want to put this guy?
Where do we have space left? It's
Um,
bio. What about the same bio box that we use for the prison jig? No.
1A is still empty. We still got.
I think we will put in a coral quiver, no? It's a kind of small one.
Yeah, but how many coral quivers do we have left? because we don't want to use all the coral quivers.
Just use two of all of them.
Can I have a look? Thank you.
Yes, we need it.
¿Y pero por qué no lo ponemos aquí mismo?
Okay.
Como muy ordenado.
Es que, y no sé, como que siempre ponemos cosas por
Separadas.
aparte.
Dice como
Ok,
igual,
háblale.
como en los montes, la idea es dejar la mayor cantidad de espacio
Sí.
libre para los... Do you have the pictures?
Taking some right now.
Okay. When you are ready with the general picture, then let us know so we can have the close-up.
Yeah, let's
Yeah,
go
but-
for it.
Okay.
Try to find a little bit.
Okay.
Hispanic is real soft right there.
It's too big for suction, right?
Okay.
¿Dice mañana?
Me acaba de escribir, no entiendo por qué no puedo.
Doing a bunch of close-up shots.
Yeah.
You can do lasers on whenever.
Lasers are on. Let's see if we can get it open for real. There we go.
Nice.
So I might be able to port so we can come down and just kind of.
Got it?
Sorry.
Let's go for the close-up.
Okay.
You guys kind of cradle it. Just get the fingers underneath it.
Tyler, when
That's
you're
what
ready
you
for
guys do.
close-ups.
Wait,
Yeah, unless they wanna.
Can we have the close-up, please? Thank you.
Oh, look at that guy.
Yeah, it's really nice.
Whoa.
Siempre antes de realizar las recolectas tomamos varias fotografías de los especímenes. Primero se toma una fotografía general con los láser encendidos para referencia al tamaño y también con los láser apagados, y después hacemos fotografías macro o un poco más de cerca para poder observar algunos detalles. So,
Pregúntale si cabe en el estudio. Es que si hay problema con mezclar.
okay. Hey guys, do you think that will fit in that coral quiver? It's about 10 centimeters length, right?
Yeah, we're just trying to figure out the best way. Yeah, it's a little bit less than 10 centimeters. So you could possibly slip it, or we can pick it up and put it somewhere.
But it will be fit in the coral quiver? Yes, right?
It would fit in one
Yeah?
quiver, yeah.
For sure? Okay, then just go for the coral quiver. And I think we have space on coral quiver 3.
Right.
I mean, that's up to you. I think they sometimes with the cucumbers they do it with the claw, with the grip, right?
With the soft grips on the right?
Yeah,
or the
with
ones
the
on the left?
I think it's with the one on the. What do you mean by the soft ones? Like the one without the yellow thing.
Is it not the core cutters? Yeah, the port's the one with the.
Okay, vea, normalmente esto lo recogen con la que es como una. No con la que es como un alicate, sino con la que es como así, ¿verdad? Yeah, like the one that it looks like a claw.
Yeah,
I don't know how you call it.
Before I wouldn't be able to reach to a coral quiver.
Okay.
Yeah, that can't come all the way
Yeah.
across the core cutters.
Okay, so then should we try with the suction thing or no? Huh. Because what about if you do it like you did it earlier with the C-Star, that you basically try to suck it up but not totally, just to hold it?
Just put it on there?
Exactly.
I don't know if it's gonna keep me.
Is it, yeah,
Okay.
how
Yeah.
flexible are they?
Yeah, they're really flexible.
Do you think you are able to do it from one side?
No, the problem is they say like they cannot use like the claw thing to put it inside of the coral quiver because it's not possible to reach the coral quivers with that arm. I mean,
And
the other option would be like trying with the other one, the one with the yellow, the cutter thing. Just try to don't cut it in half.
do you think it would be gutted?
We'll try.
Okay.
Just gonna make Conan nightmares for the rest of his life. It's fine. Yeah.
I think we could suck it up. Yes, I mean, I understand it's flexible.
Yeah, we should be able to get through it.
It's like a coral.
Would you rather do that?
Much flexible. I don't know.
Because there is no way for you to control like the suction power of the tool. Can you?
Yeah.
Yeah?
Yeah, we can turn it up, turn it down.
Okay.
So but you don't want it in a suction sample jar?
No, just in the coral quiver.
I mean, if it fits in a
In the
suction
suction
sampler,
sampler?
it's good.
3?
Yeah, the problem will be if it gets stuck, right?
Okay. We can try this way.
Okay. I remember once someone actually picked the octopus eggs with that arm. So yeah. Maybe try with the ones in the middle of the body. They are like longer. Yeah, yeah, that one. Los pepinos de mar son organismos de cuerpo blando, así que lo que están tratando es de realizar la recolecta sin dañar el cuerpo del animal. So, will you put in the suckers?
Yeah, I would for that small of the sea cucumber. Any of the bigger ones, yeah, definitely put in for that small of one.
Yeah. Okay. Then we can just try the.
Yeah, just line up with one.
We are going to be sampling stuff. How we doing?
Good. So we are moving now from grade 0.4 to grade 0.5. And we were just like doing some opportunistic sampling in the way. So I think now we are almost done with the time that we have allocated for the sampling.
Okay.
So basically you have to start, this is kind of like where we are now, more or less.
Yeah, we're on one now.
So you have to start with the transects and you have to turn on the M3 data thing.
What's M3 data?
They know what it is, something to. So are we going to do like two transect in each waypoint, or what is the plan?
Right now we just need to move
To
really
3.
fast to number 5.
Number 5, okay.
Because
Yeah, but once we are in number 5, should they do 2 or 5
we are in
transects?
this one. not
Yeah,
this
yeah,
one.
but it's more like this one, like we kind of like merge.
I mean, this is not past yet.
It's going to be like,
I mean, we are here.
yeah.
From waypoint 4
4
to
to waypoint 5.
Okay, yeah, right.
Are we on the seamount slope?
Yeah, but we
already?
didn't. This was like merging the two
Yeah, yeah.
stuff, right?
Yeah,
So
yeah.
do you think we're going to also do like continue with this collection here?
I think we should
feel like
just
this
go
begins
to
So the
this.
waypoint. So exactly, I think we actually should start like the transects
it?
at waypoint 5.
Do you
Okay.
think you would enter in the chamber? Just
It's in, we're number 1.
Number 1.
alright.
Okay. Okay.
Thank you.
Muchas gracias a todos los que nos acompañaron en esta hora de transmisión. Ahora le voy a dar el lugar a mi compañero Gustavo Ramírez de Cal State en Los Ángeles, quien los va a estar acompañando por la próxima hora. Pura vida y muchísimas gracias por acompañarnos.
Which number is the menu? Number one, right?
So correct. And we are still between waypoint 4 waypoint.
Yeah. Close to waypoint 4.
Transects begin at 5.
Yeah. We
Yeah.
just
They're not.
fly.
They're not 100 meters straight, right? 6, I guess that's what they are.
Yeah. We will be here to advise you.
Okay,
on
thank
that.
you, yeah.
But
Yeah.
for now, just go to waypoint 5.
Waypoint 5.
Waypoint 5. All right, got it.
So the number 163 load.
Good? Alright, so we're just gonna continue on to waypoint 5?
Waypoint 5, please. Yeah.
Alright, coming up. Good?
Very cool.
Good afternoon from the Falkor to all of you joining us remotely. My name is Gustavo Ramirez. I'm an assistant professor at the California State University in Los Angeles, and I will be leading the narration of our current dive 625, a 625th dive of the submersible Sebastian, remotely operatable submersible Sebastian. We are a couple hundred miles offshore the Costa Rican port of Punta Arenas, and we've been here for a week now, exploring a number of very interesting seafloor features, some large enough to be deemed seamounts or underwater mountains. We are exploring the easternmost feature in our search area here, a feature called Caballito. It was originally known as a thermal anomaly, maybe 20-something years back. and first visited with an ROV, with the remotely operated vehicle, the camera. First visited 5.5 months ago on an expedition that I also had the privilege to be a part of, the first leg of our Octopus Odyssey cruise this summer. Today we got a chance to explore this Caballito feature once more with a remotely operated vehicle. So it's the main goals for the next hour is getting to a set of coordinates that we've designated as a waypoint number 5 specifically, from which we will begin video transects. And this video transects are very regimented surveys where we try to keep the nice charismatic eel there. Are they everywhere here, or is this?
I haven't seen so many yet.
Okay.
There's
We'll get
been
a
a
biology
few,
observation.
like 1 or 2. Oh,
Those eyes seem dilapidated.
Mhm.
Yeah. They don't get a lot of action.
You know, it's dark in there. Ooh,
Yeah.
closer.
They'll go the way of our appendix pretty soon. Yeah. So. Yeah. Oh wow. Slightly spooked eel there. Didn't know what to do with all this light. Perhaps it's more light than it's ever seen in its lifetime. So yeah, as I was just mentioning, we are on our way to a set of preset coordinates that we are calling waypoint 5. Once we get to this coordinate on the seafloor, we will begin a series of video transects. So again, video transects are regimented surveys where we try to keep the camera at an unchanging angle, and we try to maintain the vehicle exactly 1 meter above the surface, and knowing we also have laser pointers that which you can see on the screen now. Actually, those 2 small dots right in the middle show us or give us a sense of scale in terms of what we're looking at, and those 2 laser dots you're seeing in the middle are separated by 10 centimeters. So that gives you a pretty good idea of an estimated length for that animal, for example, perhaps 15 to 20 centimeters in length, according to the 2 laser markers. So with the transects, again, we keep a fixed angle on the camera. We have those lasers on for the entirety of the survey, and we try to maintain a consistent altitude above the terrain. So that's right. Once we're on the seafloor, it's easier to navigate, thinking of this as a flight rather than a dive. So we don't go by depth in terms of figuring out our location. We go by altitude, as pilots would flying over the surface of the Earth. Have another charismatic creature here. This little critter. I should say my specialty is microbiology, but I very much enjoy seeing these charismatic seafloor macrofauna. I have no idea what this is. Does anybody know in the room?
It's a worm polychaete.
Worm polychaete?
Yeah.
Yeah. Okay. So word around here is that is a worm polychaete that we just looked at before. To me, it looked like a living fossil from the Brigitte shell. Yeah. And
You're right.
yeah, and a dream of one of my favorite naturalists, Stephen Jay Gould, right? The guy from Harvard.
The guy from what?
Harvard. He really pursued the fossils that look exactly like that, but they had a very special mouth, like a Polaroid shutter, called Anomalocaris. I guess extinct in the Cambrian. Yeah. The rise and fall of Anomalocaris.
Very nice, James.
Yeah. So that's a little of my background in terms of the animal life that I can describe here. My only
Your inspiration.
Yeah, my inspiration, but like my only grounding is things that are already extinct, you know. So that's my bias to everyone in the audience. I am not the best person to describe the macro animal life, but I can tell you all about the microbes that inhabit the sediments that we're looking at. That entire sedimentary layer, which is the majority of the surface area of the planet, is actually alive with an incredible density at the interface between the deep seafloor and the mud there of over 1 million microbes. I'll say closer to 10 or perhaps 100 million microbes in some places per cubic centimeter of mud. So just so that's an incredible thing to wrap your mind around. Again, this world, the Earth, our home planet, that's also just a rock, by the way. So when you see these animals fighting for real estate and rock real estate in the forever plains of the ocean, just keep in mind that we do the same thing in a planetary scale, right? All of us life forms latch on to this 1/3 rock from this random sun, in a similar way that we'll see this animals fighting for rocky substrates at the seafloor. So where was I going with that? Yeah, this rock, our world, our big rock, the Earth, is a microbial world without a doubt. There are 10 to the 30 microbes on the planet. That's a humongous number. Again, 10 followed by 30 zeros. And most of those microbes are found in the ocean. So again, just to give you a sense of scale, there are 10 to the 24 stars in the visible universe. So we are orders of magnitude, hundreds of thousands of times, if not a million times, according to best estimates. We've got a million times more microbes on planet Earth, most of which are in the ocean, than there are stars in the visible universe. Just putting that out there.
Food for thought.
Yeah, a good little thought inspired by this view of the mud. You know.
Are we doing opportunistic sampling, or are we just heading to the next
Waypoint 5, no stopping, and when we get to waypoint 5, we'll begin our series of transects. And I think these are zigzags, but I guess we'll have an expert here leading that transect. It's not straight 100 meters, right?
No, I think they actually
Zigzag.
split it.
Okay.
Yeah, and I don't know if they're actually going to do the same as before, like 2 transects instead of 5. So
Who's leading? Is Beatriz? Or
yeah, she's
okay.
coming.
Yeah,
right
so
away.
we'll drag Beatriz back in here to help us with that. I just know the straight 100 meter ones that I learned from Diva yesterday.
It's pretty much a desert where we are right now.
We stopped and sat down and looked around for a while. Obviously a bunch of stuff, but skimming past it, you know.
The commentary here from Mr. Oscar Almazan, graduate student in my laboratory back in Cal State LA, was that this looks very much like a desert. Yeah, I'm gonna say that's true. even more specifically, kind of like a dry lake bed, right?
Yeah.
Yeah. Yeah, so that's the sense that I get here. As we navigate this abyssal plains of the ocean, there's definitely a sense that I could be driving through a flat, or what is it, a dry lake bed. Perhaps the one that comes to mind, obviously, is Badwater Basin, somewhere in Death Valley in California. And Badwater actually looks exactly like this right now, because it was recently flooded by
Oh yeah.
flash flooding, so it's a lake sometimes. Yeah. Yeah. So. And again, I'll reiterate that both what we're seeing here, the abyssal plains of the ocean, and salt flats, ancient lake beds in the most hostile terrestrial environments, like Death Valley, California, right? Famously known for having had the highest temperature ever recorded on Earth, right? Recorded right at Furnace Creek, California, sometime in the 1930s. Can't recall what the temperature was. 136 perhaps, or something like that. Yeah, both of those places, teeming with life, of course. There's tons of microbial mats that survive under the rocks and in deeper aquifers under Death Valley. And analogous to that, as I was just mentioning, there's even more microbial life. Hundreds of millions of microbes, perhaps, and some of these superficial sediments. Hundreds of millions of microbes per cubic centimeter of mud that we see here. And again, there's a lot of mud all around the world. What is our speed?
We're going
0.2 meters per second?
yes. Trying to get us there quick without outrunning the ship too much.
Yeah, that's right. So yeah, to those of you watching back home, this is flooring the gas pedal for the ROV, considering the physical constraints of this submarine piece of equipment. We are tethered to the mothership. So this ROV, Sebastian, is connected by a very sophisticated cable, a very sophisticated umbilical there, back to the Falkor, our 310, is that right? Foot research vessel on board which we sit, floating thousands of meters above the seafloor. So we can only allow Sebastian to go as fast as it would be safe for a Falkor to follow, because yeah, we're tethered to the ship. So even though perhaps this ROV could go slightly faster than 0.2 meters per second, the speed that we're traveling in now, we would quickly run out of slack on the line and have the line be very taut and pull us back perhaps, or cause some damage. So we got to keep it slow. We're transecting, so that means that both the ship and the ROV have to coordinate this movement of a couple hundred meters from waypoint 4 to waypoint 5. Again, once we reach our destination, simply some predetermined coordinates on the seafloor. Once we reach that destination, we're going to begin a series of transects. And this transects, again, the goal of the transects is to basically drive around with our lasers on and measure, catalog, and record video of anything that we see down there, both living and non-living. And this gives us forest view perspective overall of the ecology of this place. How many species are here of each kind of animal, and what are their relative distributions relative to environmental parameters such as depth, number of rocks. So it's basically an ecological survey that we will be beginning once we get to our set destination of waypoint 5. Nice cucumbers.
Very nice cucumbers.
Yeah, it's a psychopodis.
Psychopodis?
Psychopodis, yeah.
That's one that we've collected last time, right?
Yeah, Psychopodis longitata.
That was a humongous one, right?
Yeah, big
the one that looked like a dog.
Yeah, big chunky boy. The dots of the deep.
So it's very weird looking animals there. We made a couple of collections during the summer leg of this cruise or this expedition. Yeah, they're humongous. Maybe a half a meter. Is that right?
No.
Bigger? Bigger?
Really? Yeah, it was like.
Yeah, approximately a meter long.
It was like 80 centimeters or something.
Yeah, 80 centimeters long. That's a meter, so close to 3 feet. For those of you listening in the States, with a very large diameter too. That's exactly it right there. That's what I'm talking about. So I don't know too much about the biology of those, but I can tell they're extraordinary to look at. Yeah, as big as a small dog, basically. When they came on board, yeah, I was shocked by their size. I thought they would start barking at some point.
Also, this can't.
I was kind of scared. I would have barked back at them.
Like sandpaper. Oh wow! Like shark skin.
Yeah, yeah, extremely rough. Yeah, to the touch.
That is crazy.
Yeah. So that was a unique experience. It was the biologists, macrobiologists, I should disambiguate, not the microbiologists, the macrobiologists on the cruise that were extremely excited about collecting and cataloging a couple of those specimens on our summer leg for the Octopus Odyssey expedition. The specimens that were collected back then now live both at the they're housed both in museum collections in Costa Rica and the United States. Am I correct about that? Yeah. And yeah, so some of these animals are the first to be described. They're genus, perhaps, in some cases. We believe that's the case with the octopus. So it's a tough decision to slightly disturb this pristine environment by collecting animals, but we try to do it while being as minimally invasive as possible every time. Seems like we are just a few tenths of meters away from our destination here, waypoint 5. And again, once we get there, we'll move on to our more guided survey of the seafloor in this area around a seafloor feature called Caballito. Oh wow!
Whoa!
That is massive.
Just alien-looking creature, right? I'm not sure if any of these animals were known from like the very early expeditions, you know, from like the 1800s, perhaps the Challenger. They must have inadvertently recovered some of these, right? Can you imagine what the thoughts of the first human to see something like this, right? Must have been back in the early 1900s or late 1800s. So yeah, it's it's just an alien life form, you know. Yeah.
So beautiful.
Yeah, it's almost like if someone told us that we weren't looking at pictures of the Earth, you know, we would believe it.
Yeah. It's pretty cool because sometimes you get them with the veil, like horizontal, and sometimes they're like more vertical.
What is the vertical? What is the veil?
The lobe.
Is that on the posterior end or the anterior end? Is that the mouth or the anus?
On the posterior end.
So it's the back.
Yeah.
And what do they do with it? What's the anatomical function of it?
Some people it says for sensing.
Sensing.
And for stabilizing sensing the currents.
Okay. Wow.
Yeah, it's
And
like
then maybe
more-
deciding when to go up into a current for locomotion.
Probably yes.
Yeah.
Yeah.
But their main food is still mud, right? Because they have the mud in the gastrointestinal
All
tract.
mud. Yeah. All mud.
So again, we're just discussing the anatomical and potential functions of the anatomy of these remarkable seafloor critters. So what my colleague Sergio Carbonero here from Universidad Nacional in Costa Rica is saying is that the front end of their business is what's moving there at the front. So they've got a mouth that's definitely constantly. Okay, that got us all. Just a bottle that went down in the rocking of the ship. Anyway, that was extra loud out here. Anyway, yeah. So their mouth is actually constantly searching for food in the sediment, and that's been confirmed because I mean it's pretty straightforward to see their gastrointestinal tract. Once you get one of these right in front of you in the laboratory, back on deck, that horizontal surface is the rear end of the business of this animal. And sometimes that horizontal end really opens up. I guess they call it the veil. It really opens up, and it's kind of up in the air as to what the function of that veil is. Again, my colleague Sergio Carbonero was suggesting that perhaps it's a sensory organ to, in this perpetual darkness of the seafloor, be able to sense when the currents change and whether or not they can more or less go airborne. They can just jump up right into a strong current and utilize some of that advective movement of moving currents in the seafloor to move far away. So it's basically aiding their locomotion, their local locomotion. So maybe if they've been at a particular spot eating for a few days and they've exhausted the resources of their local environment, they just wait for a current to come up and they jump right into it and they get swept away to perhaps serendipitously end up somewhere better. So yes, I'm looking at the chat. That is correct. I believe we've seen a couple of these swimming before, and that's what triggered the discussion that we had here in the ROV room as well.
Could you draw up a waypoint from where we are now to like 90 meters?
90 meters?
Yeah. And then
So we have been joined. The loud noise that we heard earlier was the water bottle of Dr. Diva Amon joining us in the room and leading. So obviously Dr. Diva Amon is a world expert in benthic ecology, and she is leading the next set of transects that we're going to undertake now. And again, this is not just video recording. It's got a very specific set of parameters that we need to follow in order to be able to quantitatively trace back the amount of seafloor area that our surveys have covered. And once you have enough of these surveys, you can use some pretty interesting statistics, perhaps involving some linear models that allow you to have an extremely good guess as to the basic ecology in terms of the distribution and the species head counts of animals in this uncharted part of the seafloor. So again, these efforts are led by a team of scientists here, but the lead person here is Diva Amon.
Kina. Just gonna go.
But where's waypoint?
Hey Tyler,
Where's waypoint
yeah,
7?
you're practicing for today? For later on at night?
Huh?
Okay.
What's happening at night?
We might have a little Mario Kart.
Mario Kart, okay.
So I think we're going to 6.
Did you see me drifting around those corners?
Yeah, we got 5 minutes.
Uh-huh.
When are we gonna play Smash? Tyler,
Huh?
when are we gonna play
So-
Smash Brothers?
Right, so we can just go over 7.
When you find
Right,
at least
so
one
then
other person who wants to play
on a
Smash.
marker, can you
I got a
draw
cartridge.
1, 2,
Someone bring it.
3.
To maintain sanity out here, despite
Yeah, we'll find time.
99% of our time being spent on never-ending work. So we're all so excited and it's such an incredible opportunity to be here. To maintain sanity, we do engage in a game activity sometimes. So we're setting up the Mario Kart schedule for this evening's activity. We'll take 10 or 15 minutes to play Mario Kart later tonight. And yeah, so there's local challenges being made between some of the scientists and the ROV pilots. Yeah. So Tyler Smith and Claude Tribuse will be joining us, I hope. These two pilots, these two extraordinary pilots, are manning the ROV session that we find ourselves in right now. Yeah. Masterfully steering this submarine.
Why are you stopped?
Because I'm waiting for you guys. We're at our waypoint here. I'll let you set up where you want to be the rest. I'm not gonna operate all willy-nilly.
Okay, so then can you drive to the green marker? Please. And then from the green marker, we're gonna run transects in transect mode.
Okay.
Sorry, I'm totally like.
You're on. So we're not starting transect now. We're just getting a green marker.
That's because I think from between the green markers is 100, right? Yes.
Sorry.
Is there 100?
I mean, you could just fly from now in transect mode.
One transect.
You just have a longer transect. So we're going to the second green marker. Please. In transit mode, usual jam.
There's zoomed out.
Lasers on.
Lasers on.
Altitude 1 to 2. Speed between 0.1 and 0.2.
The green waypoint, that's when we.
Is M3 data on?
The start.
Yes.
Yeah.
Yes.
Transact 3.
So we're gonna go to waypoint 7
6
with
actual.
transects. So I think it depends kind on what orientation we wanted to do things, but because we're trying to get to waypoint 7, because that's where the next stuff is, and we'll just transect.
Straight line.
Straight line.
So we're going to
Right,
stop
so
it.
yes.
Are we going to stop it?
So basically, we don't need to stop per se, we just need to tell the logger end of one line, start of the other.
You started?
We don't need to stop.
Did you start at the
Just
transit?
keep
Not yet.
transecting.
We
Tell us when you hit the
waypoint,
markers.
on the green waypoint.
We
that's
start
when
on the green waypoint?
Yeah.
Unless someone drops the bottle, I'll start with it.
Keep commentating.
That did sound very
Oh,
bad,
yeah.
I'm sorry.
Yeah.
Yeah, so I think we're in transit mode. Let's just have a slightly longer one. So start in transit 1, please.
Starting transact. This is transact 3.
On this. Yes.
Wow. And we are going.
Did I steal this from you? No.
No. I got my own right here.
You stole it from me.
Sorry from you.
Okay. Transect 3 started at 1:37. It's okay. It's actually on schedule.
Yeah.
7 minutes behind?
Give or take.
Yeah.
So we got
Then
two.
maybe shall we say
We got one. Actually, no. Yeah, we got 2 biosamples like on the way to the waypoint.
Got it.
we do the 5 and then we.
Rich, new waypoint.
See that? Here, here.
Anyway, let's make it. I'm a donut for you. I want the green donut back.
All right, so I'm not sure how much of our little aside here was picked up by the audience back home, but yeah, so we were just getting ready to start our third transect on this dive, and the first transect at the site. We will move on now to our next waypoint, but we are doing this in a very meticulous way. The camera angle has been set to a certain angle. We've got our laser lights on, and the ROV pilots here will try to do their best to remain at a steady altitude of half a meter above the seafloor. Again, all of the observations that we're seeing in this transect are being recorded, and they will be contextualized in terms of the surface area of the seafloor that was covered. And we'll be able to make a pretty good estimate of how much seafloor we're covering by, again, flying in a steady line at a steady altitude, and with our laser ruler on the seafloor being shown in every frame. Which is the camera that's steady? Or is it this one? For the actual transect data?
Yeah.
That one.
Yeah.
So this is not, this doesn't have to be steady, right? It's just for you to navigate.
This one is, yeah. So this is a transect.
This is the this is what I'm looking at here, that.
Yeah, so that camera you see physically in there.
Comes out, all right.
Yeah.
That's the image, okay.
For this guy.
Nice. We got a big one coming up again right here. Is that good? Yeah. That's fine. See. Next cruise. Next cruise. Yeah. We'll open it up to the audience. Switch line. That would be great. That would be something fun to be able to play with play a lot. Yeah. That's what I'm saying. Yeah. Engage the science. Another level. I'm gonna write that in my proposal.
Stream up.
I'm gonna write that in my proposal.
Yeah.
Seriously? Like, I don't think
Audience
it's
engagement. Things have been on the cover.
Yeah. Mario Kart with the scientists.
Deep sea Mario Kart.
Yeah. Deep sea Mario Kart. There you go.
You can maybe reach out to Nintendo.
To make a deep sea, oh my god, track around the sea mountain. You know when I was on the bike yesterday? How long is Dorado? It's like 3 kilometers? Long?
Yeah.
Like,
About,
Yeah, I think it's like 2 kilometers.
yeah, so anyway.
anthropogenic.
Oh, no, okay.
Last
You
bottle.
got that?
Yep, I got it. Trash.
I was imagining that I was riding the stationary bicycle around the Dorado. I was doing the tour of the Dorado in my mind.
That's cool.
So why not do that for real? We have the 3D maps. We should give it to Peloton.
It was on frame, but yeah.
Let's keep that. Let's keep that going. Yeah. And get on the proposal.
Yeah.
That'd be really cool.
I need it if I jam, right? So I'll be like, last 2 years. It's literally one thing.
Yes. Yeah. I'll double check.
We know we're going to start at the first 100 meters.
I'm not sure.
M3 is on.
So I think we have to last sprint issues.
But the main, okay, there is a main.
So no?
Start again, but
What are we talking?
not change.
Oh, it says there. M3, whatever. Okay.
Power down, we're having sprint issues.
Okay.
That's why the X-ray doesn't have very and the nav. So these people think about in the contracts of what that is, how can we get signs of that?
Okay.
Just make a note, I think, in the log.
Make a note that M3 is on, since we started the transect, but there's an issue that the technicians are working on.
Added event.
I think we just passed that first marker.
Yeah, yeah, that's
You good?
Okay, so that's. Oh,
There's like 4 start already.
thank you. Okay, great.
Is this the fourth transect or
This
continuing
is-
with the third?
No, the
Fourth.
Four for the whole dive, 2 at this site.
Got it.
So we have more to go.
Yeah.
So far, since my special care, yeah, we got some first ones.
So the fun continues in the ROB Sebastian control room as we continue our biology transects. Again, so this is video cataloging of all the visible life forms on the seafloor with the highest possible level of resolution, with the intent of counting the biodiversity that we observe. Oh wow. Yeah, I saw the shadow before I saw the fish. Yeah, very nice.
Yes. Standing. And then, yep, more transects. Clear hand short. So basically, the other one was C. There's the other. This is the last line.
We began to see a bit of a transition here in terms of what's in front of our screens. It was exclusively sediment that we looked at for perhaps the last 25 minutes. And now we're seeing the increased prevalence of rocks. So it's a good chance that we're going up slope pretty soon. Not sure exactly where we're at relative to the seamount, but we must be getting closer to this seafloor basaltic feature of Caballito. Oh wow, just a majestic looking sponge here. It's going to come into view at least slightly right on the left side of your field of view there. Wow, just a giant. And again, that sponge needs that piece of rocky real estate to latch onto. So life appears to be a response to the geology of the seamount, and obviously that's not an original observation. People as far back as Alexander van Humboldt were explaining how patterns of life change as a function of altitude on terrestrial mountains. So yeah, this is a very well-known fact that again applies to the mountains explored by Van Humboldt in the 1800s and applies to this brand new mountain that we're exploring today in 2023. You can see those spring-like or corkscrew-like structures on the seafloor. I believe those are fecal pellets. I'm not sure what animal defecated those, but that's what we're looking at there. We see one coming into view here, like almost at the center of your screen there. That twisted material is again sort of fecal pellets, right?
What,
Twisted material?
Yeah.
Yeah.
Most likely. Oh, yes. For sure, yeah.
So yeah, just a record of a seafloor defecation.
I would say it's a pellet.
Well, what would we call it?
Self-serve ice cream.
Compacted poop.
Paste.
Oh, come on.
Paste. I don't know.
Yeah, we're looking for better ways of describing the fecal matter. Yeah, pellet. It's the wrong descriptor for sure. Perhaps what do we converge on? What are we gonna call it? Fecal what? Twisties?
Twisties.
That's nice.
Yeah.
Twisties. I like it.
Twisties.
What about helico-fecal structures?
Helicoidal.
Helicoidal fecal
Helico-
structures.
I like fecal twisties.
Yeah. Fecal twists. All right. Anyway,
Back on track. Transects.
we're having too much fun here in the control room. I figured out a better way to describe the fecal detritus on the seafloor, a more descriptive way. Employing our best Latin and Greek.
Yep, slowing down.
Again, we've had a major change in the structure of the seafloor here. Again, for about 25 minutes since I took this seat, 50 minutes ago now, most of that time we've been looking at completely flat sediment, where there was larger animals like those cucumber, 1 meter looking alien things that were purple. And now, again, with rocks becoming more prevalent, we see just what appears to be an explosion of invertebrates everywhere. We saw a giant, perhaps a 1 meter tall sea sponge, and now we're seeing more corals and invertebrate animals that need this rock substrate.
No, it was a really big sea sponge. So we decided to split it. It was going to fit in.
Hey, how you doing?
Are we still good on the time, or we're already at 4? Yeah.
Right. We can press start, right?
Yeah, I would press start. So Eva,
Yes.
I'm assuming endpoint is the other green line.
Exactly.
Okay.
Yes.
What other thing you could
Again, for those of you that are just joining us, I'd like to welcome you all to our live transmission of the action on the seafloor. Specifically, we are a couple of 100 miles off of the Costa Rican port city of Punta Arenas. in the Costa Rican Pacific, or Costa Rican territorial waters, you are seeing at the Costa Rican seafloor here. And it's amazing. My name is Gustavo Ramirez. I am an assistant professor at the California State University in Los Angeles. I am trained in the microbial ecology, geomicrobiology, and oceanography. So the primary impetus behind me joining this expedition is basically understanding the interactions between microbes and rocks. So we see a lot of rocks here, and these rocks are basically small or relatively, I guess, large protrusions of the first layer of the lithosphere that rises above the sedimented plains of the seafloor here. And these giant edifices of rocks, these are volcanic rocks or basaltic rocks, and they serve as conduits that bring in deep ocean water into the mountain and deep beneath the seafloor, where this rock ultimately connects under the thousands of kilometers of sediment that blanket the seafloor. Underneath that sediment, there's this connected rock that's full of moving water, and that is something that that's a pretty new concept, or very recently studied concept, I should say, in the subsea floor. But that's basically a major phenomenon that ultimately changes the temperatures, the physical properties, the geochemical signature, and the microbiological signature of the fluids as they transit, like this giant rivers beneath the sea floor, and aquifers that are completely buried by the mud. I should mention that we've picked up numerous seafloor rocks at many sites on seamounts in this part of the Costa Rican Pacific. And every time one of those rocks is picked up by our ROV here, our remotely operated submarine, and brought back up to the laboratory on board this ship, me and my graduate student, Mr. Oscar Almacen, also on board the Falkor with us now, we take them into our little part of the laboratory, and we section them using sterilized hammer and chisel. Long story short, once any one of these rocks is split open, biofilms basically oozing out of them, and again, the living layer of microbes inside every possible habitable nook on every rock that you see in this field of view. And actually, that living layer of microbes looks, there's no real way to describe it. It's other than, I guess scientifically it's called an exopolysaccharide substrate that the microbes embed themselves in. But to the unaided eye, it basically looks like a booger. It's a giant living film of microbes that inhabits, again, every rock that you see in this field of view. Densities of hundreds of millions per cubic centimeter of goo, boogery goo, and again, each one of these rocks basically represents what's going on beneath the seafloor in the first layer of the lithosphere, which is obviously the largest continuous ecosystem on the planet. So when we crack open these rocks and we see the living goo inside of them, it gives us an idea of what's actually happening to the Earth. Yeah. Okay, I guess time flies when you're having fun. So my hour of narration is up. I will pass on the baton of leading the narration for these dives to my colleague and a good friend now, as Mr. Sergio Carbonero from Universidad Nacional de Costa Rica. Sergio, take it away, man.
Is this mic on too? We should have a podcast. It's better to talk to.
Yeah. What's that one?
Thanks, Gus, and thank you, everyone. My name is Sergio, and I will be joining you for the next hour. Hopefully, we will see many, many amazing creatures down in the deep. I'm a marine biologist and working in physical oceanography for over more than 6 years at National University. And yeah, I'm really happy to be joining you in this live stream. And here in the control room, also with very, very good colleagues, Dr. Diva Amon and Beatriz Naranjo, which are in charge of the video transects. So a special shout to them, the amazing Schmidt Ocean Institute team here in the control room, the pilots and co-pilots, and our multimedia specialist, Sophie. So yeah, as Gus was mentioning, we're currently focusing on conducting video transects, and this is to have a quantitative approach of things that we see in the seafloor. And this is why we are going at a fixed velocity and direction, and always with the lasers on, so we can have a standardized view of the seafloor. And then our colleagues Diva and Beatriz will quantify and annotate all this video to translate all these pixels into data. So pretty amazing work that we're doing here. And well, as you can see, there is a lot of diversity down at the deep. That's actually a really nice sea cucumber. So unfortunately, we're not able to zoom in because of the video transects, but we can definitely drop a marker if that's possible. Well, okay, maybe not. Because yeah, that was pretty impressive. I think it was a Sinalact, but anyway. Just yeah, sea cuc. So yeah, if you have any questions, any comments, please let us know in the in our chats, either through YouTube or Facebook. Special thanks to the folks who are greeting us in the chat. Thanks for tuning in, and hopefully you're enjoying this as much as we are enjoying it here in the control room.
Sergio, I saw your comments earlier. You're a sea cuc fan.
Yeah,
Can you
totally.
tell us more about that?
Oh, woof. Exactly. Exactly.
You've got an hour to tell us.
Yeah. Yeah. Well, basically, yeah, I would say that I became really interested in sea cucumbers. I think it was like 6 years ago when I attended this Echinoderm Congress in Costa Rica. So actually, some of the folks that are here on board participated of that as well. And yeah, pretty much I realized that, yeah, that the echinoderms, and specifically the sea cucumbers, account for the majority of the biomass at the abyssal depths. So I thought it was, yeah, a great group to focus on if I wanted to do some research on the deep sea. And yeah, throughout the years I've been working in physical oceanography, specifically focusing on the water column. So there is a really particular connection between the sea cucumbers and the water column, because they pretty much feed on the particles that sink in the bottom. And as you can imagine, all these particles depend on the processes that happen at the surface and in the mid-water column. So they have been used as proxies or indicators of the organic matter content that we can find in the deep sea. So yeah, that's pretty much, a very brief explanation on, my admiration and fascination towards the sea cucumbers. And we're definitely getting more and more people into the sea cuc team because they're just they're fascinating creatures. And yes, and you have many different shapes, many different characteristics, even though they're of the same group. And I find that one of the most amazing things of deep sea cucumbers is that they usually roam around the seafloor, but they also have the capability of swimming and display some, I would say, really impressive swimming movements. So yes, I just find that really fascinating. They're a really good reminder of the connection between the water column and the deep seafloor. So yeah, thanks, Sophie, for the question. Oh yeah, I might also mention that one of the very fun facts about deep sea cucumbers, or I guess that any overall animals that roam around eating the sediment off the seafloor, is that they have evolved to withhold all the pathogens that we find in the sediments. So according to literature, the deep seafloor, the sediments that we're seeing right now, for example, are some of the places with the highest viral load in the entire world. So as you can imagine, they must have some sort of defense mechanism to protect themselves from all these viruses that are in the sediment. And there was this really interesting paper back in, I guess, 2017, talking about an endoprotective symbiosis between sea cucumbers that were sampled in the Mariana Trench. And researchers identified that they have a symbiosis with bacteria that protect them against all the viruses that they ingest through all this sediment. So these bacteria have the capability of detecting the viruses, storing the genetic information for, if they come across again these viruses, they will know that they are dangerous, and they will destroy the virus capsid. So these bacteria live within the gut of the sea cucumbers. And yeah, that's one really nice, curious fact or fun fact about sea cucumbers, that they're not only interesting from a taxonomical point of view and ecological, but also they could be, really important part of the next generation of health and medicine advancements. So yeah.
That's wild. Are they born with a immunity that's different than other invertebrates as well? Or do they mostly just acquire it, like you just said?
Yeah, that's actually a really interesting question. That's what we call vertical transmission of genes, and that's not very well studied in the deep. So that's actually, what Janet and others are trying to study, specifically with the octopus, to see if there's a vertical transfer to the baby octopus, or whether that's acquired from external sources, such as the fluids. But yeah, I would say that in sea cucumbers, pretty much is unknown. We are barely, starting to understand the diversity. And hopefully we can with these expeditions, showcase the beauty of these animals, so we can have a baseline for future studies and answer those very interesting questions, Sophie.
Yeah, I already
I'll probably have more soon once I think of them.
So stop here?
No, we will not stay here. We just want to check if we have some other breakfast.
Sorry, I'm just looking at
I
them
have
three here.
waypoint 7. They said that's where.
But should we go straight forward or could you?
So, another fun fact, Sophie, you know what? Sea cucumbers in the deep are bioluminescent as well.
Really?
Yeah, so there is a recent book chapter that was published, I think, like 1 month ago, about researchers that retrieved sea cucumbers from deep sea waters. When they brought them up back on board into the research vessels, they put them in dark rooms and they recorded some pretty mind-blowing bioluminescent patterns.
Oh wow.
So, yeah, of course you need to have some sort of specialized low light equipment to detect that.
Yeah.
And I have been not able, unfortunately, to read the book chapter, but yeah.
That's wild. Do they use it for communication, or like what's the reason for having it? Do we know anything about that?
Yeah, that's a pretty good question. Yeah, bear with me just for a moment, Sophie.
No, it's okay. I'm also dealing with Sprint now. The EMTs are on it. Just keeping an eye out for that.
Vamos a ir al 7 directo. Ok, entonces ya terminamos estos. Ok, ¿qué más?
Go ahead, RV.
Yeah, can you take me to point 6 of the
Es que pueden apagar el...
Point 6 coming out.
Pueden apagar el M3 por ahora.
El M3,
Yeah,
okay.
turn on, right? We should turn it up.
It's on.
Yeah, M3. It's on.
This is not working.
Okay, cool. All right.
I'll let you know if I turn it back on though.
All right.
Yeah.
So yeah, we will keep it going with the video transects. We're moving along to another waypoint, and as you can see on your screen, I believe so, yes, but you can see the lasers. These two lasers are separated from each other by 10 centimeters, and this pretty much allows us to have a spatial scale of things that we see through the video. So this is very, very useful to quantify the biomass that we see down in the deep. And again, this is in a specific role that my colleagues, Dr. Diva Amon and Beatriz Naranjo, are working. And and I take this quote from Beatriz, but I find it fascinating, and pretty much they work on transforming pixels into data. So yeah, as you can imagine, lots of data come out and will come out of these expeditions. So yeah, Sophie, back to the bioluminescence question. I would say pretty much. I don't know personally, and from what I read, I believe there's no very concise explanation so far on why these organisms display bioluminescent patterns, and whether or not if just one type of bioluminescence or if they can do several types depending on where they are, if they're in the water column or if they're on the seafloor. But they for sure it's all across their bodies, so
Okay.
probably will be maybe for communication, or I've read some authors, I think a paper from 5 years ago that suggested that it might be something that evolved without actually being something that has a specific function.
Yeah, that happens sometimes.
Yeah, so yeah, who knows? Many questions.
Yeah, and I might have missed when you explained this, but did you say that the bioluminescence was in the pelagic or in the benthic holothurians again?
So in this case, I think the pelagic ones for sure.
Yeah.
And what we've seen on the benthic ones is that they also have the capability of swimming. So that's what we call demersal. and yes, they both display this bioluminescence patterns. And yeah, since until 2 months ago, when this book chapter was published, there was not a comprehensive review of bioluminescence in this type of organisms. So yeah, we're definitely, when we talk about bioluminescence and deep sea cucumbers, I guess we're talking positioning ourselves at the bleeding edge of science.
Yeah.
So yeah, really fascinating. For example, this Cycropodis that you see on your screen is definitely one of the most common organisms that we can see here, along with, of course, many other creatures. Y un saludo para todas las personas que nos escuchan y sintonizan esta transmisión, ya sea en Costa Rica o en otras partes de Latinoamérica. Mi nombre es Sergio Cambronero y trabajo en la Universidad Nacional, específicamente en el Departamento de Física. Y bueno, pues comentarles que en este momento estamos haciendo un tipo de muestreo que se le conoce como videotransectos, y básicamente pues son secciones definidas con una distancia definida, en donde el sumergible, en este caso, avanza a una velocidad constante y con una visión fija. En este sentido me refiero a que no se puede hacer zoom, sino que se mantiene fijo a través de ese transecto. Y básicamente esto se utiliza para poder cuantificar todo esto que vemos en el fondo marino, porque si ustedes pues se pueden imaginar, no es lo mismo estarse deteniendo, ¿verdad?, y colectando los organismos, haciendo zoom. Esto definitivamente, cuando se hace para una aplicación más taxonómica y más cualitativa. Sin embargo, cuando queremos tener una perspectiva, un abordaje más cuantitativo, usualmente se recurre a este tipo de metodologías, en donde se trata de estandarizar de alguna forma el video que se recolecta. Y este trabajo pues justamente está a cargo de mis colegas acá en el cuarto de control, la doctora Diva Eyman y mi buena amiga y colega Beatriz Naranjo, que básicamente se encargan de transformar los píxeles que vemos en estos videos a datos que luego pueden ser utilizados para evaluar, por ejemplo, la distribución de la fauna, qué tanta biomasa hay en un sitio comparado a otro. Entonces pues es algo bastante interesante de ver. Y bueno, ahorita particularmente creo que no estamos haciendo transectos, pero nos estamos desplazando a un sitio en donde vamos a hacer más transectos. El que está ahí, aquí son como una pirámide. Yo creo que sí, creo que le vamos a hacer. Okay, vamos. Y bueno, como les comentaba anteriormente, tanto para nosotros como para ustedes que nos ven, ya sea en sus oficinas o en casa, pues todos estos videos y esta exploración del mar profundo nos despierta muchísima curiosidad y nos deja con muchas preguntas. Así que si quieren consultar o evacuar alguna de esas dudas, con muchísimo gusto lo pueden hacer a través de los canales de Facebook o de YouTube, y nosotros por acá los vamos a estar leyendo y tratando de responder todas sus preguntas y aclarando todas las dudas de la mejor manera posible. Pues en este caso, pues muchas de las cosas que se preguntan no necesariamente son respondidas por una sola persona, así que si preguntan algo en lo cual, por ejemplo, pues yo no tengo el expertise, dichosamente acá en el barco tenemos a muchísimos expertos también que nos pueden ayudar a responder esas preguntas. Gabriel, can we stop for a little bit?
What time is it?
It's 2:20.
Oh yeah, do it.
What do we need?
Yeah.
Which one?
The sea urchin that we saw, just like I think is like down at this corner.
Oh, jerk back.
Just a little bit. I think it was around here. Yeah, it's a good question. Let me check.
Oh, that big giant one?
Yep, that one. Please. Yep. Thank you. Well, I think this is pretty packed, right? Already with the Brisingit and the other echinoid.
What's in BB1B?
BB1B is for the.
Do you want to put it in with the Brisingit?
Oh, it's not here?
BB1B is the Brisingit.
BB1B is the Brisingit. I should put it here then. Ah, okay. This is the Brisingit. So if we can put it here, that would be great. Just to save some space.
I mean, you're making the calls.
Yep. Yeah. So if we put it in BB1B.
BB1B.
Yeah. Along with there's a Brisingit star there. So I mean. So.
Did I get it right?
No, I was gonna say, do you want help with that?
I'm good. Just make sure the chip doesn't run over me.
Sí, y si no, lo podríamos poner en un quiver.
Okay.
Garrett, do you feel that will fit in a quiver?
No.
No? Yeah, okay. So let's go with the original plan. Two. Okay. Garrett, before collecting, can we have a zoom on the specimen? For the sediment to settle?
Yeah.
Okay. Yeah, let's do it.
Or you can always pick it up and then you get your thing.
Yeah, I think we can wait a little bit, maybe. Just to have it on the, like undisturbed.
Go ahead.
Yeah, can you slow to a no stop here? We're gonna collect the sample and then just.
Yeah, coming to a stop slowly.
Yes.
I think that should be the last until we get
Yeah.
right at home.
Okay. So yeah, can we get like a closer zoom?
Well, not with the lasers.
Okay, so yeah, I think we can.
Laser shot?
Laser shot, perfect. Let's take it up and. Perfect.
You happy with that?
Very happy with it. Yep, let's do it.
Let me measure myself so we're good.
So right now we're sampling the sea urchin, which is part of the priorities of biological sampling of these dives. And after this, we're gonna move along to keep going with our video transects.
Can you also mark? Where is it? Oh, can you mark on this, which we've done?
Yeah.
Like circle them or something like that.
Okay. And if you feel it's possible, can we have a zoom with the
Yep, as soon as
Yep.
we get a little
Okay.
bit more over the
Perfect.
collection point.
Thanks. Estamos en este momento haciendo una recolecta de este erizo, que es un tipo de equinodermo. Está emparentado con los pepinos de mar, con las estrellas de mar. Y este tipo de acercamientos son muy importantes también para la taxonomía. Perfect. Yeah, that's great, J-Rod. Thank you.
I use beard oil.
Yeah.
You want to talk about me?
Do you
Em,
The white one that with your sea star from earlier.
with the sister, yeah.
I think you're good, huh? What do you think? You happy? Okay. I'm dropping it. Boom.
Okay.
It's in the hole. Go ahead and go first.
Neat. Perfect. Special thanks to our very skillful team in the control room, the pilots and co-pilots. This might look easy on your screen, but it definitely takes a lot of skill. So thanks to them. And yeah, we will move on to keep going to our next. Yeah, that's perfect. Thanks, Jayra. Thanks, guys. We will move on to continuing our video transects.
On the move, I'll come back up to 2.5.
Thanks, Ed.
Y como les comentábamos anteriormente, estábamos haciendo una recolecta de un erizo de mar, que es un animal emparentado con las estrellas y con los pepinos. En este caso tenemos un interés particular en este tipo de organismos por dos razones específicas. Una, porque los equinodermos son los invertebrados más de los más abundantes a estas profundidades abisales, y en segunda instancia porque pues parte de los objetivos principales de esta expedición es poder no solamente describir la biodiversidad que está en las aguas costarricenses, sino también poder tener muestras que se puedan alojar en el Museo de Zoología de la Universidad de Costa Rica, que es uno de los museos más respetados a nivel latinoamericano. Así que todas estas muestras van directamente al museo para ser pues preservadas y analizadas de la mejor forma, y pues también con un enfoque colaborativo para que otros colegas alrededor del mundo que estén interesados en estos grupos puedan tener acceso a estas muestras. Aprovecho para comentar también que toda esta expedición, el Octopus Odyssey, tanto la parte 1 que sucedió en junio, como la parte 2, que es la que estamos ahorita, todo ha sucedido y está bajo la gestión de los permisos respectivos con las autoridades nacionales, y pues también looks like
Did you say ooze?
yeah. Esta investigación ha sido gestionada y cuenta con los permisos respectivos, y además de parte del equipo científico y técnico estamos comprometidos con tener el menor impacto posible en los ecosistemas, así que solamente tomamos las muestras que son necesarias para tener el menor impacto sobre estos ecosistemas tan frágiles. Aquí en el cuarto de control tenemos también, como les comentaba, la presencia de muchísimos expertos. En este caso le voy a dar la palabra a mi colega Leonardo Chacón del Museo de Zoología de la Universidad de Costa Rica, que nos va a comentar un poquito más sobre este animal que acabamos de recolectar.
Hola, muchas gracias. Efectivamente, el erizo que acabamos de ver pertenece al grupo de los holastéridos. Este orden es un orden exclusivo de profundidad y la especie corresponde a Cystechinus loveni. Agradezco profundamente a mi colega Carlos Conejeros Vargas de la Universidad Nacional Autónoma de México por este dato y por estar apoyando y compartiendo también toda esta información. Hi everyone, my name is Leonardo Chacon. The echinoid that we just collected before, it's part of the Holasterid groups. This is a exclusive deepest order from the Echinodermata, and the species is Cystechinus loveni. And I am really glad to share this information with you that is shared before with Carlos Conejeros Vargas, a colleague from the Universidad Nacional Autónoma de México. And we are really glad to can share all of this information with you. Thank you all.
Muchísimas gracias a Leonardo por esa información tan detallada y me sumo al agradecimiento a nuestro colega Carlos Conejeros y a los demás también que están sintonizando y que nos están apoyando desde el continente con la identificación de estos organismos, ya que muchas veces pues es necesaria tener la validación de expertos y expertas que ya han trabajado en el caso, y bueno, por dicha tenemos la dicha que en Latinoamérica hay muchísimos expertos que han trabajado con este grupo, o estos grupos más bien, de equinodermos. Si tienen alguna pregunta, algún comentario, o simplemente si quieren pasar a saludar por el chat, con muchísimo gusto por acá los vamos a estar leyendo y respondiendo todas sus dudas y respondiendo sus preguntas y aclarando sus dudas. Y quisiera aprovechar, mientras nos desplazamos al siguiente punto de muestreo, para invitarles a las personas que se conectan de Costa Rica a dos cosas muy importantes. Uno, a que nos comenten en el chat de qué parte del país se conectan, ya que esto es de gran importancia para nosotros saber de dónde, ¿verdad? Y hasta dónde llega el impacto de la transmisión de estas expediciones. Y en segunda instancia, comentarles que el día de mañana tendremos un evento muy especial. Diría que por primera vez en la historia se va a hacer un evento de este tipo, ya que tendremos una conexión virtual en vivo con las personas que estamos acá en el barco, en donde mostraremos de primera mano las instalaciones del barco, cómo es la vida en el barco, un poco de las investigaciones que se están haciendo, también para que conozcan no solamente los miembros del equipo científico, sino también a las personas que forman parte del equipo técnico. Y digo que es un evento único, ya que lo vamos a hacer de manera simultánea en 4 locaciones del país. Lo vamos a hacer en el Caribe Norte, en Tortuguero, en el Caribe Sur, en Cocles, en el Pacífico Sur, en territorio indígena, en Salitre, y en el Pacífico Norte, en La Cruz de Guanacaste. Así que si ustedes están cerca o son de estas comunidades, invitadísimos e invitadísimas a que se sumen a estas actividades. Es mañana a las 3 p.m. que vamos a estar haciendo esta conexión virtual. Y bueno, pues al mismo tiempo agradecerles a todas las organizaciones que nos han colaborado en este esfuerzo de transmitir y comunicar las maravillas del océano profundo. Esto forma parte de una campaña de concientización que hemos denominado Costa Rica Desconocida, y que seguramente van a seguir escuchando muchísimo durante los próximos meses, ya que tenemos una gran intención de que este tema trascienda de la comunidad científica hacia la cultura popular, y pues que realmente este tema sea un tema prioritario en la agenda de Costa Rica. Let's keep going. We're not allowed But yeah, that's great. Can we drop a marker here? Thank you, J-Rod.
I'm gonna have you label it here in a second.
Okay. Perfect.
Is that spaghetti worm?
Spaghetti worm.
Kinda looks like spaghetti.
Yeah, yeah, yeah. Looks like for sure.
That is an anthill.
Oh.
Typing what you want that to be.
The marker? Yep. Okay. Oh, Yoda purpurata. Acorn worm, yeah.
Those are very hard to sample.
Why are they hard to see?
Because the sediment that's inside their gut is enough weight to tear their body apart when you go to lift it. So you actually have to like get rid of most of it or scoop it in them up. That is it. I've only been successful once.
J-Rod, just press enter?
Sure, or I'll just let you try.
Okay.
If that works.
Alright. Thanks. Thank you.
Alright, I'm almost at the waypoint. What are we doing when we get here?
Okay, so once we get there, we're gonna start with the video transects and
Yeah, we
at the
will
end,
look around and make a decision because it's really sedimented.
There's some ridges coming up. I don't know like how, but there's some wavy stuff coming up.
Mhm.
See it my sonar?
Yeah. Mm-hmm.
That's in front of me though, so not where y'all have us set up to go.
That would be a nice place to do it. Como,
Yeah, so it's probably this stuff right here.
perpendiculares a eso, tal vez.
Yeah, we would like to.
You want to
see
just go
the-
explore real quick?
Yeah, to have a.
What's the question?
That it's really sedimented here, but it seems to be more.
So we're almost reaching our point of sampling to keep going with the video transects.
No, we're not video transects.
We are exploring.
No,
and
we're
see
about
if
to
we-
get there. Yeah. Yeah. Come on, guys.
I'm sorry,
I'm
JJ,
at
sorry.
a fixed altitude going set speed. Whether y'all are sitting with that or not, it's a transect.
Yeah, well, there you go. There you go. I didn't say it. No, but I said we are about to reach our point of
Not
sampling.
one of the official ones.
Yeah. Any case, lots of fun here in the control room. So if you have any questions or comments, let us know in the YouTube or Facebook channels while we see this beautiful jellyfish swimming across the Sebastian ROV. Yeah, also let us know from which part of the world you're tuning in. This is very important for the Schmidt Ocean Institute to assess and evaluate all the impact of these expeditions.
Anything else?
More ooze.
A lot of ooze.
Sergio, do you want to tell us about the questions you're trying to answer for your personal research on this expedition?
Is there a personal question? What was the question again?
No worries. I didn't word that very well.
But you can guess.
What? Yes. What specific research questions are you asking on this expedition?
Oh, okay. Well, we have time, right? No. So I'll try to be brief. Thanks very much for the question. As I said, well, I'm a marine biologist, and just for, I would say by casualty, I ended up working in physical oceanography over 6 years ago at the National University of Costa Rica. So yeah, I'm kind of a hybrid between biological and physical research interest. And I would say that my main interest in terms of research is understanding the connection between the open ocean and the coastal areas, and the connection between the surface and the deep. So pretty much that is all about understanding the water column, and particularly at this specific site where we are right now, we have very, very interesting oceanographical features, such as the Costa Rica Thermal Dome, which is an offshore upwelling. And as you can imagine, all this productivity that happens at the surface and ends up sinking by gravity to the bottom of the ocean. And this is why you have so many sediments. So in order to understand the distribution of the sediments, skate.
So do you know, you know about the bamboo corals, right?
Yeah.
About the nodes and the white part, and their relation to the surface in the seafloor?
No.
So the nodes, I believe, are a representation of what's happening on the surface, and the white part is what's happening at the bottom. So if you go into the layers on them, you get a timeline of what was happening at the surface and at the bottom at the same time.
Oh, I didn't know.
Dr. Brendan Rourke was studying that on the Emperor Seamounts. Really,
That's-
really cool. He was looking for the skeletons.
Of the bamboo. Oh, okay. I didn't know that. Thanks, Gerald. I will look into that. What's the name of the researcher again?
Brendan Rourke.
He's the one who did the world's oldest coral one.
Oh.
Yeah, he was at A&M. I'm not positive if he's still there.
Huh.
All right.
The
So
Pacific White Skate.
Looks like a little bit pale.
Yeah, and it's more circular.
Yeah, can we do like... Estamos viendo una raya de profundidad que en inglés se les llama skates.
the other skates that we call a white skate, those are great. This one's actually white.
It's really white, yeah. Albino. Beautiful. Wow, that's beautiful.
Kill the lasers now?
Oh,
Is
yes.
that enough laser work?
Yeah, I think it's perfect. And if we could do some zoom on the eye and maybe like the tail, right? That would be incredible. So what we're seeing right now is a type of skate, deep sea skate. We are not really sure about the taxonomical identity of this one.
I think it's definitely the same family. I mean, Caballito maybe, but it's kind of different.
Yeah. So, as you can imagine, having detailed observations of these animals in their natural environment is crucial to have accurate identification. So this is why we were doing this close-ups. And yeah, I guess that, yeah. So we're going for a swim with the ray.
Don't you stop. Don't you stop. Don't you land. No.
Same species?
No. I got too much to do.
So yeah, we were talking here with my colleague Beatriz, which is really interested in deep sea skates, and yeah, she was telling us that might be the same species that we have been looking in other places, the Batirraja espinosissima, which is the Pacific white skate. Although we are definitely seeing that this one specifically is a little bit more pale than the other ones that we've seen before. Maybe because it's smaller, like a juvenile, maybe.
The one that I saw that was inside the egg case on the last cruise, it was already gray. Like
it was already gray.
With spots and stuff. It was really cool.
Huh. Okay. It's gonna eat that ophiuroid? Eat it. Eat it.
Why are you attacking me?
Beautiful footage that we're seeing right now, live from almost 3,000 meters depth off the Pacific coast of Costa Rica. This is what we like to call Costa Rica unknown, or Costa Rica desconocida.
Did he just use a foot?
It's a male, right? No.
Yeah,
It's a male.
Yeah.
Is this
It looks like he used a foot to turn.
Yeah.
Has some weird things underneath.
What species of skate is this?
Most like, well,
It resembles the Pacific white skate, but it's a smaller one. So we will check.
a little bit more pale. But yeah, it's
Definitely the same family.
Batibraja spinosissima, the scientific name. But yeah, to be confirmed.
Tony Hawk.
Tony Hawk. Yeah, Tony Hawk must be happy watching this.
Hey Tony, if you're watching this.
All right. Anything you want me to zoom more on, or are we going to stay with it a little bit longer? You know, I'll stay with it all day if you'll let me. So.
Yeah, I think we're good.
I would do that as well, but.
Okay.
Yeah.
Moving on.
All right, bye, little guy. Oh, that's a Joda purpurata, right? Anchor worm on the back. So yeah, lots of different creatures right now. High biodiversity at this particular seamount that's called Caballito.
Those ridges were actually real lazy ridges. You can see it right here.
Mm-hmm.
It's nothing dramatic.
Yeah, not true.
So,
Hmm.
do you want me to still keep going southwest? Do you want me to go actual west?
We have a dive plan.
I think
Yeah.
there is the plan. You have to
Yeah.
go up until the waypoint 9. Where are we?
Just
I
past
think in 7.
I'm ready to
So
go.
we have to go to the.
Yeah, we're looking
9.
for a place where might be more not so sedimented for good transits, but it seems like it's everything the same.
Okay, so
We're going to stick with the plan.
start going towards waypoint 8.
8, please.
Roger that. Oh, I'm surrounded by NGs. I don't like it right now. It's working fine for me though.
Yeah. I'm not seeing the.
So very cool stuff we're seeing right now in our dive here at Caballito Seamount, which translates to little horse.
Okay, well, we can deal with it later.
This is south of this site that we're diving currently is south from the main site, which is called El Dorado. And as you have already seen, there are many different differences between the sites. And this is part of what we want to quantify and understand better. So what are the difference between the seamounts? What's the difference between the different types of habitats around the seamount? So from the abyssal plain through the slope to the summit of the seamount. And this is all being part of the main priorities of this expedition.
Doesn't matter, they're both working. Just trying to get out of this.
So we will keep going towards our next waypoint.
Keep an eye on it to make sure you're not drifting too.
And yeah, let us know if you have any questions or any comments in the YouTube or Facebook channels. Y acabamos de ver como vieron previamente, acabamos de ver una raya de profundidad. Todavía no estamos muy seguros de qué especie podría ser. Preliminarmente pensamos que es una raya blanca del Pacífico, muy similar a las que hemos visto anteriormente. Sin embargo, esta pues es un poco más pálida, más blanca que las que hemos visto previamente. Entonces todavía no tenemos una confirmación oficial de la especie. Y bueno, pues por eso fue que estábamos tomando los acercamientos de ese animal con el que tuvimos la dicha de compartir unos minutos. Y acá, bueno, vamos a seguir en nuestro rumbo hacia el siguiente punto o waypoint, mientras vemos todos estos animales en el fondo. Vemos peces, equinodermos, muchísimos también, bueno, en este sitio en particular no tanto, pero algunos corales también. Hemos visto gusanos y muchos de estos animales causan o dejan una marca, una huella en el sedimento, y esto también, aunque no lo crean, pues se utiliza para tener una idea de la actividad y la cantidad de animales que existen en el fondo. Y bueno, en inglés se le llama bioturbation y creo que en español es bioturbación también. Sí. Y básicamente eso es pues un indicador también de muchos organismos que muchas veces no podemos ver en la superficie, pero que están hundidos en el fondo. Can we drop a marker here, please? ¿El tiempo para mostrar? No. Ok. Cualquier cosa. Este sería así. Si hubiera tiempo luego de mostrar, este sería así, creería top. Sí, acá le dejamos el waypoint. There you go. Thank you, Jera. Acabamos de pasar como vieron, un pepino de mar muy interesante que estamos particularmente pues interesados de recolectar y estudiar. Así que dejamos, como estamos apegados o apegándonos a un plan de buceo que tenemos que seguir, cuando vemos algo interesante y no tenemos tiempo, entonces dejamos un marcador en el mapa para después. Ahí estamos viendo un gusano que le llaman el espagueti gusano. A su derecha podemos ver un pepino del género Cicropotes, que son organismos bastante grandes, y como pueden ver, la mayor abundancia de organismos está compuesta por los equinodermos, ya sea estrellas de mar, estrellas quebradizas, pepinos, erizos, y por eso es que este grupo es tan importante de entender y de estudiar. De nuevo, si tienen alguna pregunta o algún comentario, nos lo dejan saber por los canales de Facebook o YouTube, y por acá los estaremos leyendo.
Starting question 5, transects, straight lines, so are we doing more, or we got enough already?
Yeah, and I think we want to do more, but at the time, they were kind of wondering. But
Okay, so right now I'm just getting to waypoints, following the line.
Yeah, exactly.
Opportunistic videoing.
Yeah, exactly.
Fair enough.
Sí,
Hay bastante espacio. Yo creo que si quiero agarrar el pequeño,
sí, ya.
de todas maneras usted ahí está.
Y tiempo, okay. No, okay, Jiro, can we go back to the Ventothuria marker we dropped? Sorry, but apparently there is a chance, so let's go for it.
Creo que no vamos a hacer transects aquí porque es por el mismo segmento que hemos estado viendo.
Okay. Okay. Yeah.
Yeah. Quick what? Zoom or whatever that weird thing is?
Yeah.
I'm all for it.
Is that wood? No. It looks like wood.
It looks like a sponge, but covering something. It doesn't look like that's the natural sponge. It looks like there's...
Isn't? Yeah, I agree.
Yeah, like...
It looks like a wave one. Yeah, it looks like a whale one. Yeah. Okay. Okay. So we're gonna collect both. We're gonna collect this look-alike bone and then the holothurian.
Where's this going? Mailbox, I imagine?
Yes. Let me double check. That would be.
If you collect these two big things, that's it for biobox.
Things that make you go,
We still have
I mean, if you're okay, I'm okay.
for small stuff. Yeah.
Yes. BB3B.
BB3B is free, BB2 is free, BB1A is also free.
Yeah, I think actually we can. Yeah, looks like a sponge.
No.
Growing on top.
Yeah.
Like growing on top.
What is bigger, the sea cucumber or the?
I think they're pretty. Maybe they're the same size. Yeah, and even if you agree, maybe we can put it on the same.
Oh, the same.
Size. Yes.
Okay.
Do you think they will fit? Yeah. All right. So let's try have that as a plan A.
any particular spot you wanna look at? I mean, that's the only part where you see maybe some
Yeah.
rocky stuff in it.
Rocky. Yeah, I would say. Yeah, with this, maybe just one with the lasers on.
Yeah, lasers are still on there.
They're still on. All right. So yeah, it's roughly about 30 centimeters, maybe.
Yes, I have it.
No, it's 40.
Yeah, I think with that view is fine. Maybe we can go ahead and try to.
Collect it?
Yep.
Okay, you
Put it
said-
in. Yeah, I think we will aim to have this and the CQ in one same bio box. So we have maybe BB3 if that's possible.
I think that's a good one for this
Yeah.
arm, yeah.
Okay, yeah, let's do it. BB3.
BB3A has some samples, but BB3B is free.
Yeah, BB3B. Okay.
Yeah, just cradle it. I wouldn't.
So, yeah, we're about to sample this object that looks like it's covered with the sponge and, well, of course, other animals. Yeah, we're wondering whether it might be a whale bone, or maybe a wooden log. We don't know, but we're gonna collect it to find out more about it.
Yeah, I got a dust storm coming behind me, just so you know.
Okay. And after this, we're gonna sample the holothurian we saw earlier. So, I'm gonna take the time to say that while we sample this, all this expedition processes and samples have been approved by the Costa Rican authorities. So all permits are in place to conduct this sampling, and we aim to minimize our impact in the environment, so we only collect the minimum amount that we need for our scientific purposes. So in that way we can understand better and study while reducing the impact to the environment. ¿Qué muestra sería esa?
Esta es la 165.
165, ok. Guys, if it's possible, before putting in the bio box, to have a underneath view, that would be amazing. Thank you. ¿Cuál? Ah, eso que
Bring it back down on that. Yeah. And then go back to the bottom. You gonna open or you just pull it off there?
Estamos en este momento muestreando este objeto que parece ser estar recubierto por una esponja. Okay, so maybe it's not necessary to turn it around, just put it there to avoid things falling off. So, yeah, thank you. Estamos muestreando este objeto. So yeah, BB3B. Y bueno, pues nos encontramos con este objeto de nuevo que no solamente tenemos un interés de ver qué es el objeto en sí. Tenemos la evaluación preliminar que pudiese ser ya sea un hueso de cetáceo o un pedazo de madera que está sobrecrecido por esponjas, por una esponja, que eso es la cobertura blanca que pueden ver. En todo caso, la vamos a recolectar para estudiarlo más a profundidad y luego de esto vamos a muestrear un pepino que dejamos atrás hace algunos minutos. Unos centímetros, ¿no?
Like that as much as possible before we get on it. Can't do back move too much more before you're gonna hit it with
Yeah. Thank you, guys. Do you think it will be a space in that same compartment for the cucumber?
I think so,
Yeah. Okay. Perfect. Thanks.
I think you got it. I mean, as long as you get it, like, if you rotate a little bit more counterclockwise, and there you go, like that, you just put it in there, I think it's gonna naturally wanna go.
Oh, okay.
Now you can bring your jaws out and then just kind of like hit the front of it. Try to push it back. Yeah, if we could. Try. I was trying to get it going like this.
Yeah, right.
At the angle that is, but that bottom part more kicks out. So I think if you drag it, you're always going to tip it.
Right.
You just can't get too
It's weird.
So like come all the way out. Get your arm
We are
be a little bit more
finishing to sample this object. Yeah, we have many hypotheses, but yeah, I guess we will validate them once we have it back on board. And after spending some time with it, we might confirm whether it's a bone, whether it's a wooden log, whether it's another anthropogenic object. We don't know, but what we know is that definitely has some biological associates to it, and that's already fascinating for us. So it's definitely going to be a really interesting sample to analyze. So thanks everyone for putting your comments and questions and all the suggestions you have. Definitely help us a lot also to handle different versions from the one that we have here.
Can you just push on the tip? Down that down.
Well, so we have a fun fact time by our colleague Beatriz, and she just reminded us that this is the same place that we collected last time.
The other one?
The other whale.
It looked like this
whale
without
bone.
the sponge, right?
Yeah. So that other one was kind of already petrified or fossilized. So yeah, very interesting coincidence. Yeah, and we will confirm that once we have it back on board. So that previous bone we got in the last expedition was confirmed to be of extinct civet whale. Might be too long. So is there another place we can put it?
Is it all the way back? Yeah, it's all the way back in the corner. I mean, we could try to force it in there a little bit, like we could maybe, I don't know, the oath that you have in this one, how important is it that it's separated from that?
Like to force the separator?
To come over, yeah?
Yeah, I think that's fine.
I mean, this is a pretty important thing, right? These
Yeah,
little-
totally. Yeah. No, and the bruise it's not gonna get hurt by that. So.
Yeah, so like, I would go in and get your divider and try to pull it a little bit from the top. Yeah. That's a good way of saying break it.
I'm telling you, customize the divider.
Have your jaws touch it. Like your jaw right now. Touching inside that divider and then close your jaws. That'll pull that whole part.
So yeah, really exciting part of this dive, trying to collect this object. Yeah, we have a lot of potential identities for this object, but again, we cannot tell or confirm anything before actually having it back on board. So stay tuned for our dives during the next days. We might have a preliminary confirmation on the identity of this enigmatic object. But yeah, definitely we're throwing some bets right now, and probably it's a bone. And as I was saying earlier, this is the same place, the same spot in which we found last expedition another civet skull. Estamos muestreando este objeto que parece ser un hueso, muy probablemente algún cetáceo. Pues estamos tomando la muestra. Si ven, tiene como una recobertura de color blanco que parece ser una esponja. Y bueno, pues es muy interesante porque justamente nuestra colega Beatriz Naranjo nos acaba de comentar que este es el mismo sitio que la expedición pasada en junio recolectamos otro hueso fosilizado de un tipo de ballena que ya está extinto, pero que sin embargo los colegas geólogos y paleontólogos con los que se hizo la consulta a través de nuestra colega María Sandoval de la Escuela de Geología de la Universidad de Costa Rica, pues pudieron confirmar de que efectivamente es una especie. El pasado que recolectamos en junio es una especie extinta de ballena o de sífido.
Sergio, do we know what kinds of analyses were done last time to determine what it was?
Yeah, maybe.
The expert said it had probably like 50 million years from the Miocene, but I think there is
I think you made it. Like it's touching that corner.
Yeah. Yeah, that's actually.
It's definitely a distinct species from the Miocene, but we're not sure which one.
Yeah, and I would say, just to complement that, as Beatriz said, that as per our colleague, it was pretty much based on the visual analysis, on the morphology.
Okay.
I think they're aiming on doing like further analysis to determine like the structure, but so far, just based on the morphology and visual inspection.
Very cool.
There you go. That's
Yeah, because you can tell a lot about the shape of it, and also she was mentioning that also the crust that forms on top, that also tells it's a proxy to understand the age
Cool.
of the specific. Yeah.
And is that from like organisms accumulating on it, or is that purely like chemical, like a change over time, that crust?
Both. Yes.
Both,
Both.
okay.
Yeah. So it's usually an interaction of both
Okay. Cool. I
organisms,
didn't know that.
microorganisms precipitating those minerals over time. Yeah,
Every day is a school day.
yeah, really
It's
cool.
great.
True story.
True story.
Just
Facts. I was there.
so what you're seeing on screen is just the pilots and co-pilots are trying to maneuver and to make it fit inside the box. And
We're modifying the biologics.
modifying right on the fly. Yeah, so yeah, it might look easy, but let me tell you, it's not. Thank you, guys.
You still going for that?
Yeah, for the cucumber on that same one.
Yeah, it'll fit in there now.
Perfect, thanks.
We made all that extra room. You won't put,
Very nice.
3 things in there?
Another modification.
So yeah, I'm doing a little bit of extra time until we get the sea cucumber. Then I will hand it over to our colleague, which is already in the room, Dr. Odalis Cabriti. So stay tuned, and if you have any questions related to corals, she's the expert and definitely the person to go. So we're gonna go back just a little bit to where we saw that big boy, big chunky boy.
Chunky
boy, let's go. Bueno, acabamos de ver la recolecta de ese objeto que de nuevo parece ser un hueso. Todavía no está confirmado. Eso tenemos que validarlo una vez que tengamos la muestra a bordo. Y ahorita nos estamos devolviendo un poquitito para muestrear uno de los pepinos que vimos anteriormente, que justamente lo vamos a acomodar en esa misma caja. Una vez terminado ese muestreo, le voy a dar el paso a mi colega, la doctora Odalis Cabriti de la Universidad de Costa Rica, que es experta en corales, específicamente corales blandos u octocorales. Así que si ustedes tienen alguna pregunta, alguna duda que quieran evacuar sobre los corales de aguas profundas, la doctora Brady es definitivamente una experta en el tema y estoy seguro que ella estará muy feliz de contestarles cualquier duda que tengan al respecto.
So that was that spiky one, right?
Uh,
It was purple with a whole bunch of spikes on it?
Yeah, the one that was like round
Yeah.
with some cilia up behind. Yeah.
Like all those.
Stretch.
Zoom on that one.
I think that's one on the back, right? Maybe.
That looks like one of those giant ones, but I'll go up to it because that's right around where the breakpoint was. That looks like one of the ones with the little.
Oh yeah, no. Yeah, maybe it's
But
a
it
little
was
bit
right
further.
by it, though.
Yeah. So exciting. I see a question on what was while we are transiting to get that biological sample of a sea cucumber, I see a question on what was the coiled tube that was next to the object we picked up in the substrate, and yeah, pretty much was fecal material, let's put it that way. So yes, probably most likely by a sea cucumber, maybe an acorn worm.
This guy right here, right?
Yeah, I think it's that one.
And Biobox.
Biobox 2B. No, 3B, sorry. BB3B.
We'll do the same thing.
Yeah. It's cradle chocolate.
Ay, es que eso, el que vimos anterior tenía la
Sí, sí los tiene, ya se los
Sí.
Sí, es que...
Perú.
Sí.
Stay put. Nice spot for it.
Let's get some shots for them real quick.
Beautiful. So we're gonna get some close-ups of this beautiful sea cucumber we see here. So you can see it's roughly about maybe 20-25 centimeters long. And the one that you see next to it, the one that's more transparent, it's one of the many organisms that are known commonly as sea pigs. They're not only one family. Perfect. So yeah, we got one with the lasers. With that, perfect. Oh yeah, so I was telling you that we're going for the biggest one, the one that's on the right, but the one that you see on the left is also really interesting. We're not collecting it because we already got a sample last time, but that's, as I was telling you, it's part of the group that is commonly known as sea pigs. As we see this big boy doing his thing, number 2. Alright, go for it. Last dance.
To start doing that means they're about to fly.
Alright. Oh. This guy can be pretty fast, pretty fast, as you can see. So yeah, and talking about the other one, the sea pig, this might be either of the genera Peniagone or Amperima. And again, they're really interesting. We're not collecting them because we got a sample last cruise. So as I was mentioning earlier, we try to minimize our impact on the environment. So if we already had a sample, we are not just collecting just for the sake of it. So, but on the other hand, the one that you saw, we believe might be belonging to the genera Benthoturia. We do not know so far, and this is why we want to collect it and have a closer look once we have it back on board. So yeah, you might think these guys are lazy and slow, but they're definitely pretty agile and fast. But yeah, definitely not faster than our pilots here. Okay.
Amazing.
Neat. Perfect.
Is it okay if he goes in the suction jar?
Yeah, perfect.
Want to go over to the one I need to go to then?
That was amazing. Okay.
I'm going. He's still in the hose.
Still in the hose?
Yeah, I have it. I stopped it because I wanted to make sure I went to the correct one, which is gonna be 3, right? 3's open.
Oh yeah, only the number 1 is.
Only one, yeah.
Okay, then I'll go to 2.
2? Okay.
Alright, coming to 2.
So it doesn't clog it up. ¿Qué muestra es esta, vea?
166.
166. It's gonna be a long road. Okay. Oh, okay. Okay. Is it there?
Oh yeah.
Yeah.
He's all up in there.
All right, 166, ¿verdad? 2. All right, perfect. Thank you, guys.
Sorry.
That was impressive.
Sorry, step ups.
Yeah. So, yeah, well, after seeing that very special collection, great moment of the dive, I'm going to hand it over to my colleague, Olalis Cabriti, coral expert from Universidad de Costa Rica. So, thank you very much and keep enjoying this live stream. And stay tuned because we might watch some really, really amazing creatures and underwater landscapes.
Alright, continuing on to the next waypoint, right?
Yes, yeah. We go through with the plan. Now.
You have so many guys coming up. Like, this is
Good?
kind of their
Good, yeah. Great job with that whale.
Hello, everyone. We are in the seamount that is called Caballito. We had already collected some specimens of echinoderms that are some of our target species for this dive. We are moving up to the summit of this small seamount and to try to find some corals, maybe some mollusks also. We will see. Hola a todos. Estamos en la monte submarino que se llama Caballito y ya estamos haciendo una exploración. Aquí el sustrato es más que todo, como lo pueden ver, más lodoso y hemos recolectado varios equinodermos que son uno de los organismos de interés en este buceo debido al tipo de sustrato donde los equinodermos son muy característicos. Ustedes pueden ver una gran cantidad de estrellas frágiles o fiuras ahí en el fondo, algunas rocas y muchos pepinos de mar. Hemos recolectado también un equinodermo, un erizo de mar, y que es otro de los equinodermos, otro de este grupo. Entonces en este grupo tenemos pepinos de mar, estrellas de mar, ofiurodeos, o sea, estrellas quebradizas, y también erizos de mar. Vamos a movernos hacia la cima de este pequeño monte para investigar si vemos algunos corales que nos interesen o algunos moluscos como gastrópodos que también son característicos de este tipo de hábitat. Y bueno, espero que disfruten. Yo soy Olalis Cabriti de la Universidad de Costa Rica. At the beginning of this dive, we were collecting some push cores that is for a kind of to study the sediments. It's a sample of the sediments in a tube. So as you see, this is mostly muddy bottom, and it's very interesting to study the sediments. So in the sediments, we will study bacteria, fungi, and other types of interesting animals like foraminifera that can give us an idea of the age of that substratum. Al principio del buceo nosotros sacamos unos que se llaman push cores, que son unos núcleos, es decir, se mete un tubo y en ese tubo se saca una muestra del barro vertical en el substrato, y ahí se pueden ver las capas de diferentes tipos de sedimentos, y también se estudian ahí algunos organismos con los que incluso se puede hablar sobre el tiempo que tiene esta zona, el origen que tiene. y también se van a hacer análisis de microbios, o sea, de bacterias, de hongos, ya que estos sustratos son muy muy ricos en bacterias y hongos, casi que es la parte predominante de este fondo marino. Aquí estamos a 2.780 metros de profundidad. Disfruten esta vista, que es algo que normalmente nosotros no podemos apreciar, ver el fondo marino a esta profundidad donde pensamos que nunca hay nada, y vean la cantidad de vida que hay. Y si nos ponemos a pensar sobre lo que hay en ese sustrato lodoso, todavía son miles de millones de bacterias y de organismos pequeños que nosotros no podemos ver a simple vista. Is that a crab? Yes, this is very nice. We collected one last time.
I think so, yeah.
Yeah, one very nice.
Yes, ma'am. Not that I'm aware of. What is this area that it comes to? What is this?
Wow, yes, María, eso. Eso blanco. Okay.
Those are like
What is that?
calcium carbonate casinos. I know it's not a thing. That's a thing.
Calcium carbonate. Sí, calcium carbonate.
Eso que estamos viendo ahí son como agregados de carbonato de calcio. Aquí el piloto J. Road nos está instruyendo sobre esto. We are seeing some calcium carbonate substrate, this white thing that you see there. And it's interesting because our pilots already know very well this kind of structure. So J. Road was telling us this is calcium carbonate mountains. So it's very, very nice to have this collaboration also from our pilots. Estaba contando que los pilotos J. Road y Tyler se hacen ven muy familiar los fondos oceánicos porque pasan muchísimas horas ahí y ellos ya empiezan a reconocer estructuras, incluso nos ayudan muchísimo a nosotros y son súper orientados en el fondo, y mucho de lo que logramos es por la experiencia que ellos tienen. Is it very far?
It's very possible, yeah.
Yeah, but we better finish now.
Let me know quick.
Okay.
Go get it?
How far are we from?
We're not far. I can turn around quick. Yeah.
Okay, so do it.
At the bridge.
Thank you. You're welcome. Okay.
Coming to a slow stop.
Appreciate that.
Anteriormente vimos otro hueso, un fósil que en realidad no sabemos qué es, y aquí María Sandoval, nuestra paleontóloga, está pidiendo que lo recojamos. Entonces vamos a devolvernos un poco hacia donde está el fósil para recogerlo.
Isn't that a piece of coral? Or is that a sponge? Is that a sponge? Looks like a sponge.
What is sponge?
Yeah, that's sponge.
No.
Sorry to bore you. I'm good with the marker.
Good-ish.
What is that? It's a Dumbo octopus.
We break for Dumbos.
Wow. Ese es un pulpo Dumbo que le dicen por esas estructuras que tiene en la parte de arriba de la cabeza, que parecen unas orejas. Estos hemos visto varios. Empezando el buceo vimos uno, son espectaculares, como lo pueden ver ahí.
No interest in the Dumbo, like no possibility of wanting to sample or anything, right? That you're aware of?
No. No, we're okay with that.
Right, then
Yeah.
well, I'm forced to this
Yeah.
way too much for my Dumbo. We go.
Okay. Do you feel the current when it is current there moving the
Oh yeah, how fast that guy was going.
Okay.
Like where I stirred up this was further down the road than this, and it's already gone from there. And that guy just stayed with it the whole time. I remember seeing that white crack back there. It was. That's one of the ones before that.
Yeah, the US Gulf Coast. It's not as far away as
This one was just before that, 'cause I was like, was that another one? one, correct?
Yes, it is. Wow, this is amazing. Okay. Bueno, ya llegamos a donde está la muestra, el fósil que queremos recolectar, y entonces vamos a proceder a recolectarlo.
Can you all get some photos quick before the disc goes?
Close and the.
You got that photo?
Yeah. Did you take the picture? The graph?
Yeah, hurry up before the disc gets hit.
Okay.
If it does.
Ready?
Yeah, and
Good.
yeah, and a close up of the octopus. Haga un grab ahora, porfa, cuando lo enfoque.
Only get in focus.
Yeah, listo.
Yeah, thank you.
There you go.
Yes. Maybe when we collect it, it will be a chance to do a very close up. Thank you. En esa estructura que vamos a recolectar también están varios otros organismos. It's so cool. It has many colors and that. Estaba diciendo que a veces vienen muchos organismos y digamos en este caso vamos a recolectar unas esponjas que están ahí pegadas, unos pequeños hidroides como una plumita que ven a la parte derecha de la estructura, y viene una ramita que ven ahí con unos pólipos. Eso es un octocoral del grupo de los corales bambú, y eso también, todo eso lo vamos a traer en una misma muestra. Además se ven algunos tubos, tal vez son unos gusanos, y también ahí vienen, cuando se está tomando la muestra, hay algunos carbonatos que se van a venir pegados a la estructura esta, donde va a ser posible hacer algunos otros análisis geológicos.
Pues también dice si quieres que le tome grabs.
Sí, tomen. Cada vez que vea que alguien con una cosa cercana lo toma. Ahora el usuario está ahí. Mira, es un usuario, es un usuario, el que está ahí en la punta.
María dice que si pueden agarrar con la cuchara un poquito de sedimento
de ese blanco, es que yo creo que ahí viene un poco. ¿Ves que están agarrando ahí un poco?
Eso es lo que ella ocupa para poder datar el sedimento. Yeah, she wants to put an age to the sediment as well.
Take a grab when it is in focus.
Sí, ya tomé una.
Ajá, and that's one. Looks like a sponge, yeah, I think.
Sí.
How's that?
No, ese es el lícido, esto es de...
Si le dio tiempo a la otra, para poder tener un coral clear.
Otra muestra de sedimento del blanco.
Del blanco, pero justo por acá.
Okay. Okay, after this, if it is possible to scoop a little bit of the white carbonate in the same place.
Okay.
I think there is some in the sample. There is some in the sample.
So you want that?
Yes. We want the one that is in the sample, but Maria asked for another scoop, maybe, if it is possible.
You want a push cord on it?
The cord?
No, push cord.
No, push cord. You have all the push cords already.
No, there's two more left.
No, she was talking about the scoop, not a push cord.
About the scoop, yeah.
Not the push cord.
Yeah, I mean, we can do a scoop. I was just asking if you want
No, pero en la misma B3B.
What is
No,
faster?
espérate, no han decidido.
Scoop,
Sí, 3B.
Yeah, I mean, if the same for you,
PB3A.
you can do
A or B?
It's the same
No.
amount of time.
Ah, BB3B.
B.
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 B. Okay.
I think this piece it works the white stuff within the arm.
Ujú, ahí viene.
It's a piece, right? It's a white piece there.
Sí, ahí viene. Pero si vos querés otro poco, ellos pueden sacar un poquito de esto mismo, pero echarlo que en un quiver o ahí mismo.
Pero ¿por qué estamos usando el Biomax por eso?
Mae, porque esta vara es muy grande. Digo,
Nos va a cagar la jefa.
no. Si vos querés un bioax para eso, aquí no hay tantos organismos.
Ah, bueno,
The
okay.
coral, just so you know, went into Biobox 3A.
Ah, this is attached from the. Okay.
But it's in 3A.
In
The coral?
3A. In 3A is the bamboo coral,
Yeah.
and in the other one is the phosphor.
¿Qué hago? Should I give another sample number?
No,
Yes,
they're all really going to be the same
No,
Biobox here in a second.
Okay, I'm going to keep it the same. We will see.
Keep the same number.
Same.
For the
same
sample number?
Yes.
One.
Just keep it the same.
No.
Okay.
They came from different locations.
Oh no, they're talking about the bamboo coral that just fell off of
Oh,
that.
sorry.
No,
I
it's
thought
because
you
the
were
coral.
bones, and I was like,
No.
Sorry.
Okay.
The thing is that the
No,
bone-
keep the parent. The parent number
Ajá.
es el que vamos a mantener para los
Sí,
dos.
sí, sí, sí.
Después le damos otro número, pero ponga la nota.
Go grab some more dirt.
You can add.
You want more of that white dirt, right?
Yes, please. And if you can put it in the same.
In the same?
Yeah, we can. Yeah. Like
No se
that.
va eso.
No, because it's the Biobox. It would close.
Okay.
In the Biobox, right?
Yeah.
It is not going out from the bottom.
Yeah, he's just going to grab another handful of it. That'll go in like that. And just,
Entonces,
you ever used an estimator before?
I have not.
Well, this is what it's like.
Alright, I like that.
Fix it. I don't know, this one's cheaper, probably this.
Then you're in a sandbox.
pero lo metemos en
What's the regular estimator? Probably less than this one.
B3B.
pero no había
Había otro propósito, pero sí. Sí, sí.
¿Qué número le dice?
A este,
Al de
167. 167 y el pasado era 165.
Sí, aquí están ahora los dos.
Y el coral mantiene 167, pero
Pero
cambió
está a
de
la
lado.
par. Ajá.
Yes.
Yes.
We'll restart the stream. We'll have to restart the stream as a time if you'd like to go to Spanish, then I could do it in English. Just, that will return in a few moments. Part two.
Vamos a hacer una parada un momentito y volvemos, volvemos dentro de poco, nada más vamos a cortar por un momento. Esperen a que regresemos, gracias.
You want to go back in there? That's that spot they use for septic traps.
Hello, everyone. We're just going to be restarting the stream here, but join us back in a few moments for part 2.
No importa. Ajá. Yo creo que mejor que lo echen al frío, ¿no? Se puede salir.
Seguro que le llamaría, sí.
Do you think